Hi everyone, welcome to Simplilearn's YouTube channel. Our topic for today is Tableau Full Course. In this full course, we will be covering a brief introduction to Tableau. Then we begin with the Tableau tutorial. Later, we will understand the functions in Tableau. Advancing ahead, we will learn the parameters in Tableau. We will learn how to get connected with data. Next, we will understand the LOD expressions in Tableau. After LOD expressions, we will dive into the data blending in Tableau. Once we are done with fundamentals, we will get started with charts in Tableau. Later, we will learn to design a dashboard in Tableau. Once we are done with charts and dashboards, we will get started with some projects in Tableau. Finally, we will go through some important interview questions in Tableau. Hope we are good with the agenda for today's discussion. Now, let us begin with the session.
So what is Tableau? So before we understand what exactly is Tableau, let us imagine a simple situation. Imagine that you're an office worker and you get some loads of data, maybe like millions of rows or billions of rows, and you are supposed to extract the insights of that particular data. So what do? You basically load that data into a database and try to write the SQL commands and then try to extract the insights of that particular data. So this kind of approach is basically time consuming and you get exhausted. Now, what if you had a tool which could write all the SQL commands for you in the background and all you had to do is just to drag and drop the data? Sounds interesting, right? So Tableau is just the same. All you have to do is just drag and drop the data and it will automatically write all the SQL commands you ever wanted to write on that particular data, and it will give you live data interactions and advices for the future. Now with this, let us understand the definition of Tableau. So basically Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize, and make data-driven decisions in real time with extreme agility and accuracy. Now with this, let us continue with the next topic, which will be about the various versions of Tableau. So at first, we have the Tableau Desktop. So Tableau Desktop is a data visualization application to facilitate you to examine virtually any kind of structured data and generate highly interactive, beautiful graphs, dashboards, and reports within minutes. Once a quick installation, you can tie to virtually any data source from spreadsheets to data warehouses and display information in several graphic perspectives. Designed to be easy to utilize, you'll be working more rapidly than ever before. Next, we have the Tableau Server. It is a business intelligence application that offers browser-based analytics anyone can utilize. It is a rapid-fire alternative to the slow pace of traditional business intelligence software. It is an online solution meant for sharing, distributing, and collaborating on content created in Tableau. What makes Tableau different? It is proposed to everyone. There is no scripting required, so everyone can grow to be an analytics expert. You can grow your deployment as you require it. Train online for free, find answers in minutes and not in months. That's the speciality of Tableau. Now followed by the Tableau Server, we have Tableau Online. So Tableau Online is a business intelligence application that offers browser-based analytics anyone can utilize. As discussed before, it is a rapid-fire alternative to slow-paced traditional business intelligence software. So Tableau Online is a secure cloud-based solution for sharing and collaborating on Tableau views and dashboards. Next up, we have the Tableau Public. So now I want to give you guys a serious heads up if you're a beginner in Tableau. Tableau Public is like an open source. Whatever the data you choose to work on using Tableau Public, it goes to public. So kind of like Tableau Public is not preferable if you want to work on your company's sensitive and confidential data. Tableau Public is a free software to facilitate anyone to get connected to a spreadsheet or a file and create interactive data visualizations for the web. It is delivered as a service that permits the user to be up to and running overnight. With Tableau Public, users can construct amazing interactive visuals and publish them quickly without the help of programmers or IT. It is designed for organizations to facilitate their websites with interactive data visualizations. There are higher limits on the size of data you can work with, and among other features, you can keep your underlying data hidden. And lastly, we have Tableau Reader. Tableau Reader is a free desktop application that you can use to open and interact with data visualizations built in Tableau Desktop. With Tableau Reader, you can filter, drill down, and discover humongous loads of data. Now moving ahead, we have the features of Tableau. So these are the few important features that you might want to consider. Those are the first one, robust security. Tableau takes special care of data and user security. It has a foolproof security-based authentication and permission systems for data connections and users access. Tableau also gives you the freedom to integrate with other security protocols such as Active Directory, Kerberos, etc. An important point to note here is that the Tableau practices low-level filtering, which helps in keeping the data secure. Followed by that, we have the collaboration and sharing feature. Tableau provides convenient options to collaborate with other users and instantly share data in the form of visualizations, sheets, dashboards, etc. in real time. It allows you to securely share data from various data sources such as on-premise, on-cloud, hybrid, etc. Instant and easy collaboration and data sharing helps in getting quick reviews or feedback on data, leading to a better overall analysis of it. Another extremely useful feature of Tableau is the use of time series and forecasting. Easy creation of trend lines and forecasting is possible due to Tableau's powerful backend and dynamic frontend. You can easily get data predictions such as a forecast or a trend line by simply selecting some options and drag and drop operations using your concerned fields. Next up, we have live and in-memory data. Tableau ensures connectivity with both live data sources and data extraction from external sources as in-memory data. This gives the user the flexibility to use the data from more than one type of data source without any restrictions. You can use data directly from data source by establishing live data connections, or keep that data in memory by extracting data from a data source as per their requirement. Tableau provides additional features to support data connectivity such as an automatic extract refreshes, notifying the user upon live connection fail, etc. Next, we have informative view and even the mobile view. One of the key features of Tableau, and the one that got its popularity, is its wide range of visualizations. In Tableau, you can make visualizations such as bar chart, pie chart, Gantt chart, bullet chart, motion chart, tree map, box plot, and many more. Like you name it, Tableau got it. You can select and create any kind of visualizations easily by selecting the visualization type from the Show Me tab. Apart from that, it is capable to represent data in mobile view as well. Tableau acknowledges the importance of mobile phones in today's world and provides the mobile versions of Tableau app. The next and the last feature is that being capable of accessing data from various kinds of data sources. Tableau offers a wide range of data source options where you can get connected and fetch data from data sources ranging from on-premise files, spreadsheets, relational databases, non-relational databases, online cloud data, data warehouses, and many more. So followed by the features, now we'll discuss about the advantages of Tableau. So following are the advantages of using Tableau. First one, it has remarkable visualization capabilities. Of course, the unparalleled capabilities of visualizing information is on top of the list of Tableau's software benefits. Followed by that, we have the ease of use. The tool's intuitive manner of creating graphics and a user-friendly interface allows non-developers to utilize the basic app's functionalities to the fullest. Users arrange raw data into catchy diagrams in a drag-and-drop way, which facilitates information analyzing and eliminates the need for the help of IT department and pattern building. Next, high performance. Apart from its high visualization functionality, users rates its overall performance as robust and reliable. The tool also operates fast on big data, which makes it powerful performance on an important point on the list of the advantages of Tableau. And next is the mobile friendliness. One of our best advantages out of the Tableau benefits is its efficient mobile application, which is available for both iOS and Android. It adds mobility to Tableau users and allows them to keep statistics at their fingertips, as well as supports their functionality that desktop and online versions have. And finally, we have the thriving community and forum. Tableau has a rich community. The number of Tableau fans who invest their expertise and skills in the community is increasing rapidly. Business users can beef up their knowledge on data processing and reporting and get many useful insights in this community. Also, forum visitors are ready to help settle any user issues and also share their experience. Next up, we have the disadvantages of Tableau. The first major disadvantage is the high cost. The Tableau is not the most expensive visualization software, especially compared to such business intelligence giants such as Oracle's and IBM solutions. All the same, the license is quite costly for small and medium companies, which makes it one of the considerable Tableau's disadvantages. Next is the inflexible pricing. Tableau's sales team is not flexible enough to provide case-by-case approach for their customers, ignoring the fact that each company has its own unique requirements for visualization tool package. The Tableau sales model requires clients to purchase and extend license from the start. As a result, a lot of companies that use Tableau arrive at the conclusion that they don't need all their licensed features. They would prefer to buying a set of requirements and scale them if necessary. Followed by that, the next disadvantage is poor after-sales support. On multiple message boards, users complain that Tableau software lacks proper after-sales maintenance. If customer has software performance problem, the support team does not settle the matter by investigating the problem's root and eliminating it. Next, we have the poor BI capability or the poor business intelligence capability. As previously mentioned, the tool provides best-in-class information visual interpretation. However, it lacks the functionality required for a fully fledged business intelligence tool such as large-scale reporting, the building of data tables, and statistics layouts. And lastly, the poor versioning. Only the recent Tableau versions support revision history, while for the older ones, software rolling back is impossible. Now, with the advantages and disadvantages discussed, let's move into the top companies hiring. The companies which are desperately looking for Tableau experts are Accenture, EY, PepsiCo, Deloitte, Wells Fargo, Capgemini, and many more. Now let's discuss the humongous and handsome salaries offered by these tech giants. So according to Glassdoor, the average salary of a Tableau expert in America is 82,000 grands, and for a beginner it is somewhere around $60,000 per annum, and at the highest rate it is $110,000 per annum. Similarly, the average salary of a Tableau expert in India is 5,06,000 per annum, and for a beginner it is somewhere around 3,60,000, and for a highly skilled, experienced Tableau expert, the salaries range from 8,75,000 per annum.
Here's a story about these two gentlemen talking about Tableau. The first gentleman comments on how the IPL Cricket League was very entertaining this year and how he believes that de Villiers scored the maximum runs. But the second gentleman says he has stats which shows that Kohli outperformed this time. How did you come up with these stats? There's a tool that helps visualize data by creating interactive charts and graphs. It's basically a business intelligence tool used by many organizations for visual data analysis. Tableau helps us gain insights by visualizing the data that you already have. So Tableau is important when it comes to visualization. It has many advantages. First, it has speed of analysis, so you can get into your data and start analyzing it very quickly. Second, it helps users be self-reliant and not rely on very difficult analytics tools to start digging into their data. Third, it allows you to do visual discovery, so as you're building, you can learn information and insights about your data. 4, you can use it to blend diverse data sets. And 5, you can use the data sets that are centralized, so after you've put together a data set, you can publish it out and more people can use it than just you. That sounds interesting. How about we visually show the stats of IPL? So first, we'll look at connecting to data. This will be the first step in Tableau. So if you've opened up your workbook and you see this page, you can click here, Connect to Data, and we're going to choose a text file, and we're going to join our deliveries data to our matches data. So when we click deliveries, it brought in deliveries, and we can click Add and bring in another text file called matches. Next, we'll talk about joins. We will make use of joins when we have multiple data sets to work with. Suppose we want to join these two data sets, one of which has a team ID and what city that team is in. The other one has a team ID and tells you the name of the team. There are 4 ways to join data sets. An inner join, the resulting table contains values that have matches in both tables. So we can see here that we have Delhi and the Delhi Daredevils. We also have Chennai and the Chennai Super Kings. We have Bangalore And then we have this team that doesn't exist in Bangalore. And so, since these two don't match, since we have 2, 2, 3, 3, but then we have 4 and 6, these two don't exist in our resulting table because they don't have matches in both tables. In a left join, resulting table contains all values from the left table and the corresponding matches from the right table. So we have Delhi, Chennai, and Bangalore, and then we have their matches. However, Bangalore does not have a match, so it is left null. In a right join, we have the opposite. The resulting table contains all matches from the right table and the corresponding matches from the left table. So we have the Daredevils, the Super King, and then we have King Punjab, and they all exist. However, number 6 does not have a corresponding city, and so that's left null. And in a full outer join, the resulting table contains all values from both tables. So we still have Delhi and Chennai, and we have Bangalore, and we have the Kings, but their corresponding nulls exist as well. So since this one doesn't have a match, it still shows up, but you get a null, and then this one doesn't have a match, it also still shows up, and you get a null. Now it's going to allow us to join our two different data files together. So we have to decide which field to join on. In this case, it is match ID. And then on the matches, it's just called ID. And that is ID. We'll do an inner join that will select only the records that match between the two fields. So it's given us some sample data underneath from our two things. And we look at match ID here, and where it's 1 here, we'll scroll over and see that it's 1 here for ID. If we scroll down and find a different number, so here we have 2 for ID, and we scroll over and match ID is now 2. And we have our join in place. Dimensions and measures. Dimensions are qualitative fields that cannot be aggregated. For example, batsman and batting team, etc. However, measures are numerical values that mathematical functions can work on, like batsman runs and extras. So for the case of batsman runs, you can sum up all of the runs for an entire game, or that took place in a city, or for an individual batsman, and that's how you can tell that it works with a mathematical function. Now we'll move on to the last part of dashboard designing. So we can move on to sheet 1. I will take a second and load our query. And now we have the worksheet space, and this is where we can build our visualization. This is called a worksheet. You can also build a dashboard, which is where you can put multiple worksheets together. And you can build what's called a story, which is where you can take worksheets and dashboards and put them in an order to tell a story. So on our worksheet, we'll have this space here in the middle, which is where you can build the visualization. You have columns and rows where you can drag on your data, which is here on the left. Here's our data, dimensions on top, measures on bottom. We'll talk a little bit more about that in a second. We have columns and rows where you can drag your information, and it defines where the columns go, or where the data goes to define the columns, and where the data goes to define the rows. We have places here, these are our cards, and when you drag things onto these different cards, it will do different things to your visualization. And let's talk about our dimensions and measures. So Tableau will take its best guess at what your data is. So it's guessed that all of these blue fields on the top are dimensions, and dimensions are qualitative data, so data that defines and describes the rest of your data. And so usually it can be things like city, so you can say here's a city, and then we can look at our different measures by the city that it took place in. For example, with financial data, you could pull on city and you could look at sales by city, and city is the dimension, which is a quality. And then sales would be a measure, which is something that is quantitative and it is able to be aggregated. Whereas dimensions are not things you would like to aggregate. So some things can be a number, but they're still not a measure, such as a phone number. Nobody is going to want to sum up different people's phone numbers and see what the sum of the phone number is. However, you might want to look at a customer and see their phone number, and it puts it up in the dimension area. Another thing that Tableau does in this case, by default, it will make little folders for your different data sources. So we have our deliveries data source and our matches data source. If we go back to our data source section, that corresponds to our two different files. You can also look at these sample fields here, and the part where it's blue at the top represents the blue table. And if we keep dragging, we'll see the orange coming in, which represents the orange table. So here we are back at sheet 1. And let's start building our first visualization. I'm going to right click here, click rename, and we're going to call it matches in each venue. So we're going to start off by making a map. Tableau has recognized the word city here and put this little globe next to it, meaning that it has recognized it as having the geographic role of city. So if I double click on it, it maps out some cities. Now it's having a hard time mapping the cities, so we're going to click edit location, and it doesn't recognize these places, or it could exist in multiple places because it's defaulted the country to the United States. So if we change that defaulted country to India, then we have much fewer unknown fields. So we're going to focus on India and not look at these other locations because some of these are not in India, but we're going to make this visualization for India specifically. If you wanted to show what countries they were in, you can define from what field you can find the country information. So if we had two fields in here, one was city and one was country, that told you what country it was, then you would choose this from field and you'd choose that country dimension, and that would fix our problem, assuming things were spelled right and put in the right countries. In this case, we don't have country, so we have defined India, and that's where we're going to focus. Next, we're going to bring city onto color as well. And now they each have their own colors, and here's our legend. And we want these to have a different size based on how many matches they've had. So we're going to bring on ID onto size. And we want it to actually count those IDs. So we changed it to a count distinct. And now you can see the littlest ones have around 2, and then as they get bigger, this size is 20 and this size is 85. And when you hover, you can see exactly how many they have. You can adjust the size using this size marks card. Make our circles a little bit bigger. We can adjust our color by adding a border, maybe like a black border, but then changing the opacity so we can see through it a little bit for those that go over borders and start to overlap. And if we wanted to see the exact number without having to hover, we could take this ID onto label and again change it to count distinct. There we go. And now you can see exactly how many there are in each location. You can change where the labels show up by adjusting the alignment, so we could have it in the center and it kind of shows up inside their circles, but that's kind of hard to read in these smaller circles. So we could define that we always want it at the top or something like that. We could also have it say the city name. So if I drag city onto label, now it shows 9 and then the city, but if I want to change the order of that, see how it does the count and then the city? I could drag So you saw right inside of here we have 2 that are on label, so they have this little T inside of a box. And now city is on top of count of ID. So city and then count. We could also allow people to filter. So if we click show filter here, and if we just want to look, it'll zoom in on the countries you select. So if we just wanted to look at a couple of them, then we could select individual ones. Or if we wanted to exclude certain ones, then we can make it easy to exclude. Great, so now we have our visualization for matches in each venue. Next, we're going to make another worksheet by clicking down here, and we're going to name this one Top Run Scorers. And this will allow us to be able to find who scores the top runs. So we're going to make a visualization called a tree map using this Show Me button. We haven't explored Show Me yet. Show Me will show you what visualizations you can build based on what you've selected over here. So when we selected city, it shows us that we can make maps using city. What we're going to do is look at city, and I'm going to hold Control and click Batsman, and I'm going to hold Control and click Batsman Run. And now you can see that tree map is filled in and not grayed out anymore, so we can select that. And it is showing us what batsmen have the most runs. We want the color to be based on city, so let's drag city onto color. And now we can see that it's separated out by city. And you can see that the person at the very top right with the biggest square has the most runs. But then you also get a second benefit of being able to know which city seems to have the most runs associated with it. So it looks like Mumbai has the most runs. Let's also filter this information. So let's bring on batsman runs, and then we can choose sum. And let's filter out batsmen who didn't get a total of 400 runs. There we go. So now we only see batsmen and cities that have a sum bigger than 400 runs. Okay, so we have city on label, but maybe we just want to be able to see that on hover. So we'll take city off of label, and now we just see the batsmen who have the highest runs for each city. And we'll also bring on the number of runs onto label. So now we can see the batsmen and their runs and exactly how many runs they have. You can always get to how many they have based on hover. We'll go on to our next visualization, and that's going to be win percent based on toss decision. So we're going to see which decision you make based on the toss leads to a win more often. So you can choose to bat or you can choose to field. And if you choose to bat, do you win more than if you choose to field? So let's take a look. We have our toss decision, and we also have if they won the match or not, match winner. And I'm going to control click toss decision, and we're going to select pie. So here we have a pie chart that colors it based on toss decision, which is bat and field, and makes the angle and the size of the circle based on the match winners. Now we're only going to have the angle be based on match winner or not, and then we can define the size ourselves so we can make it bigger. I'm going to change this visualization to fit the entire view so that we can see the pie better. Great, but we don't see a percentage. So let's change this sum of match winners to a table calculation. So we're going to click Add Table Calculation, and we're going to change it to percent of total. We'll close that. So now when we hover, it says 60% of the matches were won by the people who chose filled, and 39% were won by the people who chose bat. Let's make this into a label as well. So I'm going to Control drag toss decision onto label, and what that does is make a copy and add it to label instead of pulling it off of color. So let's see what happens if I don't hold Control. So if I just drag toss decision onto the label, it got rid of it off of color and just put it on the label, and that's confusing. There's two pieces, but they don't look any different. So Control drag fixes that. We'll do the same thing for that match percent of total that we made, match win percent of total. One of the benefits of having these labels here is that it allows you to be able to use this visualization even if you take a screenshot and send it to somebody and they can't hover over the top and see what everything means. Another thing you can do is annotate it, and so we can click annotate the point or the mark, and it will give you this box, and then it will put in some information that's showing up in your tooltip, and you can modify this, and we could change this so it's not bold anymore or leave it bold. And when you hit OK, it makes this box that you can move. Tells you information about that point or that mark. We can do the same thing here. And it draws a line. And this allows you to put notes about it. You can see that these parts are dynamic, so it just fills in toss decision based on your field from over here, and it will change if it changes. So will the percent match winner. So for example, this is for everybody over all time, but if we show a filter for city, it adds it to our filters card up here, and then we could filter it to just this city, and you can see that they have updated. And in this city, they have more people who have chosen to bat win the game. And so you don't end up with old static information in either place. But if you did want to make a note manually about what you think is happening here, then you can do that as well. We could also do the same thing with date. And now you could choose just what year you want to see, so just 2017. And in 2017, the field advantage was a lot higher. And here's 2016. And that's all time. Our next visualization is going to explore the idea of if you win the toss, how likely you are to win the game. So we're going to look at historical data and see what's happened in the past. So we're going to call this advantage of toss winning. So we're going to bring on all of the toss winning teams, and we're going to also bring on all of the teams that actually won. So how it works is we can see all of the teams, and then you can see if they won or not. So we're going to quickly make a couple of changes to this. The first one is this team changed its name to this team name, so we're going to group those two teams into the same group so that they are treated like just one. And we're going to create a group based off of winner. And we're going to grab the two team names by control clicking and click group, and it puts them together. Let's replace winner with our winner group. There you go. So now you can see those two teams are together. Do the same thing with toss winner. Create group. One disadvantage to creating a group is that it's very manual. And so you have to manually create the group and you have to manually update it. So if they change their name again, you have to change it again. And it's nice to have the functionality in Tableau to make those changes in case you don't have the functionality to make the changes to the data source itself. But do keep in mind that if you have to manually group things together, you have to manually keep it updated as well. Next, we're going to exclude some data. So we have this null here that we'll just click exclude on, because that would be perhaps when a winner was not declared. And we're going to remove some of these teams that have holes in their analysis. And that could happen because they didn't play all of the teams, or so there was never a match with that team. And so here, for example, they played and they could have won, or this team could have won, this team could have won, or this team could have won. But these other teams don't seem to have any matches against them. So we can come across here for the winners, and I'll control click the teams that we're excluding, and then we'll just come over here to exclude, and you can exclude a bunch at a time. It just adds it to the filters right here. So if I right click on edit filter, you can see all the teams we've excluded. And then we'll do the same thing on the toss winners. And we'll control click and exclude. And now we are left with all of the teams that seem to have available data between them. And now we want to see, of these toss winners, who won the game. So we're going to count all of the matches, and that will give us the information we need. So I'm going to grab ID and put it onto text. Now what it's doing is giving me all of the IDs. So I've got to right click on it and change it to a measure, and change it to count distinct. And now it will show you how many matches fit these categories. So for this team, if they won, when this team wins the toss, then this team usually wins, which is the same team. So I'm going to widen this out so we can see the names better. So when the Super Kings win the toss, the Super Kings won the game 42 times. Let's right click here, and we're going to change it to a table calculation again for percent of total. And what that is saying is that of all of the games where the Super Kings won the toss, they also won the game 64% of the time. Now you can read this with the numbers fairly easily, but it'll be a lot easier if we can also show it in color. So I'm going to change the marks to square. And I'm going to control drag this onto color. And now we have what's called a heat map. And the color is stronger where the percentage is higher. You can see our range over here. So you can see there's a pretty clear advantage to the person who wins the toss. They tend to be the one that wins the game. When the Daredevils win the toss, the person who wins the game the most is the Daredevils. Let's take this visualization and use it to analyze a different feature of the game. So I'm going to right click on the worksheet and I'm going to click duplicate. So now we have the same visualization twice. And I will rename it to be called batting first advantage. So here, instead of toss winner, we're going to bring on batting team. But let's first create a group again. So we're going to, don't be confused by group by, that's not the same thing. We'll go to create and click group. We're going to put together, control click the team names that have merged. Okay. And let's drag. You see how it's not up here right next to batting team? That's because they put the calculated fields that we've been making outside of the folders. So if you're looking for a calculated field, you can scroll down to the very bottom. And let's drag batting group right over top of toss winner. And it will replace it right out of there. And we have our gaps again, because the toss winners that we excluded only applied to that toss winner, so I can pull off this toss winner filter. We don't need it anymore. And then we will control click on the ones with the gaps that we wanted to remove. Click exclude. Okay. And now we have an analysis showing how the batting team does. In our next visualization, we're going to explore who the leading batsman is. And this could allow you to find out who's the best if you were in charge of putting together your team. So we can take all of the batsmen and put it on rows. So now we have a list of every batsman. And we can bring batsman runs onto columns, and it will sum up all of their runs. Now what we can do is sort it from biggest to smallest, and we can see who are our top batsmen. We can bring batsmen onto color, so I'm control dragging again. And then they each get their own color. One nice thing that you could do here is filter it by the team. So here we have like team 1 and team 2, but what we would be doing is filtering it on batting team. So we're going to click show filter. And so if you wanted to see, well, like this is the best overall, but let's see who was the best to ever work for this team. And then it will sort it from best down. And you can switch the team. And if we choose this one, we should choose this one as well. And then we can see who's the best. Another thing that could be really useful is seeing who's the best by year. So we can come here to date and click show filter. And now we can see this is the best overall of these years. But if we just want to see most recently who's the best, that's a very different story. So filters can be very handy for looking at a bar chart here and getting the exact information you want. We could also maybe just look at the top 5 batsmen. So what we'll do is we'll drag batsmen onto filters, and we'll create a conditional filter based on top here by field. So we'll say top 10. We wanted to look at the top 5, so we'll change that to 5. And we're looking at the top 5 batsmen based on the sum of their runs. So you could choose something else to filter it by, but we want it to be based on their runs. And we hit apply. And there we go, we just see the top 5. And again, if you just want to see the top 5 for 2017, here's the top 5 for 2017. Maybe 2016 and 2017 together, those are your top 5. Now, if we wanted to be able to change how many we see, as the developer, we could go in and change it here. But if we wanted our end user to be able to change it, then they can't, because when this is published, you can't change your filters. You can't change the filters that are the top conditional filters. We can change these filters that we show on the report called quick filters, but not this guy. You can see, we can see now that it's choosing top 5, but we can't select it. How many? So let's get rid of that card. And let's make a parameter that will allow them to select it. So create a parameter, and we're going to call this top n. We're going to make it an integer, and it's going to be a range. We'll let them choose between 5 and 30, and they can go up and down by 5. We'll click OK. So now we have here at the very bottom parameters, and we can right click on it and click Show Parameter Control. And now we have this parameter over here called top n. It's set to 5, and then if I change it to 10, nothing's happening. And that's because we made the parameter, but we haven't put it anywhere in this sheet. So we're going to put it right inside of this filter. So you come here, and we want to choose top how many? You can do it based on a parameter, and we'll do it based on our top n parameter. Okay, so now when we change it from 5 to 10, the parameter updates the filter. So in presentation mode, the user can come in and choose how many they want to see. Now we've only let them go up to 30, but that's to your discretion. You could have this parameter do whatever you need. So we could say they can go up to 100, and that changes our parameter. Now we have all these little marks in between, and here I chose 80, 55, or you could even make it so that they don't have a step size. They just have a range, and then they have just this little slider, and it could be any number in between, but not lower than 5 and not bigger than 100. Let's remove this filter, and we will also hide this card because we won't give them the option to choose how many they want to see in this case. We'll just show them all. So, for this next visualization, we're going to look at our top 5, and we're going to see how they do over time. So again, we're going to start on by bringing on our batsmen, but we only want to see our top 5, so let's bring batsmen on the filters, and we'll do what I just showed with top 5. Now, since we don't have anything else on this visualization, it's not sure how to define the top 5. So we're going to do it with batsman runs, and we're going to have the sum of the batsman runs. So top 5 players over all time that have the highest sum of batsman runs. Highest sum of runs. So here we have them. And we're going to bring on their runs, and we'll sort them biggest to smallest. And next we're going to bring on a time element so we can see it over time. So I'm going to drag date over here. And now it's doing a line chart for with a dot for every year. And I'm going to change year from the discrete year to the continuous year so that it's an axis down here. And now we can see that over time. We can bring batsmen onto color so we can see the different color for each batsman. And here's how they're trending. And then we'll also bring the batsman runs onto label. And now you can see how many runs they had. Next, we're going to take a look at finding out who our leading bowlers are. So let's bring all of our bowlers onto a visualization. One way to look at this would maybe be to see which bowlers have the least runs associated with them. So we can bring the runs up here and then sort it smallest to biggest. However, they could have very few runs associated with them because they don't bowl very often. So let's bring on match ID and change it to be a measure that is a count of match IDs. And we can see that a lot of these with the least amount of runs also have the least amount of matches. So it's not a very good indicator. We have here what's called a dismissal kind. And you can see the reasons that the batsman was dismissed. And one of them is hit wicket. So you can see any of the bowlers that hit the wicket. So let's bring dismissal kind onto filters, and we'll just look at those that hit the wicket. So we have these ones that have hit the wicket, and let's see how many times they did that. So we'll actually bring on down here number of records. and we'll sort it biggest to smallest. So now we can see that this bowler has hit it twice in our limited set of data. If we include all of the dismissal kinds, except for null, so this means that they were dismissed for any of these reasons, we can see which bowlers had the most dismissals. And let's bring bowler onto color. Great, and we'll rename it. To leading bowler. And we're going to do a similar thing as we did with top 5 batsmen with bowlers. So we could start with this visualization and replace by right-clicking and click duplicate. Let's bring it to the end. And now, instead of top 5 batsmen, we can change it to bowlers. But first, let's bring in our dismissal kind and only choose the ones. So here we can click exclude, and we're going to exclude null and hit apply. So we don't have the nulls anymore, we just have the ones that were dismissed. And we're going to bring in the bowler on top of the filters, and we're going to have it be based on the top count of dismissal kind. Top 5. Great. And we'll put bowler over top of batsman. And we'll take out the sum of batsman runs. And put on our number of records. And batsman didn't get removed when I pulled bowler on top of it, so I must have accidentally pulled it in front of it. There we go, batsman's gone. Now here's a disadvantage to making a copy and then changing it, because it's like, what's happening here? But it's because batsman is still on color and sum of batsman is still on runs. So let's take number of records and put it onto runs, onto the text. And then let's take bowler and put it onto color. That clears things up quite a bit. So now we can see the bowlers over time. If we take year of date off, we can see which ones are the best overall, and we'll sort it. There we go. And then we'll put year back on by dragging date up here, right-clicking and changing it to a continuous. There we go. So now we have our top 5, and we need to rename this to top 5 bowlers. Okay. So now we have all these visualizations, and we can start putting them together into dashboards. So let's make our first dashboard. We're going to have the size be automatic, so it fills the screen here. You have some options with the different sizes. You can have it be a fixed size, or you can define the width and the height. You could also define the width and the height based on some of these presets, like a desktop browser or a laptop browser. You could have it be automatic, so it fills the space. Now this will have it fill the space on any screen, so if they're looking at a much smaller resolution, then it'll try to squish all of your visualizations into one size. So I don't recommend automatic for a lot of visualizations, because you need to have extra space. Or if you define this should be here and this should be over here, then it will all squish it all together. There's also a range where it's sort of like it's automatic and it will adjust based on what screen you're looking at it. However, there is a minimum size, and it will never be smaller than that, and a maximum size, and it will never be bigger than that. So it won't stretch or shrink your stuff too far before adding scroll bars. So here we have automatic and our first dashboard. So we're going to rename our dashboard. We're going to call it overall performance. Oh, the first one we're going to make is going to be looking at venue and run scored. Great. So this is our dashboard space. So it says drop sheets here. And then these are our dashboards. And we have other objects down here that you can also bring on. And then over here we have layout, which after you have brought things on, you can change their layout here. And it will show your item hierarchy based on how they're nested down here. So on our dashboard, we will first bring in our matches, and we will bring in our top scorers. And we have all these different places for matches, and we have our different cities for our top scorers. And so if we go back to this sheet, top run scorer, we can do that in 3 ways. We can come down and find the right sheet and click on it to go to that sheet. We can look at our visualization and click this go to sheet, and it will take us to that sheet. We'll go back. Or we can come over here to our sheets and click go to sheet, and it will take us to that sheet. So let's take our filters off of the sum of runs so that we're showing all runs for all cities. You know what? Instead, let's just edit it so it's filtering out only those that never scored more than, say, 100. Okay, so we have a lot more in here, but it will filter out some of the lowest ones. And we'll go back to our dashboard. And now there's one thing you can do, which is called an action. And so we can click use as filter. And now when we click on a city over here, it will filter the remaining sheets on this dashboard to what you've selected. So we can see how many matches have been done in different cities, and if we want to see, well, who are our best players in Mumbai, it will filter down to the top run scorer. So that's called an action. So let's get rid of that, and we'll look at doing it manually as well. So here under dashboard, we have our actions. And you can see there are no actions in here. But then when I come and click use as filter, then we go to dashboard and actions. And now we have an action called filter 1 generated. And what that has done is made an action based off of the matches in each menu sheet. And it affects the other sheet on select. And when you unselect, see it says clearing the selection will show all values. And it's doing it based on all fields. Okay, so if we wanted to make a different action, which is a URL action, on these 2 sheets, when you select, it'll take you to this website. So this is the Wikipedia beginning page. But let's say we wanted to take you to a specific Wikipedia page. In Wikipedia, if you append on the name of the Wikipedia page to the end of this URL, it will take you straight to that page. And we're going to assume that there's a Wikipedia page for all these different cities. So we have city put in there. And if we hit OK, and now when we click on a city, then it will bring up the Wikipedia page for that city. So if we come back and we unselect that, and then we come over here and we pick a different city, it'll do the same thing and bring up that Wikipedia page. So right now it's if you click on either chart, it will bring up the Wikipedia page. We can edit that by maybe changing it so that it's only when you pick it in the top scorer chart. So when you select something over here, it filters the top scorer chart, but when you select on something in the top scorer chart, it brings up that city. And that's just an example. And now it's bringing up that page on a separate screen. So there we go. Now we're back. Okay. And some more things that we can do is we'll get rid of this visualization that is a legend for how big the circles are and what that means. because we have the labels right over top of the circles, so we don't need a legend for that. We'll close that. We have the capability of filtering on city right now, but when we do filter on city, it's only affecting this visualization and not this visualization. So we can change that by hovering over Apply to Worksheets and then changing it to Selected Worksheets and clicking All on the dashboard. And when I click Show All Worksheets in the workbook, you can see the rest of the worksheets that are not on the dashboard are not affected. Unselect, okay. And now when I filter these, it does it in both places. Another thing we can do to make this look a little nicer is make this a multiple values drop down. So now it's in a drop down form. We can also a horizontal object up here and put city up inside of there as kind of like a header. But we can have some more filters. So if we wanted to be able to filter by the date, we can put the date on filter there. We'll click Use All for now. Let's go back to our visualization. We'll click on the visualization we added it to and hover over Filters. And look, you can add year of date. Here it is. Let's put it up next to city. And we'll also change it to a multiple value drop-down list. And we'll also have it apply to selected workbooks all on dashboard. Okay, so now we can see the different years. If we only wanted to see maybe 2017, they both apply. Or they apply to both visualizations there. And we can have those. And we can add a blank object over here on the other side of city so that it doesn't take up quite as much space. We could put a text object up here too with the name of maybe the whole workbook or the sheet. There it is. But if we want to edit it, then we can make it bold and we can make it big. And those are some of the things we can do to update all of our different dashboard things. Our next dashboard is the one that's going to be about overall performance. We're going to change it to automatic again. And we're going to bring in information about performance. So we'll bring in the leading batsman and our leading bowler. Our top 5 bowlers will go underneath the bowler information, and our top 5 batsmen will go underneath the batsman information. You can see that any filters we had or any different legends we had are showing up here. We don't need these legends because we have the names right next to them. So let's get rid of those. When I clicked on the bowler in that last visualization, or in the last legend, it highlighted that particular bowler. So I had to unselect it before I closed it out. Okay? And then we had batting teams filter here, which we will not use. But we will use this year filter. And now if I change it, it will only affect this visualization. But I want it to affect all. So again, this is just a good habit to have to make sure all of your filters affect everything on the dashboard that you want it to affect, and that it's very clear which ones it's affecting. Let's give it some space. We can move this whole piece to along the top here. It doesn't need that much space. And we'll change this to be a drop-down filter. And it doesn't need all of the space, so we can add some blank to either side. and have it a little bit more in the middle here. So now we just want to look at 2017. We can see our leading batsmen and our leading bowlers, but then you can't see it over time anymore. So let's change our minds, and maybe we only wanted to apply to worksheets, these two worksheets, because we want these worksheets to still show it over time. So if we click selected worksheets and we remove our top five, now we can see that these worksheets update and these ones do not. But one thing to keep in mind is that these are the top 5 over all time, whereas these 1, 2, 3, 4, 5 are the top 5 for this year. And so these top 5 are not the same people, you can see, as these top 5. Well, this one is. And this one is. But it's going to change. And so that's the point, is that it's important to recognize that these top 5 could update to just the top 5 for the year we selected if we still had it applying to these worksheets. So it's just your call. Information over time, when filtered to just one period, can be not very useful. So our next dashboard is going to be about advantage. And we're just going to make it so that we can see the advantage of the toss and the advantage of batting just side by side. So let's add a blank up here, blank down here. And it just gives you a visualization where you can see the advantage of winning the toss and the advantage of batting first. One thing that we're seeing here is that we're getting a scroll bar because it's too wide to fit in the selected area. So we could change the visualization to fit width, and then it will make this shrink to fit inside the area instead of giving us a scroll bar. We'll do the same thing here, fit width. If we change it to entire view, then it will also change the height to fill this area. Entire view. There we go. So as a recap, we have looked at different ways to look at data so that you can use it to help you in your decisions. You can use it to find out who are your top scorers in which cities. You can use it to figure out who is the advantage. You can use it to help you figure out if you should choose to go to the field or to bat. You can find your leading batsman and who should be worth more to try to get them on your team. Same with bowler. And you can put them together into dashboards that are interactive, even out to websites. Today we're going to talk about building dashboards in Tableau based on cricket data from the Indian Premier League. Please comment below for access to this dataset, and somebody from the Simplilearn team will get back to you, and then you can follow along. If you have any questions about creating a data source off of a text data set, then go ahead and comment below or check out tutorial part 1 in which we go over that information. So we're going to get started, and in this visualization we're going to look at batsman information. So let me rename the sheet, and I'm going to call it all innings score. And so by the end of this, we're going to have 2 visualizations, 2 dashboards. One of them focuses on batsmen and one of them focuses on bowlers. Some of the use cases behind this is if you are trying to figure out who did the best of the batsmen and who did the best of the bowlers, for if you were trying to put together a team. So let's get started. We're going to look at batsmen. And here we have listed out all the batsmen. We're going to make this visualization so that you can look at just one batsman at a time. So I'm going to right click on batsman and click show filter. And now we have a filter over here with all of our batsmen, and we can choose just one or all of them. Let's just look at one for now. And then we're also going to look at their information across all of their matches. So we're going to bring on match ID. And now we have all of the matches for this batsman. Now we have quite a few matches, so we're going to allow them to filter to just one season, 1 year. So if I right click on date and click show filter, it gives me this automatic year filter. So we'll just filter to maybe 2014. And now we have all of those matches for 1 year for one batsman. And we want to look at the runs for this batsman. So we'll pull runs out here onto rows, and it now gives us bars for all of those rows. If we were looking at multiple batsmen, so I select all here, it'll section them out by their names, but it's a little bit difficult to tell where one batsman ends and one begins. Sometimes it's not that visually easy, even though there are lines, so we could make those lines darker, or another thing we could do is take batsman and pull it onto color, and now each batsman gets their own color, and it's a lot easier to tell the difference. Let's go back to just looking at one batsman, and let's sort the matches from smallest to biggest as in number of runs. So here we have all of the runs for this batsman per match. If we look at multiple batsmen, you can see how he did as opposed to other batsmen. There we go. Let's move on to our next visualization. It's going to be about, I'm going to click on the sheet, click rename, and click type of dismissal. So now we're going to make a chart that shows you for one batsman for 1 year what kinds of dismissals they had. So we want the filters we made on all inning scores over here to also apply to this worksheet. So let's talk about filters a little bit. When we right click on filters, we can hover over apply to worksheets, and we have these options. We have all using related data sources, all using this data source, or only this worksheet. And that's because we haven't built a second worksheet yet. We have another worksheet, but it doesn't have the batsman information on it. Come right click on year, same thing. So when I bring, or any information on this worksheet, we just need to have some information on this worksheet for it to start being taken seriously. So I drag dismissal on to color, I go back to this sheet, right click, and now we should have another option. Only this worksheet, selected worksheets, all using this data source, or all using related data source. We're going to use the option selected worksheets. Now why would we use the option selected worksheet instead of all using this data source? This is because we're going to apply these filters to all of the batsman worksheets, but as I mentioned before, we're also going to make visualizations based on the bowlers, and we're not going to use this same filter on the bowlers worksheets. So I'm going to click selected worksheets, choose my worksheet, and hit OK. I'll do the same thing here on year, apply to worksheet, selected worksheet, and do the same thing. Okay, so because of filters and because how you can have different filters per worksheet, or one filter that affects 2 worksheets but not the other worksheets, it's best in my mind to do all of your filters at the end when you're actually building the dashboard, so that you can keep track of what the filter affects and what it doesn't. In this case, for our purposes, we've done it already, so now we're looking at just one batsman, just 1 year, but my preference is to do it at the end. Now we brought on dismissal kind and put it onto color, and I want to make a pie chart, so I'm going to click on marks and change it to pie. And right now there's nothing telling this visualization how big each slice of the pie should be, so you need to drag something onto angle. Let's first make the pie bigger just so that we can see it better. And then let's also remove the dismissal kind of null. So we have null dismissal kind, and that's when the batsman did not get out. However, we're trying to keep track of how many times they did get out, so this isn't relevant. So I right clicked on null over here and clicked exclude. What that did was made a filter right here on dismissal kind. And we click edit, and you can see it's excluding null. So that's what right clicking and clicking exclude did. So right now it's doing 50 and 50. It doesn't know how big to make each angle, and we want it to count the dismissal kind, and that's how it'll determine how big to make each angle. So I'm going to drag dismissal kind onto angle, and I get an error. Why would I get an error? I would get an error because it's treating it like a dimension, and a dimension is by definition not something you use to measure things with. And so you can't say this angle should be this big based on a dimension. So we're going to change it to a measure, which is when we're going to count the dimensions. So we're going to do a count of the dismissal kind. So if they got out because they were bowled out, then we'll count how many times that happened, and that will determine the red angle or the orange angle. And if it was caught, that will determine the red angle. So count. Great. So now we can see 5 and 6. So for this batsman for this year, he was out 11 times, 5 times because it was caught, 5 times because it was bowled. Let's control and drag dismissal kind onto label. So now we can quickly see the 5 and the 6. And we're going to control drag dismissal kind onto label, and we can see which kind of dismissal it was. That keeps us from having to need this legend. So we can click hide card, and we don't need that anymore. Now we're going to make another pie chart based on runs. So since I'm making a second pie chart, I'm going to duplicate this. There are some pros and cons to duplicating it. One of the pros is when we come up here to filters and we come to selected sheets, we can see that the filters that applied to type of dismissal are automatically applied here onto type of dismissal too. And so that's great news because we do want it to be filtered to just one batsman and just 1 year. However, we don't want it to filter out dismissal kind of null anymore, because now we're looking at runs, and runs need to have the times when they didn't get out. So we're going to pull dismissal kind off. And if you weren't paying very close attention or you copied it, then you might be confused as to why things were getting filtered out, but it was because it copied your filters as well. So that's one of the disadvantages of copying. Let's rename it runs distribution. And I'm going to pull off all of this information here so that we're starting from scratch. So here we have basically blank pie chart. And we're going to look at batsman runs. So there are a couple different kinds of runs that you can get. So I want batsman runs to determine color, but when I drag batsman runs onto color, it's doing a sum of batsman runs. And it's just trying to make it darker or lighter depending on how many runs there were. But that's not what I want. I want to use it as a dimension. And now we can see we have 0 through 6. And that means that a batsman either has 0 runs or 1, 2, 4, or 6 runs. Now there is 3 runs as well. However, because we're only selecting 1 year and 1 batsman, this particular batsman for this particular year only had either 0 runs, 1 run, 2, 4, or 6. So when we change it to a dimension, it's now, instead of summing up all of the runs, it is now just showing you their options. But it's still doing it like a scale from light to dark. I want 6 distinct colors, 1 for each. So I'm going to change it from a continuous type of field to a discrete type of field. And now I have 0, 1, 2, 4, and 6. Now I want to exclude 0 runs because I'm not trying to keep track of how many times they didn't get a run. I'm trying to keep track of how many times they got different kinds of runs. So again, let's exclude it. And now we have our 4 different kinds. And just to show this, I right-clicked on year, I click show filter, and if I show all the years, you can see our 5th kind of run where they got 3 runs on 1 ball shows up. So it does exist, it just didn't happen for this particular batter or batsman during that year. Now we want the angle to be determined by batsman runs. However, we don't want to sum up the batsman runs. We don't want to take every time that he got a 6 and do 6 plus 6 plus 6 plus 6. What we want to do is count how many times he got a 6. So we're going to change it from a sum to a count. And you can see he got a 6 24 times. And so before, let's go back, it was taking 24 and timesing it by 6, which is 144, and summing up each of those times. But instead we want to count each of those times and see how many times he got a 6 and how many times he got a 4, not how many points were scored when by getting a 6. So that's a little bit of a confusing thing to think about. Another thing you could do is, instead of doing a count of batsman runs, let's pull that off, you could use this number of records field, and that will show us how many, meaning the number of records, how many records did we have from this batsman in this year that showed that he batted a 6. So drag number of records onto angle, and you see we get the same thing that we had before. So those are two ways of doing it. Either change the batsman runs to a count, or grab number of records. Number of records is a little bit simpler. So let's also bring number of records onto the label, and we can see quickly that mostly he got 1s and got more 4s than he got 2s, actually, which might be interesting to people who are trying to see how well this batsman does. Our next visualization has to do with the batsman's strike rate. So we'll make our new sheet, season strike rate, and we'll need to make a calculated field to be able to determine the strike rate for a batsman. So we'll come here to this arrow, click on it, and click Create Calculated Field. We'll call it Strike Rate. And we're going to find out how many runs that a batsman gets basically for every 100 balls bowled. So we're going to get the total of the runs by doing a sum of batsman runs. We're going to divide it by the number of balls bowled. We know that this data set is 1 row per ball bowled. It's the ball by ball data. So we're just going to divide it by the number of rows, number of records. And we're going to put all of that in parentheses. And one thing I need to do is, instead of just number of records, I need it to be the sum of number of records, so that it adds them all up before it divides it. Okay, so sum of the runs divided by the sum of the bowled balls, and we will multiply that by 100. And that is our strike rate. Okay, so now that we have our strike rate, we can start building our visualization. We would like to have both of these filters, so I'm going to quickly apply it. So first build the visualization and then apply it. We're going to come here and bring date onto columns, and it's giving us 1 per year. We're going to change our marks card. No, let's leave our marks card the way it is. And then we are going to bring on our bowler, and we're going to bring on our strike rate next to bowler. Okay, so now that we have kind of the beginnings of our visualizations, let's go here and we can now apply it to our new worksheet. Apply the existing filters. One of the reasons it's so important to apply the existing filters to our worksheet. There we go. Now we can quickly see his strike rate for 2014. I'm going to control drag strike rate onto label, and we have it there as well. Okay, one of the reasons it's so important to use the same filter that is applied to all of these selected worksheets, instead of just bringing batsman back on and making our new filter each time, is we want on the dashboard to just have one filter that applies to all of them. So you can see here, when I change this to 2015 and remove 2014, and then we go to season strike rate, we can see this one's also 2015 now. And we'll go back to 2014, season strike rate, and this one's also 2014. So what we want, whenever a filter is changed for it to affect all of the visualizations associated with our dashboard. And so all of our visualizations that are about batsmen and their information, we want to be able to use the same filters. So I'm going to click Show Filter quickly, and we're going to see what happens to this dot when I add more years. So this is going to allow them to see the strike rate per 100 balls over time if they select more periods. Our next visualization is going to be called Team versus Player. And we're going to see how many runs a batsman scores against particular teams. So we're going to bring on bowling team, because that's the team the batsman is against. We're going to bring on batsmen and their batsman run. So now we can see how many runs each batsman scored against all of these different teams. And again, we're going to apply our filters. There we go. Let's also bring batsmen onto color again, just for when we're looking at multiple batsmen at once in our filters. And we're going to bring the batsman runs onto label. There we go. So now we can have it in both places instead of just pulling it off and putting it on the new one. Great, team versus player. And our last visualization for the batsman dashboard is going to be called Balls per Boundary. So we're going to see how many balls bowled it takes for a batsman to get a boundary. But we have balls per boundary calculated here, and also a boundaries count calculated here. However, we're going to show you how to make our own versions of these calculations. So I'm going to create a calculated field. I'm going to call it boundaries count. And it won't let me save it as boundaries count because I can't have it saved as the same name. At least in Tableau Desktop, that's true. It looks like Tableau Public isn't getting mad at me for that. So, but I'm going to change the name to boundaries count calculated, so we can tell the difference between the one that existed and the one that we calculated. And we are going to do an if statement. So if the batsman runs, the individual batsman's runs, not the sum over whatever we select. If batsman's run is greater than or equal to 4, then 1, else 0. So it's giving me an error because I always need to have an end whenever I do an if statement. And this shows that whenever a boundary happens, so if they scored 4 or 6 on one ball, then we'll count it 1, otherwise 0. And if I sum this up, then we'll be able to count how many boundaries they had. So apply. Okay. And for example, if I brought on a batsman, all the batsmen, and I brought on boundaries count calculated, this should be counting up how many boundaries they had over all time. So that's the numbers we're getting here. Okay, let's back it out. Now we're going to make our new calculated field called balls per boundary. Calculated. Just so that it's clear which one is which. And we're going to count all the balls. So this is for every ball bowled. So we're counting the balls. And we could also use the number of records here, similar to what we talked about earlier. And we're going to divide it by the sum of the boundaries count calculated. So this will show us how many balls it takes to get a boundary. Apply. Okay. Great, now we can start building our visualization. And we are going to bring on batsman onto columns. And we're going to bring balls per boundary calculated onto rows. And now it's showing us how many balls it takes for the boundaries. Let's also bring batsman onto color. I've got to hold control when I do that. There we go. So we have batsman here and batsman here. And we're going to do the same thing. Hold control, drag this down to label. And we can see the exact number. And for the final time, we're going to apply our filters. Now, I could have waited and applied my filters at the very end once I had all of these built. Again, I do recommend applying your filters at the end. Now we're going to put together the first of our two dashboards. So I'm going to click on dashboard here. I'm going to change it to automatic size, which will fill my screen. And I'm going to change it back to fixed size. So now we have our width and our height based on what automatic size was. Let's just round it out a little bit. So instead of 1678, I'm going to change it to be just an even 1600 and same even 900. So now we have our fixed size here. There's also, you could change it to a laptop browser or a full screen. So if we click full screen, there's that size. Generic desktop. I'm going to go back to my size. The size that works for you is going to be based on the size that works the best for all of your users. So that will take some research on your side. And before I get started, I'm going to do some formatting of my dashboard. So I'm going to click Format here, and I'm going to change the default shading for the dashboard to this particular shade. You can use this color selector or all of these different kinds of basic colors. And so it just gives it a different color than just the basic white. So that's a quick way to change the whole dashboard color. And I'm also going to bring on some text for the title of the dashboard. Let's name our dashboard. We're going to call it Batsman Performance. Actually spell it out there. Okay. And then down here it says show dashboard title. So I'm going to select that, and we have Batsman Performance there at the top. If you don't want the title here to match what's here, you have a couple options. So you can click edit title and put in whatever you want. You can also we'll click floating here, and we're going to just drag text on here, and that allows you to be able to make your own title like that as well, or just whatever text you need to put on your dashboard. So we'll just remove that from our dashboard, and we're going to bring on our visualizations, but we're going to bring them on as floating visualizations. So I've selected floating here versus tiled. Floating allows you to bring something on and drop it, and wherever it lands is where it lands. And you can move it around, and it's not going to try to automatically fill this area. If I change it to tiled, and I bring this on, it'll fill the area, or I'll put it to the left or the right, and it will fill those sides. So back to floating. Floating has some benefits where you can just drop things and they will land there. However, if you make it floating, then you have to adjust the size of each individual thing instead of just, say, if we brought it on, undo that, as tiled, and we brought on this, and we brought on this. If I wanted to adjust the size of these things, I can just drag this little line in between, and it just tiles them and they fill the space you give them. Versus with floating, when I bring on this, and I bring on this, then I have to, if I want to adjust the sizes, I can make this one smaller, and then I need to make this one bigger independently of that. So, there are some pros and cons of doing it either way. But we are going to do it the floating way. And we are going to bring on team versus player first. And put it here. Then we're going to bring on, underneath that, type of dismissal. So basically all of our dashboards, one at a time. Here's where our balls per boundary goes. My runs distribution goes over here. And it brings in whatever filters you showed at the time, and all the legends that are showing up on that visualization. So if I go back to runs distribution, you can see we had year and that legend on there, and it brought them in as well. Let's also bring on season strike rate, which also had year, and all inning score. Okay, so this is the one that had all inning score, if you recall, was the first one we made that originally had our two filters. So we're going to change our filters from multiple value list to multiple value drop down. And that causes it to take up way less space. It still has an incredible height, so we're going to go to layout and we're going to change the height to something more reasonable. 100 just brings it onto the screen so that I could drag it like that. There we go. And then year of date. We're going to edit this one, let's see, to be multiple value drop down as well. And again, a more reasonable height for a multiple value drop down. Okay, so we've got started. We have this legend here for color for batsman, which we're going to remove because it has the name on it generally. And we're going to figure out how wide we want these to be. So we need all three of them to fit in our width 1600. So that would be a width around 500 each. So let's go to layout here. And we're going to change the width from 533 to 500 on each of these visualizations. And that gives us some extra space to go in between them all. It's a little bit more reasonable, the space in between. There we go. And run distribution. So once I've kind of figured out my spacing to go in between them, I can line up these bottom ones by matching the Y or X value. So this X is 25, and this one I want it to line up with it up and down, so I'll change my X to 25, and it shifts it over. This one is 555, so I'm going to change this one. And this one, I'm just going to copy and paste this one into this one. Now we kind of have the X figured out, and I want them all to line up along the Y as well. So I'm going to take this 170, and I'm going to apply the 170 to all three of these so that they line up perfectly. This is another benefit of having it be a floating object, because on a tile object you can't determine their position exactly, otherwise it would mess up all of the tiles around it. But you also don't need to put them quite as precisely in order, because when you do tiled, it kind of lines them up along lines as they are tiled. Great. So this is a lot more straightforward. Let's get these. I'll get this guy about where I want it, and then I'll line this one up with it. Up and down. There we go. We can also come here and edit the title and just make the font a little bit bigger on both of these. And now let's make the worksheets here individually a little bit closer to the color that we picked for our background. So I'm going to right click right on top of the chart and click Format. Then I'm going to go to the shading section, And on the worksheet, I'm going to choose more colors. You see the color that we selected before for the background is in this little palette of recently used colors. And I want one that's slightly different than that, so I'm just going to enter in the one that I want. And I'll copy that so I can use it on the others. However, if I did want the same color as I had there, I could just select it right out of the recently used colors. Okay. And there we go. We'll come here, right click on the chart, click Format, Shading, and I'm gonna paste in that color. And you see when I clicked from here to here, it kept me right on that same sheet. However, you see that this went to white instead of the darker color I had before. And so I don't even have to click Format again. I can just come here and paste in my color. So I have a color that matches more closely to my background color, but is still different enough that I still have the outline, kind of the shape of having like cards on this dashboard. We'll go full screen here. We now have our dashboard that allows us to see all of the batsman performance information for whatever batsman we choose and whatever year we choose. So when we change the year, all of the charts update. We want to change the batsman to one of these Chris's. There we go. Some of them aren't in the year 2014, which is the problem we were having. There we go. So now we see all of the same information, but for Chris instead. So now that we've made our batsman dashboard, we're going to move on to making our bowler dashboard. Our first visualization for the bowler is going to be called Bowler Performance Against Team. It's very similar to the one that we made for batsmen, only it's showing how the bowler has performed against batting teams and the wickets that they got against those batting teams. So we're going to bring on the batting team so we can see all of the batting teams against them. We're going to bring on bowler so that it separates it out by bowler. One more try. We'll also put bowler onto color. And we're going to bring on player dismissed. No, sorry. We're going to bring on dismissal kind. We brought on dismissal kind, but I want to change it to be a measure and a count of the dismissal kinds. And let's put it here. So now we have a bar chart for the dismissal kind. You can see that it's going 0 to 30 for each of these. And that's because we have some that go all the way up to 30 against a team. And if we wanted, we could edit the axis and change it to be independent axis ranges for each row or column. So now we can see that it is 0 to 2 for this guy, but 0 to 30 for this guy. And that can be nice when you want to be able to look at them independently. However, when we're looking at them side by side and you're trying to compare, we would think that maybe this person did just as good as somebody like this person. So we're not going to do that because it could be misleading. Also, in the end, I'm going to have filters so that we're looking at one bowler at a time and 1 year at a time. So we won't need to see them all at once. Okay. We have bowler on color. Let's also control drag the count of dismissal kind on the label. So now it's labeled. Some of them are going to have a lot fewer against teams. Maybe they didn't play as many seasons and that they might have a lot more. That's why we're going to have the filter for a per season number. But we're not going to do that right away. Okay. Next workbook. Worksheet. And we're going to call it bowler versus player. So when we're looking at this at one bowler at a time, we can see how the bowler has done versus particular players. So we're going to bring on the batsman here. And then we're going to bring on dismissal kind here. And again, we're going to change it to a count measure. And we can count all of the dismissals against particular players. When we filter it down to one bowler, we can see how they did versus certain players, and then in just 1 year. Let's sort biggest to smallest. We're going to bring batsman onto color. And that way when we switch from bowler to bowler, we could kind of see which batsmen fall in certain areas. It also just makes it quick to follow it along to the edge. And we could put counter dismissal onto label here so that it's easy to quickly see. However, when we filter it down to just one bowler and 1 year, then there's going to be a lot fewer dismissals per batsman. So it'll be pretty easy to see. So let's not do that. Let's go on to our next worksheet. And this one is going to be called bowling average. So we need to create a bowling average calculation. It's going to be runs conceded per wickets taken. So we have to come up with our runs conceded, which is all of the batsman runs. We'll sum those up and divide it by the number of wickets, which is the count of dismissal kind. And now we have our bowling average. There is a bowling average that already existed, so again we're going to call it bowling average calculated so that we know which one's ours. Okay, apply, done. And we're going to bring on the bowler and bowler onto color. And let's bring on our bowling average calculated. We're going to sort it biggest to smallest. It might be better to sort it smallest to biggest. But some of these players might not have played or bowled, so that's why we'll have nulls. So, biggest to smallest it is. And let's also bring the bowling average that we made onto the label. Great. Our next sheet, we will also need to make a calculated field for this one. And let me hurry and name it, and then I'm going to go back to bowling average because I had one more thing to do there. Economy rate is our next sheet. Okay, so for bowling average, we have a situation where maybe somebody doesn't know what the bowling average means. So you can right-click on your chart in the outside area, outside of the graph area, and click on caption. And the caption will pop up, and it's automatically making a caption, which is bowling average calculated for each bowler. It's just describing what's happening. And then it says color shows details about the bowler, which it does. And the marks are labeled by the bowling average calculated. So when I double click on the caption, I can change it to be whatever I want, which I'm going to put runs conceded per wicket taken. And now we have a caption that kind of is describing what this visualization means. So on economy rate, the economy is defined as the number of runs conceded for each over bowled. So instead of the runs conceded per wicket taken, it's for each over. So we're going to create our calculated field. We're going to call it economy calculated. Again, we have to get a sum of our runs. There's our runs. We're going to divide it by the count of the balls. So this will tell us how many balls were thrown. But we don't want how many balls were thrown, we want how many overs there were. So just to make this a little more clear, I'm going to put parentheses around this, and we're going to take, there are 6 balls thrown in an over, so we're going to take the number of balls and divide it by 6 to get the number of overs. So we'll take batsman runs, and then this is per over. Hit OK. And for this visualization, it's going to be pretty similar to the last one, where we're going to bring on economy, and we're going to put economy onto, I'm going to hold control and put it onto label. Sum of economy. Oh, it's not even using my calculated field. So, economy calculated. There we go. Now it's much more reasonable. We'll drag economy calculated onto label. And since this dashboard is going to be meant to be viewed one bowler at a time, we're going to not split it out by bowler in this situation. But you could. And if you do split it out by bowler, that means they could select more than one bowler at a time and see their economy side by side. Also here, we can see that it says economy calculated for our label. And if we hit edit axis, we can change the title. So we're just going to call it economy. Probably need to do the same thing for bowling average. There we go. Edit axis. Bowling average. Okay. It got mad because I didn't close it. And then there we have it. Again, I'm going to right click in some empty space and click caption. And then we have our caption here. Edit caption. And we're going to put average runs conceded. Okay. There we go. We have our caption, we have our chart, and we have one more visualization to make for our dashboard. Remember, if you have any questions or comments, please put them below, and somebody from the Simplilearn team will help us answer those questions. Or if you have an answer to somebody else's question, feel free to chime in. We'll get a good discussion going. The last one is called a dismissal. And we're going to look at, kind of like we did before, a type of dismissal. But this was the batter and how they got dismissed, whereas this is the bowler and how they took the wicket. So we are going to also make a pie chart, which means dismissal kind goes on to color, and we change the marks to pie. So we have a pie that shows a color for each of the dismissal kinds. Again, let's remove null. So again, I came over here, right-clicked, and clicked exclude. But you can do it right on the visualization. Dismissal kind, and you see how it's blank instead of bold or cotton bold, and click exclude there. So there it makes our filter. Next we need to determine the angle size. We're going to bring on number of records, and the more records that fall under that dismissal kind, that means the more often that kind happened. And let's bring number of rows, number of records onto label as well. And also we're going to entire view so that it's nice and big and easy to read. And we're going to add a caption. And we're just going to put dismissal types. We'll see how that comes up on the visualization. So now that we have made all of our visualizations for our dashboard, let's add our filters. So just on this last one, I'm going to bring bowler onto filter, and we're going to click use. Let's actually select a bowler. You can use this box to search. There we go, and it's popped up. You see how I didn't even have to start searching it at the beginning of the name. It's just smart enough. So we have our bowler. Let's bring on date. We're going to choose years. And let's choose 2016. And we have our year. And now let's apply it to all the worksheets that it applies to. So dismissal, economy rate, bowling average, bowling versus player, and bowler performance against team. Same for year. Okay, and you can see how much quicker that is to apply instead of doing it every time you make a new dashboard. So much quicker, saves you some time, can be confusing, so make sure you do it, because if you forget to do it and then you change a filter on a dashboard and it only changes one of the visualizations on that dashboard, then it can be really confusing. And like on the batsman performance, if we had forgotten to add these to all the visualizations and we left it off of this visualization, then people could be confused as to why that's not changing. Or off of this visualization, if it's not changing, it's hard to know if it's not changing because it didn't change from year to year. Maybe his types of dismissal were the same from year to year. Or it's just hard to tell the difference and see if it's not affecting it. So always be sure to double check that your filters are applied to everything you need them to be applied to. Let's make a dashboard. Okay. We're going to make it what we made it before. 1600 by 900. And you can see all of our sheets are showing up. But let me show you a quick trick here. This dashboard uses all of the batsman sheets, and we don't use any of the batsman sheets again inside of the second dashboard. So if I right click on the batsman performance and I click hide all sheets, it doesn't hide all sheets, it just hides all sheets associated with that dashboard. And now you no longer see those sheets. And then I come to dashboard 2, it's only showing me the sheets that are not hidden for that dashboard. Let's get started by first changing our dashboard color. So I came to dashboard and I hit format. And I'm going to change the color to this blue color. And there's our background. And then I'm going to click show dashboard title, which is dashboard 2 right now. So let's rectify that right now. And we're going to call it Bowler Performance. And here we have Bowler Performance. Let's do floating, which is already selected. And we're going to bring on Bowler Performance against team. And we're going to go side by side with bowler versus player. And it's brought on, both of these have brought on legends that are actually not helpful because we have labels that tell us these things. So we're going to get rid of these legends. Sometimes I wait till I have brought on all of my dashboards before I remove legends or change filters. So all of my worksheets. Sometimes I wait till I've brought on all my worksheets. I'm going to bring on bowling average and economy rate and dismissal. Here's an actually useful legend, so we'll keep that around. Remove this legend, because right there, it just tells you right next to it. And now let's start adjusting our charts. So I'm going to make these two side by side up here, so they need to split the space. So let's try a width of 750. Which gives you a little bit of space side to side, but still uses the space a little bit better. You can see that this visualization is too tall to fit inside of the area we've given it, so it has a scroll bar here on the side. If you change how this fills in its space, so right now it's standard, you can have fit width, which it's already fitting the width of the area that is provided. If you do fit height, it's going to force everything to fit inside of that area, so there's no scroll bar, and it does not look good for this visualization. And then entire view, it's the same thing. It's trying to make everything fit inside that area. So we're going to go back to standard. Another one that's good for things where you do want the scroll bar up and down is fit width. So either of those are good. These two are going to share space underneath this one. And so I'm going to make them both, let's say, 300. How does that look? That looks good. Let's make this one the same size as this above it. 750. Bring it over. Okay. You notice one thing that's happening here is we cannot see, at this point, the filters. There are no filters popping in here, even though we added filters. Now, why would that be? That's because we have no filters being shown on our visualization. None of our worksheets showed the filters, they just existed here. So, if we come and we click on one of our visualizations, click the drop-down arrow, and we go to filters, we can see all of the filters we can select from. We're going to bring on Bowler. Let's make it the drop-down. And again, it's just made it a really unreasonable height because it was trying to fit all of those bowlers. But 20 is too small. There we go. And we'll go here and also bring on year of date. What's the height on this one? 55. 55 is a good height. Now it's time to clean it up a bit. So we have all of our pieces. Let's first make sure when I change this that everything changes. So when I unselect 2016, they should all go to null, and when I click Fit 2015, they all update. That's what we want to see. Okay, so we have all the pieces. We just need to get them lined up, looking nice, and just getting things a little bit more clean. Like here, we want to show our caption that we added. And here. And here. So this kind of is something that you can use on your dashboard to describe things that are happening or different pieces of it. It's just an easy way to add a caption. And then let's line them up and down. I think that we could probably make both of these a little taller. What do we think about 350? Maybe even 400. And we'll bring these ones down. That's really nice for this visualization to have more space. Just a little bit more space. Whatever you can give it, honestly, is really helpful. Sometimes with these visualizations that are up and down, I like to give them the whole side to themselves. So maybe we would move this over and make it smaller, and these all three would fit right here, and then I'd give this one all of this up and down space. I'll undo that. We can move this legend over a little bit more. There we go. And then let's start lining things up. I like where this one is positioned on the y-axis, so I'm going to copy that and bring it over here. They were pretty close. There we go. And then I'm going to do the same thing with the y-axis for these ones, just to make sure they're perfectly lined up. These, it looks like I could make a little bit wider, if you would like. One thing that's happening here is it looks a little bit like this one has more up and down space than this one does. And that's because it's missing this label. And it also isn't colored the same as these other ones as it represents the bowler. Well, we can fix that because if you remember, we did not put bowler onto the columns. We put it on there. There's our label. We also didn't put it onto color. And there we go. So that gives us a little bit more consistency between these two visualizations. However, they're still labeled economy rate and bowling average with their captions at the bottom there. Okay. And since these are the same width, I would like to line them up on the x-axis. So I'm going to take this there, and that lines those up. I want to make sure that these are lined up and down, pretty close, but not quite there. There we go. And also, year of date is not necessarily what I want the of date part is just not useful for what we need. So I'm going to change it to year. I'm also going to center it. We'll come here for bowler and center that one as well. Center. And also, let's make it a little bigger. See how it did not make it bigger? That is because the formatting in here, such as changing the font or bolding it, requires you to have whatever text you want selected. So now it's bigger. There we go. I like the white on the blue, so I won't change these individual dashboards or individual worksheets to be a different color. Let's take a look. Here we have our second dashboard. If we come here and we click Hide All Sheets, now you can only see the two dashboards in these tabs at the bottom. And you can see that we can have different years for the two different dashboards. You could tie the year together. Oh, we have year of date on this one too. Let's change that. So, that's not what I meant to click. There we go. Edit title. We're going to make it centered. We're going to make it bigger. Don't press enter when you're not done. And we're going to erase of date. So that's just year. Do the same thing over here. This just adds a little bit of consistency. They are two separate dashboards. But if people are going to look at them side by side maybe, or one right after the other, it is nice to have some consistency. There we go. So, there you have it. We have made two dashboards. One of them about batsman performance, one of them about bowler performance. During this time, we learned about formatting our dashboards. We learned about floating versus tiled, and about positioning legends and filters, some of the options we have for changing filters. We learned about different ways to make different visualizations. So we made pie charts and bar charts. And we also learned about applying filters to just the worksheets that you want for those dashboards. And finally, we learned about adding captions.
So at first we'll understand what exactly a set function is, then we'll understand the sort function. Next we have the join and union and why do we use it. After that we have the highlight function in Tableau, then we have the device designer, and finally the forecast. Now these are the functions in Tableau that we will be discussing today. Don't worry, I'll explain each one of them with practical examples so that you have a better learning experience. Now let's dive into the first one, which is the set. So what exactly is a set? So sets in Tableau are basically a set of elements. Basically, if you have some variety of columns and rows, then you customize some selected data. For example, if you have a set of cars sales data, and inside that you have some details about the horsepower, the price values, the resale values, etc., etc., and you wanted to make a set of the cars with the highest horsepower, then you can do that just by adding some conditions onto your data. So that's what the set functions in Tableau basically do. So we have an example on our screen right now. So this is how the set function will be implemented in Tableau, and you'll be getting some similar kind of output. Now we'll go back to Tableau and try to do it practically. Now we are back on Tableau, and in Tableau let's try to make a set, and for that let's create a new sheet. Yeah, now let's rename this sheet as set function. Okay, now let's try to drag the engine size onto columns. Yeah. Now we have the engine size on our columns. Now the next, let's choose the horsepower. So we have our horsepower on the rows. Now you can see that we have a resultant dot, which is the total number of engine size values and total number of horsepower, including of all the cars. Now let's try to drag the manufacturer into the details part, so that we have the kind of which manufacturer has the horsepower values and the engine size, etc., etc. So we have the Ford, and the overall, according to the data set we have, the overall engine size is 36.60. Now it's not, this is not the kind of data you want to look at. So now let's remove the manufacturer from here and let's select the model. Yeah, now we have a little more detailed one. Just hover onto, yeah, you can see this. So we have the model Corvette, and the engine size is 5.7 liters and the horsepower is 345. Now let's try to drag the manufacturer again onto the details so that we can have also the name of manufacturer. So we have the manufacturer Chevrolet, model Corvette, engine size and horsepower. Now we have the data what we needed. Now let's try to create a set. Now to create a set, you might want to have to select the, let's undo that. Yeah. Now to create a set, you might want to select the values on here. So these are the selected parts we have with the highest horsepower. Now let's right click, and then we have an option called create set in the last option. Now let's just try to rename the set name. Now we have it as set 1. Now let's try to name it as horsepower set. And before we select OK, if you want to eliminate some names or cars, you can do that as well. For example, if you want to eliminate Cadillac DeVille, you can just select and remove it. Or you can also do it in this way. Cadillac Escalade, you can just exclude it and it'll be gone. Yeah, something like that. And if you want this set to be added onto the filters tab or filter shelf, you can just select it over here and it will be automatically done. For now, I think we don't need it onto the filter shelf, so we'll just select OK. And there you go, we have the horsepower set over here. Now to watch the set what we created over here in a pictorial way or a graphical way, you can just drag that and you can just add it over the chart pane. Now if you wanted to look at the data which you have in your set, then you can just drag that set onto the color option and you'll be having a different color on your data which is present in your set. Now you can just right click on it and you can make some changes to it. If you wanted to make, or if you wanted to keep this, you can just click on the option keep only, and if you wanted to exclude it, you can just select exclude and it'll be gone. So this is how you use sets in Tableau. Now let's move on to the next function, which happens to be the sort function. So what exactly is sort? So when you open Tableau, you can see some options on Tableau which are the some bar kind of things on the toolbar. So these are basically sort options. So sort in Tableau is a function which is readily available for the user to sort the resultant data in the form of ascending or descending order. So we have a sample picture which shows the sort functions used in real time. Now let's get back to the Tableau and see it for real. So now we have the highest pricing chart over here. Yeah, you can see, yeah, let's select this one. So we have multiple car manufacturers and the car models available in that particular section. Now these are kind of irregularly sorted. Now one press of this button, which happens to be sorted descending by sum of horsepower within model, you see, within model, all the models are sorted according to the horsepower. So the first one in Buick, the Regal model, which has the highest horsepower 240, and the next highest is 205, second 205, and then 175. So this is how the models have been sorted. Now you can make this look a bit more colorful just by dragging the model onto color, and you can see the different colors. So that's how it is. Now, followed by sort, we'll move on to the next one, which happens to be the join and union. Now the join and union are completely similar to the join and union functions which you basically use in the SQL and database. So you can see on the left part we have the 4 different types of joins, which are the inner, left, right, and full outer.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So join and union in Tableau are used to combine data from different sources, and they're completely similar to the ones in SQL and database operations. Now imagine that you have various kinds of data sources, and you need to work on those various types of data sources in Tableau. For example, consider that you have some shopping data, some store data. So you have the customer data separately and the product data separately. And let's assume that in both the tables we have one common column, that is the order ID. So the customer will be requesting for a product and will be creating an order ID. And in the product table, you'll be having the product data along with the requested product with its order ID. When you have such kind of common column, then you can basically join the two data sets. And no matter what, if you have the orders data in Notepad and the product data in Excel format, you can do it. You can join them. It doesn't matter if you have the data source in different formats. So that's why we have join and union in Tableau. So let's get back to Tableau and try to do it manually. So now I have kind of Excel. Now let's select the store data. Repeat, and you have the store data. And now let's try to add the new data set. Now for that you just need to select the add option. Now we have the other options. Now we have already included Microsoft Excel. Now let's try to include the CSV file, the text file. So I've already created one. So this happens to be the returns data. Now there you go. You have both the data sets over here, which is the Microsoft Excel and the it's text file. So you can see the new union option over here. You can use new union option and try to combine both of them based on the order ID which is present in both the tables. So this is how the join and union basically work in Tableau. Now let's try to continue with the next one. The next one is highlight. The highlight function is pretty simple. You just have to select the option which you want to showcase. It's as simple as the name is. So the highlight in Tableau is a function readily available to help the user to highlight a specific data out of the complete file. So basically you can see my screen, and on the screen we have the data set and we have a resultant bar chart, and on that we have the highest pricing of a particular car manufacturer. And when you hover on to that particular bar and select it, then you can see that that particular bar has been highlighted. Now this data is also the same one, and on the right side part I've just selected the BMW car manufacturer, and you can see the cars highlighted are based on that particular car maker. Now we are back on Tableau, and now we have the same data over here. Now let's just kind of sort it again, and you see here, and now if I select the Mercedes-Benz, you can see that particular car has been highlighted over here. So that's how we use highlight function. And you can see if you want to disable highlighting, you can do it by just clicking this button, disable workbook highlighting. So now with this, let's move ahead into the next kind of function, which happens to be the device designer. So device designer is really simple. There is no rocket science in that. It's basically the kind of device you're working with. So if you have the Tableau installed in your tablet, then you can just select the tablet option so that your dashboard is clearly visible according to the screen size of your table or tablet. And if you're using a desktop, then you can select the desktop option and you can directly do it. Now let's get back to Tableau and check the device designer. So basically the device designer is used to check the layout of the dashboard you have. You can select the fit width, fit height and entire view. So you also have the options for making your dashboard look in the phone mode. And you can either select the default where your device automatically selects the kind of view it wants to show. So that's how the device designer is used in real time. Now let's get back to the next one, which is the forecast. So forecast is one interesting function used in real time. So let's imagine that you wanted to have an information based on the future sales on the product based on the current data available. Now you can do that by using the forecast function in your Tableau. So as you can see on my screen, I have some information available based on the sample data. Now we have the sales charts on 2014, 15, 16, 17, and if you wanted to predict the data of sales in the next upcoming year, which is 2018, I'm saying 2018 as the future year here because the data set what we have only has information until 2017. So that's the reason I'm saying the future year 2018. Don't worry a lot about it. We can actually change it in the data set if you wanted to. Now let's see this practically happening in Tableau. Now we are back on Tableau and we are about to create the forecast thing. So we have the measures and dimensions on the left part. Now let's try to drag the sales. Now we are dragging sales onto rows and we're going to drag the order date onto the columns. So we have the graph over here. Now if you kind of press that little plus button, and then you can see the sales happening according to 14, 15, 16 and 17th year. Now let's try to select the analytics to create the forecast thing. Now you just have to you can see the forecast button over here, right? You can just have to double click on that and you can see that the Tableau is predicting the sales over here, and this is the best case and this is the worst case of sales, and this is kind of the average. So this is how the forecast works in real time. So we will get started by understanding the proper definition of the parameter in Tableau. So what exactly are parameters in Tableau? So a parameter will allow you to provide a value to pass into Tableau. Parameters allow you to produce scenarios or options that are not available in your data, or create these values to put it into your visualization. After creation, end users can control the input to see the results of the parameters effect. So this is a little complex to understand, so let me just break it down to a simpler version. So parameters are completely similar to filters. So when you apply a filter, just imagine that you wanted to find the sales of top 10 subcategory items. So which are, is it phones, is it furniture, is it something else? So which are the top 10 items which are finding me the most profitable sales? So you'll apply that filter to that particular sheet. So what if you wanted to apply the same filter to 10 sheets? Yeah, by brute force method you can do that and you can apply that to the 10 sheets. But what if you had hundreds of sheets, right? So in that scenario you might prefer using parameters, because once you set the parameter, you can use that particular parameter for all the sheets in your visualization, and even you can use these parameters in your dashboards as well. So I think this was a little simpler to understand. Now what are the use cases that we will be discussing today in parameters? So there are multiple parameters that you can use in your day-to-day Tableau usage. So we'll learn the most frequently used parameters, We're going to use the top n parameters, date field parameter, dynamic measures, dynamic dimensions, dynamic measures and dimensions, reference lines, and some sets. So I hope so far so good. Now let's begin with our practical session. So let's get back to Tableau. So we'll be using the Superstore dataset. We have dates and etc columns which we need for the parameters to be applied. So we'll go with that. So you can see that I've already worked on some sheets which include the parameters such as date parameter, dynamic measures, dynamic dimensions, dynamic measures and dimensions, etc. So don't worry, I'll save this book for your future reference. We'll be creating new sheets and we'll be applying new parameters for a better understanding in a practical way. So for now, let's create a new sheet. So you can see the icon by clicking that. You can just enter into the new sheet. Now for our reference, let's rename it. So we'll rename it as top n. So we'll be beginning with the top n parameters. So we'll rename it as top n for now. Enter. Yeah. So for top n, let's drag sales into rows and subcategory from dimensions to columns. Now we have a bar chart on our screen. Let's kind of twist it or change the orientation. Yeah. Now we want to find the top 10 or top 5 items which are giving us the top sales. So let's kind of order it in descending. To do so, or to know the top 10 items which are giving us the maximum sales, we'll apply filters onto it. So to apply a filter, let's drag the subcategory into filters, and you can see a drop down menu or a dialog box where we can find the option called top. So here we can specify the top ideas or top items or top categories, whatever it is, which are giving us the top sales. So we'll be selecting by field, and inside that we have a top 10. Now, okay, we are not going to create a parameter right away. Yeah, we have to create a parameter right away. Now just select a new name for your parameter. Now let's select top n parameter. Hyphen, or let's place the number in the starting for our better identification. Okay. Now let's select list. Now we have, if you remember, we had the minimum and maximum values as 1 to 100 in the previous dialog box. Now let's select that to 10, and here 5 or 7. Now let's select or let's do it 15, 10 and 5. Now let's rename them. Display as top 15. Now display the 10 as top 10 and the 5 as top 5. Now the parameter is created. You can see the number second top n parameter on my parameters section over here in the bottom left corner. Now the aggregation is sum by default. Now let's select apply and OK. Now let us right click the parameter and select the show parameter icon, and here we have the top 15. Now let's try to select top 10. Now you can see that the sheet has changed the data. Now we just have the top 10 subcategory items which are providing us the maximum number of sales. Now if we kind of select label and show mark labels, then we have the numbers, right? You can see the numbers which are providing us the maximum sales over here. Now let's kind of select top 5. Yeah. So that's how the top n parameters works in real time. Now let's continue with the next type of parameter in our list, which happens to be the date field parameter. For that, let's create a new sheet. Now let's rename it as date sheet for our reference. Now we have the date sheet over here. Now to create a date parameter, we need a date. So we have the order date over here. Let's drag that to rows. Now let's select profit, and let's drop it down to here. Now we have the profit on a particular dates over here. Now to create a date parameter, let's select the icon over here, and we have a create parameter option. Now let's create a parameter. Now let's rename it as second hyphen date parameter. I'm renaming it as second hyphen because we have already worked on this particular sheet, and if you have seen this particular parameter section, we have a date parameter already existing in my sheet. So for that, I'm renaming it as second date parameter for the reference. Now we might have a doubt about selecting the data type for the dates. I'll go with string over here. Now let's select the list and add the values. Now for a date we have year as well as quarter. Next we'll have month. We'll have a week, and we'll also have a day. So that's our parameter, which is number 2, date parameter. Let's select OK. So once we have created the date parameter, the next step is to create a calculated field. So this particular calculation field will help us with the calculation of days, quarters, months, weeks, and years. Now let's rename this as well. Rename it as to date calculation. Yep. Now in this particular tray, we'll be writing the formula. You can see that we already have a date calculation over here. Let's try to see the formula over there. So here we are, we have the date parameter and year, quarter, month, week, and daily. And we have the order date parameter over here, order date, and this particular hyphen Q is used for dividing the year into quarters. Now we are going to use the same formula. Now let's create a new calculated field. Now let's select case, and remember the date parameter we created in the parameter section, you need to drag that in. So that's dragged. Now let's paste the formula and end. So there you go. We have the parameter dragged into the calculation field, and we have the calculation for year, quarter, month, week, and day, and we have the calculation as valid notification over here. Now let's just select OK. Now there you go. In the measure segment, or yeah, there you go. In the dimension segment, we have the date calculation field available. Okay. Now we have the sales and year-wise data over here. Let's change the type of graph to bar graph. Let's change the orientation. Yeah. Now let's select the label option to provide us the details of sales. There you go, you have the sales now. Let's select the date parameter, show parameter option, and we have the year-wise sales now. Let's select that to quarter. So the parameter is shown on the right hand column. So you can see the sales are according to year now. When you select quarter, you have the quarters. When you select month, you have month-wise sales, and when you have week, week-wise sales, and finally the day-wise sales. So you can see that on the 18th of March 2014 we have the maximum amount of sales. So that's how you do it. Now moving ahead, we have the dynamic measures and dynamic dimensions. Once we are done with the dynamic measures and dimensions, we'll also execute dynamic measures and dimensions together. Then we'll continue with reference lines and sets. let's get back to Tableau. So what exactly are dynamic dimensions? So you can see that on the left hand column we have so many dimensions over here. So we'll be creating a filter and we'll be passing all the dimensions, or the number of dimensions what we want on our filter to be. So we'll pass those number of dimensions into the filter, and for the same we'll be creating a parameter and we'll be running all the values of dimensions through that parameter. Now let's go ahead and create a new parameter. Let's select the icon, create a parameter, and now we are on the new workbook to avoid confusion. So we'll rename this as dynamic dimensions parameter. We'll select the data type as string, current value, and list. And inside the list, let's write in the category, shift mode, and segment. Let's select OK, and you can see that we have the new parameter over here which says dynamic dimensions parameter. Now once the parameter is created, the next step is to create a calculation field. Let's select the calculated field option, and inside this let's rename this calculation as dynamic dimension calculation field. And inside the tray let's write in the formula. Now let's write in case, and let's drag the newly created parameter, and now let's select one category, then category from dimensions, followed by that one shift mode, then shift mode from dimensions, followed by that one segment, then segment from dimensions. Now end. Yeah, the calculation is valid. Let's apply. Okay, so you can see that we have a newly created dynamic dimension calculation in the dimensions section. Now we have the newly created dimension calculation here. We'll drag that to columns. Now let's drag sales to rows. Now let's drag the category to columns. So there you go, we have the different categories: furniture, office, technology. Now we have the parameter displayed on the right hand side. Now let's select according to the shift mode. So according to the shift mode, we have the first class, second class, same day, standard class, etc., etc., and these are the categories happening in that particular fields. And if you select the category or parameter by segment, we have these results: consumer, corporate, and office. Now this is how the dynamic dimension parameter works. Now let's get into the dynamic measure parameter. For that, let's create a new sheet. We are in the new sheet now. Now dynamic measures are completely same to dynamic dimensions. The only thing changing here is instead of dimensions we'll be dealing with measures. Now we'll follow the same steps again. First create a parameter. Let's rename this as dynamic measures parameter, and in the list we'll be using sales, profit, and quantity. Let's select OK, and our parameter is done. Now let's create a calculated field similar to dynamic dimensions. Let's rename this calculation is dynamic measures calculation. And inside the tray, let's type in case. Let's drag the measures parameter. There you go. Now, when we have used sales, profit, and quantity. So, sales then sales. When profit, then profit. When quantity, then quantity. And yeah, the calculation field is valid. Apply and OK. Now let's make use of show parameter option so that we can see the parameter on the right hand corner. Now let's select the category from dimensions and the newly created dynamic measures calculation onto rows. So we have the bar chart over here. Now let's select profit. So you can see the profit by category wise, and you can select the label so that we can have a clear picture of the numbers. Now if we select the quantity, we have the details according to the quantity. Now to just make things look a little better, we can drop the category off and make use of subcategory to have a better visualization on the subcategories which are bringing us maximum sales. You can rearrange them in descending order, and we can see binders are giving us maximum profit in the number of quantity. In the profit, yeah, copiers, and in sales we have phones. So that's how we use dynamic measures in real. Now the next part is both dynamic measures and dynamic dimensions together. For that, all you need to do is just select the calculations from dynamic measures and drop it down to rows, and dynamic measure dimension calculations onto columns. We're using both the calculations together, and now let's kind of use the option of show parameter where we can see the dynamic dimension parameter and dynamic measure parameter together. Now when you select category and sales quantity, now we have both dimensions and measures here. Now let's select the label option so that we can have a detailed appearance on the numbers. Now we have the segments over here: consumer, corporate, and office. When we select sales, we have the sales number. When we select profit, we have the profit number. When we have the quantity, we have the quantity number. So that's how the dynamic dimensions and dynamic measures are used in real time. So the next parameter that we'll be dealing with is the reference lines. Now we are back on Tableau. Let's create a new sheet. Now for reference line, let's select the order date and drop it down to columns, and now let's select sales from measures and drop it down to rows. Now let's make a change to year. We'll check that to day, and we have a line over here. We need the sales in continuous day format. Yeah, so this is how it looks like. Now let's create a new parameter. Let's rename this as date parameter. Let's select the data type as date and current value, and let's select the date as, so according to dataset we have the dates between 2013 to 2018. So select anything between 2013 to 14. Let's select 2014. Yeah. Now let's select OK. So now we have the newly created date parameter over here. Let's select the show parameter icon. Now let's get back to analytics and try to use a line. So we'll use a reference line. Let's select table. Let's select the type of line and color. Okay. So you can see a reference line over here which is got created. Now let's get back to data once and date parameter. Let's edit it once. I think we forgot something important. It's fine here. Yeah, let's recreate the line again. Let's use a reference line, table, and here we created a date parameter. We need to select this. I think I forgot that. Okay, now let's select the type of line. Let's select a medium thick line and a dotted line. Let's select the color as pink. Yeah, that should be it. Let's select OK. Now let's select the show parameter option. When we have the date parameter option over here, let's kind of change the date, and once we change the date, you can see there is a shift in the line. So that's how we use the reference line in real time. We have the date parameter over here. This is how we use it. Now let's move on to the next option or next parameter in the list, that is the set parameter. For that, let's create a new sheet. Now let's drag the sales to columns and subcategories to rows. Now select subcategory and let's select subcategory from dimensions, right click, and let's use the create option, and from there we'll be creating a set. Let's rename the set. The subcategory set is perfect. Let's navigate to top, and inside that let's select by field, and now let's select the top n parameter. We are in the subcategory. We have created a new parameter which we had in the earlier sheet. So again, let's navigate to top and let's rename this. Now by field, by top n parameter, select OK. Now you can see that we have a new set over here. So now let's select the show parameter option. And now let's drag the set into color so that we have different colors. So that's how you use set in real time in parameter calculations in Tableau. So now let's discuss the differences between parameters and Tableau filters. So these are the few differences between Tableau parameters and Tableau filters. So Tableau parameters are used for static data and Tableau filters are used for dynamic data. So parameters are implemented to entire workbook, whereas filters are implemented to only specific sheets. So this is what we discussed in the earlier part. So using parameters cannot select multiple values, but using filters can select multiple values at a time. And parameters use calculated fields while filters do not use calculated fields. And finally, parameters support multiple data types, whereas filters do not support multiple data types.
So let me now begin with connecting to data. Now in this particular topic, we are at the end of this lesson. You will be able to understand how you can connect to Tableau data server. You will be able to differentiate between a join and blend. How can you perform a join on a data? How can you blend a data? We will discuss the various connection options available. We will understand how Tableau server works in terms of the Kerberos authentication. All right. We will understand various performance optimization techniques as well, shadow extract, as well as different methods that we can prepare in terms of the data that we want to analyze. All right. So let me begin. Now, the very first topic, which is connecting to Tableau server. So I'm going to first take you through a couple of presentation slides here, and then quickly move on to the environment where we will actually then start exploring the topic. So now, when you want to connect to a data source in Tableau server, it's pretty simple. You can connect to a flat file in your local machine. So one is you will click on to the server in the start screen, and you can specify the server name. You can specify and show your log in your credentials, the username and password, and based on that you can perform you can have your connection to the database. All right, so that's how you can connect to the Tableau server as well. All right, so that's the very first basic. So the Tableau administrator is the one who assigns the roles and creates these data sources. All right, and you have Tableau has the facility in order to import different forms of data for the analysis for your ease. And once you're connected to the Tableau server, then you need to select the Tableau server data source. On the data menu, you will need to select the data source to download a local file, a local copy. You can select and create a local copy, and then you can also duplicate a duplicate of that data source will be added up into your data window. So that's how you can connect to Tableau server as well. All right, and it basically promotes various features wherein you can then connect to the Tableau server for your data. So you are in this example, you can see that you're able to connect to the Tableau server as an admin and connect to the sample superstore, and it downloads, it creates a local copy and duplicates all the data in that particular data window. That's how we can see the sample superstore, and you can connect to the server. Next, we're going to also understand what is joining and blending. So before I move on to the presentation slides here, what I'm going to do is I'm going to move on to the environment directly. Let us start exploring these blending and joining features right therein. All right, I'm going to simply just clear the sheet that we have, and let's go back to the connect to data source window. All right. Now, in terms of this is where you're able to connect. You can see the Tableau server. So it's through the server that you can connect, wherein you can specify your server credentials, and you can click on connect, and based on that, that's how then you can provide the credentials and log in. All right. Now, I do not have a server connection wherein I can show that example, but this is how you can click on any of these servers. You will have to type in the URL, click on connect, and then provide the usernames and login provided, and that's how you can connect to your data source using a server option. All right, I'm going to show you the file option wherein you can connect to an Excel, and let us discuss the join and the blending part here. All right, so let me click on Excel. We have the sample super data store here, and in this, when I pulled in order, all right, I pulled in the first sheet. So there are 3 sheets in that particular Excel file. When we pull in order, this is how now you can identify that whatever are, these are the header names, these are the dimensions and measures, that's how it's getting identified. You can notice all the dimensions are first place. You have all your measures, then you're able to identify the data type and the role, and ABC, which is a contextual value or numeric value, that means it's a dimension with a pound sign. What kind of a data role is it? Tableau is automatically identifying each of these roles as well. All right, even in the metadata, that's how you can see the field names, the field name that you're going to see onto your your view, and the table from which it's going to be getting pulled in from. In this, you can rename in case you want to change the particular name, hide it, alias it, or describe it. All right, so this is how you connect. Now connections is where you have the option to connect between live and extract. Now if you connect to live, that means you're connected to this particular sheet live. That means any update happening onto your sheet, any kind of updates on the sheet, there is a live connection. It will automatically update your views as well onto your sheets that you're creating. And in case if you select on an extract, all right, this is what it means, that it allows, what it does is it imports that data into the Tableau data engine first. In the data engine where it's going to perform the queries, it will create an extract, and based on these we can then start using the connections. All right, so what it does is it disconnects. It's more like a small extract, more like a cube if you understand it in that manner. Tableau creates an extract of that file, providing you a disconnected, wherein it allows you to give you a better performance, a better query. That's how you can then work on and start creating and working on these extracts. Now you can refresh these extracts at a timely manner as well. So that is what Tableau extracts are, where it extracts it as a copy of the data and saves it in the engine, and that's how then the performance as well gets better in terms of using, where you can connect to your particular data. All right, so you can work with multiple data sources. Data sources can be of any type. All right, wherein you can edit from the number of lists that you can see. It can be a flat file, a server file as we saw, or the saved one. And we can also then join multiple tables within the data, or we can also blend when it's coming in from different data sources. Then we can also perform a blending. So let me first show you an option for join. Now you can see we have the order table here. When I drag and drop the people sheet as well here, you can see that Tableau has automatically created a join. All right, it has automatically created a join when we have pulled in two tables coming in from the sheet, and by default, all right, we have the inner join that Tableau creates. So it creates an inner join here, wherein again you can then click on the join option here, and you can specify and modify the join based on whether you want it as an inner join, which is a default, you want a left join. Now if you see, the right join has been disabled here. Okay, I will show these options here. By default, the right join is disabled by Tableau by default, and to enable that you will have to connect to your Excel sheet in a different manner. I will show that to you shortly. So that's how you can change and you can perform your joins. This is where you can explore and show the join clause. And here again, then you can specify, like you can see a join that's being created amongst the data source, which is region and region people among these two data. All right, so it's also showing you the join and whether it is equal to or not equal to. All right, so you can connect to multiple tables, and based on that, you can add in tables, you can specify the different joins, and based on that, then when you click on sheet, you will then be able to see that there is a join being performed. There are two tables now, the people's table also that has been added in, and it has now performed an inner join on our data, and you can start using this particular option. So let's say I'm going to pull in the region on my columns, and I'm going to have my sales onto my rows. It's now providing me details of my sales at a regional basis. Now, let's say I also want to analyze the people belonging to these regions depending on the color. So it's going to change the colors based on the central, east, south, and west. All right, that's how these are the people, number of people belonging to each region that it has identified. So that's how it has taken up the region people. As you saw, there was a join that was created and it's given us that particular option. And based on that, you can see here, we just have this particular data source here. And that's how you can see. Now, I've used it earlier as well. If you remember, we had pulled in one particular table. Hence, the blue tick mark sign here enables and shows us that this is the primary data that's being used. Now, this comes in picture when we're using a particular join. So, let me right now just use this particular detail here, and we're not going to require this. All right, so let's just close this. We just need one right now because we're discussing on blending. I'm going to show you the blending part later. Right now we're discussing on joins. So that's how you can join in your data sources, and you can combine multiple fields using these joins. So when you have multiple tables, you can simply connect to the data. Let me go back to the data source page. This is the starter page, the data source page, and you can see the joins that's been performed. Now, let's say you want to create a join where you want to force, due to certain situations and scenario where you want to force a right outer join, or right join, or for that matter, you want to write a custom SQL. Now, you're not able to write a SQL right here in the drag area pane where you can drag and drop your sheets from the Excel file or any kind of a file that you're connected to. For that, and to enable the right join, you will need to connect to your data in a specific manner. So let me open up a new instance of Tableau here. And let me show that to you as to how we can enable the right join and how we can have our custom SQLs as well. So in case if we want to write in a custom SQL on our view, then how can we perform that initial custom SQL, all right? Okay, so let us connect to our data here. And I'm going to take you on to the Excel file. Now, when I click on the sample superstore here, okay, what we had done is we clicked on open, and that's how we opened up the file, all right, and that's how we could see the sheets. Now, instead of using the open option directly, what I'm going to do is in the drop down, all right, here instead of open, we have an option that says open with a legacy connection, all right. This is what is going to enable us to write a custom SQL where we can specify a query rather than using the entire data source or pulling in the entire table. So clicking on the second option in the drop down in the open tab here, you will be able to see the open with legacy connection. I'm going to ensure that you've selected that, and that's how you will then connect to the data source. And with that, you now have a new custom SQL option that's opened up for you all. This is where you can, once you've connected, you can double click on the new custom SQL and you can write in your query. You can write in the SQL where you want to perform the query and pull in your data. All right, so you can have your select from, and let's say orders. All right, so that's how you can perform, and you can write in custom SQL, and you can pull in the required data. You can have your required table that you can pull in terms of creating a SQL that you want to pull in and have your data. All right, so you can have your select from the orders and preview the results. So here you can see the orders table has 9,940. We have a preview of the data available in that particular sheet that we pulled in. All right, and we can now, parameters is what I'm going to cover when we come on to that particular topic. So I'm going to leave this for now. So that's how you can write your custom SQL, and you can click on OK, and that's going to pull in your entire data. And as you can see now, instead in the earlier view, I'm going to just switch to the earlier instance of Tableau. You could see the name of the table that I dragged and pulled in. You could see the name order. But in case when we write a custom SQL, then it gives us the name which is written as custom SQL query. All right. And this is where you can get the information. You can edit the query in case you want to change the results and requirements. So that's how, instead of clicking on open, you click on open legacy connection, and you can have your own custom SQL defined. Now, along with this, all right, when you open and when you click on a legacy connection, when I drag in the people's table here, you can see that even the options for right joins have now been enabled. So by default, Tableau disables the option for right joins. And in case in certain situations and circumstances you want the right join to be enabled, you will in the same manner have to import and connect to your data using a legacy connection, and you will have the right join which is going to be enabled there for you all. So you can have your custom SQLs or the right join in that case which gets enabled, and you can use a custom SQL or a right join. right? So that was custom SQL. Then joining is where you can, as I mentioned, identify and choose between the clauses and the clause that you want to add in. Right. Now let me show you an example of blending as well. So I'm again going to open a new instance of Tableau. All right. And with that, I'm going to show you the example of blending. So let's say you have you want to join in, and when is the best time, when is the best way that you should use. Now joining is when you have all your multiple tables that you want to join coming in from one data source. Blending would be required when you want to join in multiple tables coming in from different data sources, or for that matter you can also blend even though the tables are coming in from a single data source. There might be instances that you might want to have still perform a blend instead of a join. So let me show that option to you. All right, so let me connect to the data. Let's connect to Excel, pull in our sample superstore file that we have. We have the order table, all right, and I'm going to go on to the sheets here. All right, so we have one order, we have one data, which is the order table. Now I'm going to again click on add a new data source coming in from the same Excel file. And this time I'm going to have the people's table and move to the sheet. So now if you notice, we can see two data sets here, which is one for the orders and one for people here. And in here, now this is where the blending will take place. This is where you will have a blend automatically when you pull in a view, if there is a common view that comes into picture. Now let's say I'm going to first pull in the order date onto the columns, all right? And as soon as I pull in, you can see that my order table has now got a blue check mark, which has become a primary data source, all right? And now let me pull in sales onto my rows. And from people, let me have from the people's table, let's have region pulled in and added to the colors. So region has become a secondary data set, and now you can see a blend sign, right? A linking or data blending that has automatically been performed on both these two data sets, all right, that we have the order table and the people's table, blue being primary and people which is being secondary in this case, all right? So that's how you can mention. Now in terms of blending, what happens is you cannot specify the joins here in this case. There is a primary and secondary data, and it is automatically blending in the data for you. It is automatically pulling in the data. You will not be able to here select on the kind of join. You will not be able to manipulate the join. So that's how, even though at times you have the same tables that are coming in, as I mentioned, there are times where you might want to perform and change the joins. So that's when you can use the joining table option that comes into picture. So that's the difference between your blending and between joining the tables, right? So you can see this available link, and you can see how it was simple to drag a particular view and pull in data. And here as well, region has been added to the color fill, because of which the legends have been created, identifying all 4 regions present in the data. And it's also letting us know here in the marks that region is coming in from the secondary table. You can see the orange amber tick mark here, and that's how you can identify that region is coming in from the secondary table that's been created, all right? In terms of connecting as well, wherein you can combine and have the joins enabled. Now, depending on the kind of data, all right, going back to the data source, depending on the kind of tables and the kind of data that we have, that's when we can enable and have the joins that we can decide on, all right? So one is you would require and need to have a multiple legacy connection with which you can then define the right outer join, all right? And that's how you can proceed and have additional joins that you can work on. We also discussed how we could create and connect to a custom SQL query, all right? And that is how we could, using the legacy connection, also enable the right outer join, wherein we could then perform a right join on our tables as well. All right, and in case if it's a query, then it gives in the name of the query as a custom query, which is what we saw onto the preview and the extract there, all right? Now, in terms of extract, all right, now extracts are basically your saved subsets of the data source, which will help you in improving the performance. So instead of, as I mentioned, instead of being connected to a live connection, it is better that we select an extract which creates a subset and stores it in the Tableau engine, wherein it performs the queries, and it takes advantage of this functionality where it is not connected to the original data source. And with this, it can actually reduce the total amount of data in terms of defining and limiting it. So that's how you can create an extract. And let's say once you've created an extract, you can then perform, like I said, you have the edit option where you can edit the additional detailings. You can allow an incremental fetch happening, where then you can refresh the data each time your data is updated. You can provide an incremental fetch. So this can help you in improving your performance. You can take advantage of the functionality in terms of the data source for using the discounts, the distinct counts as well. And moreover, it's more like an offline mode. You're actually accessing your data as an offline access where it's not directly connected, and you're able to use it like a data, local data. All right, so that is the difference between a live and an extract. So that's how you can make use of the legacy connections as well. So let's go back to the presentation slides and have a recap. Now, these are the joining tables. That's what we discussed, that in terms of the tables that we have, we can join a table and we have various joins available where it makes it easy for us to analyze the data that we want to view. We can join two or multiple tables, and based on that we can customize the inner, the left, the right, or the full outer join. Now, the full outer join also depends on the kind of data source that you're connected to, all right? So in case of an Excel file, we still do not have the right outer join option which is enabled. So this possible option, again, when you open with a legacy, depending on the data type is how you will have the right outer join that you can force and have it enabled. So this would be depending on the kind of data source file also that you have, and you have these 4 join types that you can use in terms of joining tables in Tableau. Now, when would you want to use a join? All right, so a scenario is that you have a sales manager of an online shopping website and he wants to analyze the customers who have returned at least half the number of orders that they have placed. Now, to fulfill this requirement, he will require a worksheet wherein he can join the orders and the return table on a particular common dimension. All right, so that's how then he can create a join. He can change this between the inner default to a left join between the order tables and the return tables, and based on that he can then get to know the customers who have returned at least half the number of orders that were placed. All right, now in terms of enabling a right outer join, this is taken care of by the Microsoft Jet data engine driver. So in case if you all are facing a trouble where you're not able to connect and see that particular option, it's throwing an error. This legacy connection options comes in only when you're using a Microsoft Jet data engine driver. This is easily available. In case if you do not have it, you can install this driver, and with this it will enable the right outer join and the custom SQL for us. All right, to enable the right outer join here, that's how you open it with a particular legacy connection. Now, in terms of a right outer join, we saw an example. We can force and use a right outer join. We can select on a new custom SQL where we can type in and have a custom SQL generated. And that's how we can work on with the SQL, where we can provide the SQL syntax, and based on that, the data source will then be generated. Now, in terms of blending, this is what happens when you have multiple data sources in your view, or when you want to establish a link between them, or you want to blend your data. It does not create a row level join. So in case like the example that we did, although it was coming in from the same sheet, from the same Excel file, but we did not want to create a row level join, then that's when data blending would come in handy. You can use it with the related data across multiple sources that you want to analyze in one particular view. So that's how you can blend your data which creates a primary and a secondary data. So we saw that in this example, you can see that there's a customer segment, department, and sum of sales, wherein the bars are being created, which are coming in from the primary connection. But in terms of the sales plan, all right, these sales plan are coming in from a secondary data. You can see the amber connection here, the amber line here, that is allowing you to understand and segregate and differentiate that it is a secondary connection. So in Tableau, that's how you can identify, as you saw, that your primary source and you have your secondary source, wherein you can identify and distinguish. You can distinguish between the common fields that are present in your data, and you can establish a connection. In case if it has not established a link, you saw that there was an automatic link, then you can provide a link by explicitly defining a link as well. Let me take you back to the environment. All right, so this was the custom SQL. Now, in this case, in case if there is no link provided, then you can provide a particular link onto your view. You can have the option, if it has not enabled, then you can select your particular, you can see that it has not implicitly defined, but it's giving you an option that there is possibility of linking. So you can explicitly define, you can click on this link and use person as a linking field, and this has also linked in your data with the previous data that you have. All right, so that's how you can define and explicitly mention the way that you can blend your data and you can identify. Another way can also be wherein you can edit the connection in the mapping, and that's where you can perform. So you can go back to your data sources and you can explicitly define, you can identify whether the first rows are the names, whether the rows here are automatically generating a field or not. All right, so that's how you can have these two tables and you can define the blending whether you want it or not. You can disable the linking as well in case you don't want to perform a particular link. So coming to that, now let us understand, I've already discussed the difference between the joins and blends and where you can use it. So let's have a recap again. Now in terms of joining, joining is a SQL term wherein it's combining two data sources coming in from a single data source. While in terms of blending, it's more about combining two different data sources into one single sheet. All right. Joining is done once at the data source, and this can be used for every worksheet, while blending will be done individually for every worksheet. Okay, and both the tables that are joined must exist in the SQL database. While in blending, it helps us combine the database which is coming in from different sources, different locations. And in case if it's a multi-dimensional source, if it's a cube, then you cannot perform a join. And in terms of blending, you have a primary source, and but in terms of a primary source, it cannot be a cube, but your secondary source can definitely be a cube that you can use in terms of performing a blend. All right. So that's how you can optimize your connections. You can select whether you want to have perform a blend on your connections, you want to perform a join depending on the kind of connections that you have, and that's how you can work with them with the different data sources that you have available.
So at first, we will understand what exactly is an LOD expression in Tableau. So LOD expression stands for level of detail expressions in Tableau. The LOD expressions will allow you to compute values at data source level and visualization level. However, LOD expressions give you even more control on the level of granularity that you want to compute. They can be performed at more granular level, that is, we use include LOD expression there, a less granular level where the exclude LOD expression will be handy, and finally an entirely independent level, that is the fixed LOD expression. So in this tutorial, I'll explain you the types of LOD expressions you can use in Tableau, as well as when to use them and how to format them. I will also use an example to demonstrate how to create simple LOD expressions in Tableau. Now in this image, you can understand that the aggregation and granularity levels are inversely proportional. That means as the level of aggregation or as the level of ordering in data increases, the granularity level gradually decreases. So this particular example will help you understand the inverse proportional relation between the aggregation and granularity. Now let's move into the next part where we will understand the two types of LOD expressions in Tableau. So basically there are two types of LOD expressions in Tableau. The first one is the row level LOD expression and the second one is the view level LOD expression. So in Tableau, expressions referring to unaggregated data source columns and are computed for each row in the underlying table are the row level expressions. So in row level expressions, the dimensionality of the expression is considered to be at the row level only. Now the second type of LOD expression, that is the view level LOD expression. So by contrast, which is the opposite to row level, the expressions referring to aggregated data source columns are computed in the dimensionality defined by the dimensions in the view. In the view level LOD expressions, the dimensionality of the expressions is confined to the view level only. Now the next part is about the syntax of LOD expressions in Tableau. So as you can see on my screen, we have a sample syntax to be followed for the level of detail expressions in Tableau. So we will be following the same kind of syntax in our real-time examples. Now moving ahead, we have the types of LOD expressions in Tableau. So basically, as discussed in the definition, we have three different types of LOD expressions in Tableau. So the first one is the include level of detail expressions in Tableau. The second one is the exclude level of detail expressions in Tableau. And finally, the last one, that is the fixed level of detail expressions in Tableau. Don't worry, we will understand each one of them in a bit more detail along with a practical example for a better understanding. So the first one, the include level of detail expression. The include level of detail expressions compute values using the specified dimensions in the addition to whatever dimensions are in the view. Include level of detail expressions can be useful when you want to calculate at a fine level of detail in the database and then re-aggregate and show at a coarser level of detail in your view. Fields based on include level of detail expressions will change as you add or remove dimensions from the view. Now let's get back to Tableau and try to execute a simple example for include level of detail expression. Now we are back on Tableau and we are going to use the sample dataset in the Tableau, which is the Superstore dataset. Now to create LOD expressions in Tableau, we have some steps. So the first step is to set up a visualization first. So we need to use the data from the dimensions and measures and we need to create a visualization on the sheet. And once the visualization on the sheet is ready, then we are going to create the LOD expression. So for that, we are going to use the analysis button on the toolbar and then we are going to create a calculated field, and inside the calculated field, we are going to create our expression for LOD, that is the level of detail. So once the calculated field is set up or the level of detail expression is set up, the third step is to use the level of detail expression in the visualization. That is, we'll be getting the newly created level of detail expression field in this particular dimensions or measures, and we'll be dragging that into the rows or columns, or we'll be dragging that into the details, tooltips, text, size, color, etc, etc. Basically, we'll be using that particular new field which got generated using the level of detail expression, and we'll be creating the new visualization using that particular LOD. Now we have a brief idea how to create an LOD. Now let's begin with the first type of LOD expression, that is the include type of LOD expression. Now let's try to rename this sheet. I'll rename it as include LOD. So before getting started, I would like to tell you guys that we will be using color, size, label, detail. So only these four boxes or only these four shells will be affecting the level of detail visualization in real time, and the tooltip and filter, pages, etc, etc will not be affecting that much. Now let's begin with the first one. Now as the first step, we are going to create a visualization on the screen first. So for that, let's drag the region into columns. Now let's drag the sum of sales into columns. So now we have a bar chart visualization on my screen which tells about the number of sales happening in different regions. So if we have an example that is central, which is near to 500k, and east is around 678k, and similarly south, and similarly west. So basically we have created the first step, that is create a visualization on the sheet. Now the second step, to create the new calculated field, that is the LOD expression. For that we'll be moving to the analysis button on the menu bar. Click that, and you can see in the drop down menu we have the create calculated field option. Select that. Now let's rename this. Now let's rename this as sales per customer. Let's select the region where we have to write our expression. So for that we'll use the include option. Next we have the customer. We'll select the customer name, or even we can select the customer ID. Let's go with the customer ID. Then let's select the sum of sales. So we have our LOD expression ready. Okay, this shows that the calculation has some errors. Yeah, this should be resolved. Yeah, let's go with customer name and let's select OK. Yeah, I think we forgot to mention the flower bracket at the end. Let's try that. Yeah, now the expression is proper. So the best part of Tableau is, if there is an error in your expression, Tableau will not allow you to continue with that. It will show a warning over here. That's the best part. So now let's consider the ID back again. Yeah, this should be fine. Now let's select OK so that we have the new field, that is sales per customer, in our dimensions part. No, the measures part. Yeah, we have the new field in the measures part, that is the sales per customer. Now the next step is to use this particular field and generate the level of details. Now we have the newly created field over here. So that is basically the third part we are going to do right now. Now we are going to drag this and place it into the rows. So we have two different bar charts now, the sales per customer and another bar chart which is of sales. Now we are going to select the sales per customer and right click on it. Now we have the drop down menu, and inside that we are going to select the measure. So we have the sum measure right now as default. Now we are going to change that into average. Now we have the average sales per customer according to regions. So the average sales per customer is 796.9 units, and that is in the central region. Next we have the east region, south and west. So that's how we use the include level of detail expressions in Tableau. Now we are done with one example based on include level of detail expression. Let's try to execute another example. Now we have the sheet 2. Let's try to rename it. Let's rename it include LOD-2. Now in this particular second LOD expressions, we are going to calculate the sum of sales on per state basis. Now let's move to the analysis button on the menu bar. Let's try to select the create calculated field option. Now let's try to write in the expression name, average sales per state. Now inside the tray, let's try to add the expression include state now sum of sales. Now let's try to close the flower bracket. Yeah, now we have the valid expression. let's just select OK so that we find the average sales per state option or the newly created field in the measures section. Now let's drag the category into columns and the newly created average sales per state into rows. And we have the level of detail visualization on the screen right now. So the furniture is about 742 units, and the next one is the office, which is 719,000 units, and the last one is the 836,000 units. So this is the average sales happening in particular categories. So remember, we have three different categories in our sales superstore dataset, which is the furniture, office, and technologies. So these are the average sales happening. Now with this, we have the calculation placed on rows shelf and it is aggregated as an average, but we still have to find the sales happening by state. So with that, we have the calculation placed on the row shelf and it is aggregated as an average. So the resulting visualization averages the sum of sales by state across categories. Now let's drag this segment option into the columns. So when the segment is added to column shelf and the calculation is moved to label, the LOD expression results update. Now you can see how the average sum of sales per state varies across categories and segments. Now we have all the bars in one particular color. Let's try to change it by dragging the category into color. So we have different colors for different categories. Now let's try to drag the average sales per state into color so that we have different colors again. So this is how it works.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now with that, let's move into the next type of LOD expressions, that is the exclude LOD expressions in Tableau. So the exclude level of detail expressions declare dimensions to omit from the view level of detail. Exclude level of detail expressions are useful for percent of total or difference from overall average scenarios. They are comparable to such features as totals and reference lines. Exclude level of detail expressions cannot be used in row level expressions where there are no dimensions to omit, but it can be used to modify either a view level calculation or anything between, that is, you can use an exclude calculation to remove dimensions from some other level of detail expressions. So to understand exclude level of detail expressions in Tableau in a much more detailed way, let's get back to Tableau and try to execute some examples. Now we are back onto Tableau. Let's create the exclude level of detail expression example. So I'll be renaming the sheet exclude LOD. Now we have created a new sheet and renamed that as exclude LOD. Now this particular sheet will be used to calculate the level of details which excludes the region from a calculation of sum of sales. Now for that, let's try to create a new calculated field. For that, let's select the analysis, select create calculated field. Now let's rename this as exclude region. Now let's select OK. Okay, we didn't write the expression over there. Now let's edit it, and in the tray let's write the expression. Let's select exclude, and in that let's select region. Then let's write in the sum of sales. Let's close the flower bracket. Now let's select OK. Now we have the new field over here, which is the exclude region. Now we'll be using this particular field to create a new visualization on the screen. Now let's drag the region to columns. Let's drag the sum of sales to columns. Now let's drag the order date to rows. Now let's select the month. Let's kind of change this chart to bar chart. Now this is more likely good to view. Now let's drag the newly created field, that is exclude region, onto color so that we can have different colors. Now this particular step will help us to view the total sales by month without the regional component. So this is how the exclude level of detail expressions will be used in real time. Now we can actually make a little change to this by selecting this one and right click it, or we can go to colors directly and right click the colors and select the edit colors, and inside this we're gonna select kind of orange to blue. Orange to blue diverging, so that we can have a good level of visualization. Now let's move on to the next type of LOD expressions in Tableau, which happens to be the fixed level of detail expressions. So the fixed level of detail expressions compute a value using the specified dimensions without reference to the dimensions in the view. Now let's get back to Tableau and try to execute an example based on fixed level of detail expressions in Tableau. Now we are back on Tableau. Let's create a new sheet and rename that sheet as fixed LOD. Let's type an enter. Yeah. Now let's get back to the analysis menu. Let's create a calculated field. Let's rename this as sales by region. So we have the sales by region over here. Now let's get back to the tray and try to add in our expression. So we shall be using a fixed expression over here, fixed, and now let's type in region, then sum of sales. Let's close the flower bracket. Now the expression is valid. So we have the sales by region LOD, which is the fixed LOD. Let's select OK, and you can see the newly created field on the measures section. Let's drag the region onto rows, and then let's drag the state into the region of rows. So now we have a text table. Now the view level of the detail is region plus state, but because fixed level of detail expressions do not consider view level of detail, the calculation only uses the dimension referred in the calculation, which in this case is region. So because of this, you can see that the values of the individual states in each region are identical. If the include keyword has been used in the level of detail expression instead of fixed, the values would have been a little different for each state, because Tableau would add the dimension in the expression, that is the region, with any additional dimensions in the view state when determining values for the expression. Now with this, let's get back to the presentation again. So the next segment in this particular today for our discussion is the tables versus LOD expressions. So now we'll be discussing the differences between the tables and LOD expressions. So the first one is filters. Filters involved in table calculate behave like hide, and filters involved in LOD calculations behave like exclude. The next difference is table calculations are generated as query results, whereas the LOD expressions are generated as a part of query to the underlying data source. The third difference is table calculations are capable to generate either equal or less granular than the said LOD or level of detail. But whereas on the LOD expressions case, the level of detail expressions can generate results independent of the said level of detail. The fourth difference between the both is table calculations are used as aggregated measures, whereas the level of detail expressions can be used in other constructs. The final differences between the table and LOD expressions is the dimensions that control the operations of a table are separate from the calculation syntax, whereas in the LOD expressions, dimensions that control the operations of an LOD are embedded into the expression itself. Now with that, let's continue with the next part of this particular tutorial, where we will be discussing the limitations of LOD expressions in Tableau. So following are the limitations of LOD expressions in Tableau. So the first one is LOD expressions behave unreliable views when floating values are involved. So LOD expressions that reference floating point measures tend to behave in an unreliable fashion when used in a view that requires a comparison of the values in the expression. The next one is LOD expressions will not be shown in the data source. So the LOD expressions will not be available in the data source page when you are using them in real time. Followed by that, the next limitation is you should always keep in mind when referencing a parameter in a dimensionality declaration, always use the parameter name and not the parameter value. Followed by that, the next limitation of LOD expressions in Tableau is with data blending, the linking field from the primary data source must be in the view before you can use an LOD expression from the secondary data source. So first up, what exactly is data blending? So data blending is a method for combining data from multiple sources. Data blending brings in additional information from a secondary data source and displays it with data from the primary data source directly in the view. So it might be a little complicated to understand, so let us make it a little simple. Let's imagine that you have data. Some of your data is present in your SQL database, and some of your data is present in Excel database or Excel worksheet, and some data is present in your cloud, say Salesforce. So your duty is to combine all your data from different sources, that is SQL, worksheet, Salesforce, and work on it. So you might have a question here. We already have joins, but joins and relations have their own limitations or drawbacks. So to cover that up or overcome those issues, Tableau has come up with data blending. Now let us take a step further and understand what exactly I meant by joining and relationships and data blending. So as we discussed before, the data blending is a method for combining data from multiple sources. Data blending brings in additional information from a secondary data source and displays it with data from the primary data source directly in the view. Yeah, this was a definition. You can take a screenshot of this and you can keep it for further reference. Now, as we discussed, there are some existing ways to combine your data, such as relationships, joins, etc., etc., and then we have the data blending option. So first, relationships. So why exactly we do not prefer relationships in a few situations? Relationships cannot be formed between tables from data sources published to Tableau Server or Tableau Online. So relationships can't be formed based on calculated fields. When you use data blending, you can create calculation fields. Those are called as data blending calculations. Now next thing is the joins. Joins combine tables by adding more columns of data across similar row structures, and this can cause data loss or duplication. So when you use joins and create the relationship between multiple data sources or multiple tables, then there is a chance that the data can be duplicated. So just imagine that you have two different tables, and the two different tables have one common field such as ID. So even a student ID has ID and employee ID has ID. If you use a join, then there are chances that you might get IDs of both employee and student. So that's a duplication, right? So to avoid that, you can go with a data blending. Now, data blending, unlike relationships or joins, never truly combine the data. Instead, blends query each data source independently. The results are aggregated to the appropriate level, then the results are presented visually together in the view. That's the reason why we use data blending. Now up next, we have the data blending example. Now this is where we get into the practical mode. We'll get back to our data first. We'll see what kind of data we are going to use for this particular example and what are we going to do with that data in the Tableau.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So this is the Excel sheet which has the car sales dataset that we'll be using today. So this is one of the datasets, and we have another dataset. So we have another dataset which I personally created. So this is a little similar to the cars dataset. So I've created this dataset a little bit similar to the car sales dataset so that we can use this in the scenarios of data blending so that you can understand the concept in a much better way. So we have the following columns: the manufacturer, model, resale value, engine size, horsepower, wheelbase, fuel capacity, fuel efficiency, annual sales, and region. And when we come into the bike sales, we have the same kind of columns. So we have the manufacturer, model, engine size, horsepower, fuel capacity, fuel efficiency, annual sales, and zone. So you can see that this zone and region from the car sales dataset are similar, but the name is different. So there's a reason I've created a different name for this particular column, so that while we are working on Tableau data blending, we'll be actually blending these two columns as a custom blend. So this is why I've named this particular column as zone. And yeah, so far so good. I think we are good with the dataset. Now we'll get back to Tableau and start working on these datasets. Yeah, so now we are on Tableau. Let's since we're working on Excel, let's create the Excel. And yeah, here we got our Excel files. First, let's click in car. Yeah, there we go. We have the car dataset over here. And if you see, we have got some additional columns which we don't need. So the actual column we had was this. When I downloaded the dataset, this was the actual column which has sales into 1000. Actually, we had 16.919, which I multiplied here. Okay, so I had made some changes to the dataset in the Excel file, and I've hidden the actual dataset, so we don't need this one over here. So we'll do the hide option over here as well. So that's gone over here. Now let's kind of rename this as annual sales. Enter. And we don't need this F column, so this particular F column was created for a formula on Excel into sales into 1000, so we don't need this one as well. We'll remove this, hide, and the resale value, and another F1 here. We'll remove this. Now engine size 1, why don't we rename that as engine size? Done. And do we have any other extra things? No. And annual sales too, yeah, that's gone as well. So the region, manufacturer, model, annual sales, resale value, engine size, another engine size. Okay, this was a problem. So when you look into the engine size over here, okay, and here, so when you look at the engine size here, this is the actual engine size from the datasets, the original one. So it is represented in the form of liters. So basically the car engines are always represented in the form of liters. So 1.8 liter engine, 3.5 liter engine. But when you come into bikes, they represent the engine size in the form of cc's, that is cubic centimeters. So the bikes have 650 cc engine, 1030 or 1340cc engine. Yeah, that's how we represent the engine size in bikes. So to make things similar, I have created the engine size in cc in the form of cc over here. You can see that over here. So 1.8 is equals to 100 or 1800 cubic centimeters. So we don't need this particular column here, so we'll eliminate this or we'll hide this. So far so good. We have horsepower, engine size, resale value, fuel capacity, fuel efficiency, region. Yeah, everything is fine now. So now the next step is to add the second data set or the second data source. So you can do that by selecting this particular icon over here and select a new data source, or there is another way. You can enter into your worksheet, and you don't have to enter into your worksheet. You can do that from here as well. You can select the data and add new data source. So these are the various options. You can select a new data source from here, or you can select a new data source from here, or if you're on the sheet, then you can go again to the data section and you can select the data source from here as well. Or you also have a shortkey. So when you see it, so you have a shortkey here which says control. Okay, sorry. So you can read it right on the right hand side of this particular dialog box, control D. You can directly press Control D and add your new data source as well. So now we'll add the new data source. So since another data set that you're working on is also an Excel file, we'll select the Excel file. So that was bike sales, and yeah, there you go. We have a bike sales data set right on my screen right now. So in here as well, you can see some excess or unnecessary columns. So we'll remove that as well. So we'll hide this, we'll hide this, we'll hide this as well. Now we have engine size, horsepower, fuel capacity, efficiency. Okay, we have our annual sales here. So I've changed a few numbers in this particular annual sales column. These are not accurate, so I've created some random numbers just so that they're different from the car sales. So yeah, so far so good. We have this zone over here, the regions column from Yeah, let me show you that. Let's go to the sheet. Yeah, so when you see cars, we have region over here. Okay, so when you get into cars, we have the region over here which has the north, south, east, west, and similarly when you get into bikes, we have the zone which has the north, south, east, west, etc., etc. So we are now going to create the blending between the two data sets. So we have the data set over here, which is the bike, and we have another data set over here, which is the car. So to create a blend, let's get into data, and you can see the edit blend relationships row in the dialog box, or the option in the dialog box. So remember, when you just have one data source, just imagine that you only had a cars data set, only one data set. Or let us remove this. How do you remove this? Close. So we just have one data set over here, which is the bikes data set. So now when you click on data, you don't have that option. See it, you don't have that option, edit blend relationships. But when you get a different data source, so we have car sales over here. Now let's get back our okay, did we had the cars over there? Sales bike, we have the bike sales over here. Now let's get back our cars data set. Yeah, okay, sorry, we can make the changes again, not a problem. So we'll remove this, we'll rename it. On this note, let me tell you guys, if you are getting some errors, or if you're getting some kind of troubles while you're learning, it's a sign that you're trying your best. So we have Simplilearn community, which has the solutions to your problems. So if you have any problems while you're learning, then you can directly post your query over there, and our team of experts will be really happy to help you out with the solutions. So we have our annual sales over here, and another annual sales which we don't need, so we'll hide that. We have the manufacturer, model, annual sales, resale value, engine size. So I think we don't need this engine size, which is in the liters. Now we'll rename this as engine size. Great. Yeah, we were done. So we'll get back to our sheet. Now when you hover over to data, and you can find the data blend relationship option over here. So this happens when you have multiple sources only. Now let's click that, and you can see we have the automatic option, and Tableau has automatically found a data blend option for the columns which have the same names. So we have manufacturer, model, and manufacturer and model in both bikes and cars. So we also have the same names for annual sales, engine, fuel efficiency, horsepower also. So they are in the measures section. That's the reason the Tableau has ignored them. So, and remember that we have regions in cars and zone in bikes, but we can't find that relationship over here because they have different column names. To get a blend between those columns, we can always choose custom. So when you choose custom, okay, we don't have a zone over here. You need to make some changes, I guess. Yeah, we need to press add icon, and from add you can see the region from the cars dataset and zone from bikes dataset. Select OK, and then you can find a blend relationship between the region from cars and zone from bikes. Now we have the blend successfully applied. Let's select OK, and we are done. So let's begin with our operations. So currently we are in bike sales dataset. So if we start the operations on bike sales dataset, for example, let's choose zone into columns and annual sales into rows. So you can see a little tiny blue tick over here. So this particular little tiny blue tick represents that this has now become your primary data set or primary data source because you're currently working on that particular data set. Now, if you remove the zone and annual sales, and again, if your sheet is completely empty, and if you enter into the cars data set, and again, choose regions and regions onto columns, again, the same thing, drag the annual sales into rows. Like I'm just showing you, if there is some operations happening with the particular data set, then you can find the blue tick icon which says that you're working on this particular data set. So that's how we see it. Now, so this is how you find the sales happening in that particular region. And yeah, we can create another sheet, and now we'll see which model has the biggest engine. Now let's kind of sort it. So Viper has the biggest engine, Dodge Viper. Yeah, a muscle car of America. Now let's create a different sheet. Now let's get back into bikes dataset, which is the most fuel efficient bike, row and model. So now, according to the dataset what I created, Multistrada 950 has the biggest mileage. That's great. Okay, it shouldn't give 50. Maybe I think I entered some wrong value. Yeah, SV650. Or we can actually take a manufacturer over here. And so SV650 belongs to, let's sort it. Where is SV650? Yeah, SV650 belongs to Suzuki. Great. So SV650 has a good mileage next to Multistrada 950. So this is how you can use sheets and data from different datasets. Now moving forward, let's create some data blending calculations. For that, let's create a new sheet. Now we have created a new sheet. Now let's rename it as Data Blend Calculations. Now we have successfully renamed our sheet as Data Blending Calculations. Now we are in car sales. So let's drag the manufacturer into columns and sales, annual sales of the manufacturer into columns. So we have the report of annual sales of different car manufacturers over here, Ford leading, and we have Porsche, Subaru, Suzuki, Hyundai, etc., etc. Now let's get back to bike sales and drag the same annual sales from the bikes dataset into rows. So as you can see on my screen, you have the annual sales for cars and bikes together on one single screen. So here we have Suzuki as well, which is a bike maker, and Ford, etc., etc. are the car makers. So other than bikes, we have another 28 nulls which do not belong to the bike section. Now our aim is to create a new calculated field which is about the data blending calculation. So you can see that a little icon over here which represents the blend icon, and you can always select that to stop the blending, and you can click on that to use it as a linking field. So that's how you can use the blend icon. Now we are about to create a new calculated field, so you can right click and create a calculated field, or you can always choose the icon over here and create a calculated field. So now we have the calculated field over here. Let's rename it as Data Blend Calculation. Now we have successfully renamed our calculated field as Data Blend Calculation. Now we'll find the sum of sales happening in cars and bikes. So for that, we'll be using the summation of sales or annual sales. Now we have the annual sales sum of bikes. Now we'll add the cars one. For that, I'll be selecting plus and sum of annual sales of cars. So you can see that we have two sums over here, so we don't need that second sum, so we'll eliminate that. So we have another bracket over here which we don't need, so we'll eliminate that as well. So now the calculation field is valid. Let's click apply and OK. So now you can see a newly created calculation field over here with the icon equals to hashtag, which says that it's a calculated field. Now let's drag this calculated field into the rows icon, and you can see the sum of both sales happening in this particular segment here, which shows you the sum of sales of both cars and bikes. Now you can see that we have 28 nulls over here, right? So we should be having all the, when you're calculating the sum of annual sales of both the data sets, then you should be having something over here. So for that, we need to make a little addition over here. That's a function zn. Yeah. Now after adding zn, okay, we lost the sum, so we need to add the sum again. And sum of annual sales, or we can just add it over here. Okay, this should be pretty good. Now we need to add another zn over here and another sum over here. Close the bracket. Yeah, this should be good. Yeah, the calculation is valid now. Let's add apply, and okay, now we have the annual sales of both cars and bikes and Suzuki combined, BMW combined as well. So that's how we do the Tableau data blending operations. So with that, let's get back to the presentation mode again. Now the next part in our tutorial today is the data blending versus joins. So what are the differences between data blending and joins? So this particular short data table should explain you the differences between them. So in data blending, the data gets aggregated first, then the data gets combined. But where in joins, the data will be joined first or combined first, then the data is aggregated. And the second difference is when we use data blending, the data set is from different data sources. But when you use joins, you need to make sure that the data is coming from a single source. Now when we come into the data blending again, you can only use left join. So you can consider data blending as an advanced version of joins, but only the left join can be applied. But when we come into joins, we have the different types of joins like left joint, right joint, etc., right? We have different types of joins. So that's how we have a difference between joins and data blending. The fourth difference is data can be available in different level of granularity in data blending. So the level of granularity can be maintained at a different level when you have, or different levels when you use data blending, but when you use joins, all the granularity of all the data should be maintained at a same level. And the last difference between the both is data blending sends separate query to each dataset and aggregates, then performs blending. And the last difference between the both is when you use data blending, the data blending sends separate query to each dataset, then aggregates them, and finally performs data blending operations. But when you use joins, the queries will be sent to the data at a row level. So with that, let's enter into the next segment where we will discuss about the limitations of data blending. So the limitations of data blending are as follows. Data blending compromises the query execution speed in high granularity. So when you have the higher rate of granularity on your datasets, then obviously the execution speed will be compromised. Next, while sorting a calculated field that uses blended data, that field is not listed in the sorted field drop-down dialog box. And the last limitation is cube data sources can be used only as a primary data source to the blend data in Tableau and cannot be used as a secondary data source. Now without further ado, let's directly begin with the one-point agenda, that is the charts in Tableau. So for the charts in Tableau, I'm using two different datasets to just make things look a little bit more interesting. So the first dataset that we will be dealing with is the Amazon Prime TV dataset. So this particular dataset has the following columns: the serial number, name of the serial, year of the release, number of seasons, language, genre, IMDb ratings, and age of viewers. So we will be using this particular data and we'll try to extract some insights from this data using the charts in Tableau. So followed by Amazon Prime TV dataset, we have another dataset called as the Tableau Superstore dataset. So this particular dataset is a sample dataset available in Tableau Public and it is open for all. You can take this dataset and try to extract some insights from this as well. Now without further ado, let's try our first chart, that happens to be the bar chart. So what exactly is a bar chart? As you can see on the left side, we have a sample image which explains how a bar chart typically looks like. So a bar chart basically represents the data in the form of rectangular bars with the length of the bar proportional to the value of the variable. Now this might be a little deviated, I can understand that. So to understand this in a much more better way, let's get back to Tableau and execute some practical examples and understand what exactly is a bar chart in a much more detailed way. So here we are on the Tableau. So you can see I have already executed some examples on the Amazon Prime dataset, and we have all the charts that we'll be going to discuss today. We have the bar chart, Pareto chart, side-by-side bar chart, text chart, tree map, etc., etc. Now why am I showing this? So I have actually saved this dataset, or what do you call it, as book. Yeah, we call it as a book in Tableau. So I've executed all the charts and I have saved this in the form of a book in the Tableau public. And I'll also give the link to this particular book so that you can have a reference to this and you can try to execute your examples on your own in your local system. Now for our reference, let's try to create a new sheet. So we can name this new sheet. Just double click on that. So I'll rename this as bar chart 2 so that we don't have a confusion between the existing bar chart and the new bar chart. Just press enter and it's done. So to execute a bar chart, let's select genre and drag it down to columns, and the Prime TV shows and drag it down to rows. Now you can see that we have a bar chart here which explains us we have different genres such as action, comedy, adventure, animation, etc., etc. So now let's kind of sort it. So now you can see in the particular type of genre, which is drama, we have the most number of Prime TV shows. So basically the audience would like to see the drama based seasons or serials at the most compared to others. So remember we discussed the length of the bar, which shows the volume of the variable. Let's get back to the definition once more. So you can see a bar chart represents data in the form of rectangular bars. That is, we have the data represented in the form of rectangular bars, and continued with that, with the length of the bar proportional to the value of the variable. So we have the drama at the maximum number of series. So 125 number of shows based on drama. So this happens to be the biggest one, and followed by that a little smaller one which has a little less number of seasons or shows, which is the type genre comedy. So you can see that if the value is bigger, the volume of the length or the length of the bar is bigger. So that's how the bar chart works in real time. So it basically shows the biggest bar for the biggest amount of data. Now followed by the bar chart, the next chart we have is this side-by-side bar chart. Now what exactly is a side-by-side bar chart? So a side-by-side bar chart is completely similar to the bar chart. No rocket science or nothing big difference in between the bar chart and the side-by-side bar chart. If we get back to Tableau, you can see that we have different genres here. So we have drama, comedy, kids, action, etc., etc. So if we wanted to change this into a side-by-side bar chart, then we can add one more data into the columns, which happens to be the name of the show. So what exactly will be happening here? So we will be getting few more bars over here. So those few more bars will be of the name of the show. So in the genre of drama, we'll be having different shows, right? For example, the show name A is in the form of drama, show name B is in the form of drama, and followed by that we have AA in comedy, BB in comedy. So that's how you categorize. So basically the bars will be represented, that's for sure, and the data is represented in the form of categories. So we have few serials in the drama category, we have few serials in comedy category. So that's how it happens. Now let's see that practically. Now let's drag the show name to columns and we'll see that happening. So you can see that happening over here. Now let's kind of sort it again. Yeah, it's sorted. So you can see we have the first category, that is the arts, entertainment, culture. So in that particular category we have different shows, Tommy Little and Son of Abisha and Paul Chowdhury, etc., etc. So basically we have categorized them and we have the side-by-side bar charts comparing each other. Now we'll get back to a little farther, and there you can see we have the genre here and the series happening in this particular genre. So this is the drama genre, and inside that we have various amount of series, the Good Fight, the Good Doctor, etc., etc. So that's what the bar chart does in real time. So basically we had the same bar chart, but the only difference is the fields were divided in different categories. Now followed by the side-by-side bar chart, the third type of chart that we will be having today is the Pareto chart. Now what is a Pareto chart? So Pareto chart has bars and a line graph. So far we have discussed bar charts. We will also discuss the line graphs in the further section. So line graph is no different from bar charts, but the only difference is you can see here, right? So if we pull out the names, so we have this bar chart. So we can actually change this chart into a line chart just by clicking on line. So you can see this has converted into line chart. So we will deal with that in a little more detail. We don't worry about it. So this is how a line chart basically looks like. So I have explained you the line chart just because we have the two different types of charts in the Pareto chart. So there is an inclusion of a bar chart as well as a line chart or the line graph. So a Pareto chart has bars and line graph. The individual values are shown in descending order by bars, and the ascending cumulative total is represented by the line. So we will understand the definition in a bit more detail practically by getting back onto Tableau. Now let's get back to Tableau 1. So now we are back on Tableau. Now let's create a new chart or new sheet. Let's rename the sheet as a Pareto chart. Don't worry, we have already a Pareto chart over here. I'll just rename it as Pareto 2. Don't worry, at the end of the video, I'm not going to save anything onto this particular book. We'll be having the book as it was when we started the tutorial, so that you don't have to face any duplications in this particular book. So Pareto chart 2. Enter. And now we have the Pareto chart 2 over here. So to create a Pareto chart, let's drag the genre into the columns. Yeah, now we have the genre into the columns. Now into the rows, we'll drag the number of Prime TV shows based on that particular genre. So now we are back on the bar chart now. Tableau has automatically selected the type of chart to be used for this particular data, which is the bar chart. Now let's right click on the genre, and now you can see a sort option. Now we have the dialog box over here. Let's select the sort by option by field, and let's select descending order and aggregation by count. So we'll select this, and the aggregation is count, and it's done. Let's close it now. Now the second step is we will drag the Amazon Prime TV show dataset again onto the rows. Now we have two different bar charts. Now everything starts from here. We'll change few things so that we create a proper Pareto chart. Now we will select or right click the second count Prime TV shows, and now we will select dual axes. Now you can see the chart has changed itself into the dots type. Now you might have a doubt. We had two different bar charts. Now we just have one axis, that is y-axis and x-axis, and the two charts have gone into one. So what's happening here? So what's basically happened here is we just merged the x-axis of both the measures. So we have the measures over here, right? The count of Prime TV shows and the second count of Prime TV shows. So we have basically merged the x-axis of both these measures. Now we'll enter into the step 3. So now you can see on the marks card, we have two different count Prime TV shows. So we'll now select the first one, and inside that we have the pop-up of marks card where we have the options of selecting the kind of charts for our data. And now for the first one, we will select the bar type of chart. Now you can see that we have the bar type of charts over here. Now we will select the color for our bars. So to select color, you just need to select the color option, and inside that we have various types of colors. Now let's select kind of green. So we have green over here. Now let's get back to the second count of Prime TV shows, and inside here let's select line. So we have line over here. Now we can actually kind of select the color for that as well. Now we'll select some opposite color for that. Let's select pink, or you can also go with orange, kind of more visible. Yeah, we are done with the color selection. Now the next step. Now we'll get back to the second measure over here. Now we'll right click it, and inside that we will select add table calculation. Now we'll select the calculation type, and we needed the running total of this, and we're gonna compute this using table across. And the most important step is the last step, to select the add secondary calculation. By clicking on this, we'll have another dialog box, and we need to add some more details into this one. So here we'll be selecting the difference from, and we'll change that to % of total. And next we'll select the table across, which is the default one over here, and we are done. So as discussed in the definition, the individual values are shown in descending order by bars, and the ascending cumulative total is represented by the line. So you can see the individual values of the genre are represented in the form of bars, and the ascending cumulative total is in the form of line. So this is how we use the Pareto chart in real time in Tableau. Now moving ahead, the next type of chart that we will be discussing today is the text chart. There is nothing much of a rocket science in text chart. It's just a simple tabular way of expressing your data. Text charts are created by placing one dimension on the row shelf and another on the column shelf. Text tables are also called as crosstabs or pivot tables. Now let's get back to Tableau and try to execute a simple example. As you can see in this particular book, I have already executed a text chart. Now to avoid confusion, let's try to recreate another sheet and rename it as text chart 2. It's done. Now let's drag in the genre and the name of the show to the rows. So you can see that the Tableau has automatically selected the text chart for this particular data, and we have our text chart over here, which shows us the genre, which is action, the name of the show's under genre category, and similarly action, comedy, adventure, animation, etc., etc. Now with this, let's continue with our next type of chart. So the next type of chart that we will be dealing today is the waterfall chart. So the waterfall chart displays the cumulative effect of sequential positive and negative values. It shows where the value starts, ends, and how it goes there incrementally. So the waterfall chart is a little complicated than the other charts. Now I want you guys to follow me up a little bit more cautiously. Now let's continue with the waterfall chart. So for that, let's drag the language from dimensions into columns, and Prime TV shows data from measures to rows. Now we have our bar chart over here. Now the next step is select the Prime TV shows data, which is in the rows. Now the same thing is in the measures as well. So keep in mind that you need to select the Prime TV shows from the measures. Let's right click on that, and you can see a create option, and inside that select the calculated field option. Now let's rename this, and remember to add a negative symbol. Now I'll tell you why we are going to add the negative symbol. As we progress into the waterfall chart, we convert this particular bar chart into a Gantt chart as a step of the process. So in that particular stage, we might have to make some space between the bars. So that's the reason we have selected negative of count over here. You'll see that happening in the next steps. Now you can see we have a new measure, which is a negative of count. Now let's drag and drop that onto our size option in the max card. So you can see I've selected the negative of count, which is in this particular case. The complete uppercase is for the first waterfall chart what we made. So we have our chart over here. Now let's get back to our rows. Click on this option. Now we have our quick table calculation option, and that will be selecting the running total. Now we are almost done. Just one step is remaining to convert this particular chart into a Gantt chart. So there you go. We have our waterfall chart over here. Now the next one in the list is the heat maps. So you can see how a typical heat map in real time looks like. So a Tableau heat map is used to display the data along with colors. We can create a heat map using one or more dimension member and measure value. Now let's get back to Tableau and try to create a heat map. Let's create a new sheet. Rename it as heat map 2. Enter. And there we have our heat map. Now let's drag in some data to create a heat map. So for that, let's select genre from dimensions and drop it down to, no, we're not going to drop it. So we'll be selecting both the data at once. So the genre one. Now let's hold the control button and select the number of seasons from measures. Now we will go to show me option, and you can see that we have various options over here. So this particular icon is for heat maps. Now let's select that. Now we have the heat map. Now let's drag the IMDb rating from the measures into size. And this one, IMDb ratings into size, so that we have the different sizes for the boxes over here. So the biggest one here and this next leading one over here. Now the problem is we have the same color for all the boxes. Now for that, let's try to drag the genre into color so that we have different color for different genre. So that's how the heat maps are done. Now the next chart in the list is the Gantt chart. So a Gantt chart looks something like this. Now what exactly is a Gantt chart? Gantt chart shows the progress of the value of a task or resource over a period. It is used in project management and other types of variation study over a period. Now to create a Gantt chart, we will be using the second dataset, which is the Tableau Superstore dataset. So I have already created a Gantt chart over here. This is how a sample Gantt chart looks. So we have discussed that a Gantt chart is used to study the variation in the standards for over a period of time. So here we are selecting the first class, same day, second class, standard class deliveries over a period of time. So we have the dates over here, or we can say that the period of time has been selected in the form of dates or day. Now let's recreate a Gantt chart and see how it's practically done. So for that, let's create a new sheet, G. Now we'll follow this in a step-by-step way. First, let's drag the order date into columns. Now let's select this or right click it and change the order to day. Now we have the days 1 to 30 in a month. Now let's move on to the menu bar and let's select the analysis button, and in that let's select create calculated field. Now we have our calculation tab over here. Now let's type in the calculation. Now we are going to use this particular Gantt chart to study the shipment. Now once the creation of Gantt chart is done, we will study how the shipment is done based on what kind of class is selected for shipment as the days passed. Now inside the calculated field, we'll write the formula date difference. So this is the one, and inside that we'll be going to select the day, next order date, next ship date, so these particular order date and ship date are from dimensions, so just when we type them, we had them readily available. Now our formula is ready. Let's just select OK. Now in the measures segment, you can see we have a new input or new addition, which is the ship, the formula what we just created. Now we are going to select this and drag this onto the marks card, and on the marks card we are going to drop it on the size. Now our Gantt chart is almost ready. The only thing remaining is to drag the ship mode to rows so that we can have the details of that particular shipment mode, the standard one, the first class one, etc., etc. So for that, let's drag in the ship mode from the dimensions to rows. So there you go. We have a shipment mode. Now the next type of chart that we will be dealing with today is the pie chart. So pie chart represents data as slices of a circle with different sizes and colors. The slices are labeled volume and the volumes are represented in the form of a chart. Now let's continue with the pie chart. So to create a pie chart, let's select the language option from dimensions and hold Control button and select the number of Prime TV shows. And you can see the show me icon over here. Let's select that, and inside that you can see a pie icon over here. So just select that and we have a pie chart over here. Now I can see that the pie chart what we created looks a little bit smaller, so don't worry. Now let's just select the standard option here. From that, let's select the entire view, and there you go, we have a little bit more bigger pie chart. If you're still not convinced with the size, you can just go to the size option and try to increase the size, and there you go, you have the pie chart. Now the next type of chart available in our list is the bubble chart. So the bubble chart looks something like this. So bubble charts display data as a cluster of circles. Each value in the dimension field represents a circle, whereas the values of measure represent the size of those circles. Pretty simple. Now let's get back to Tableau and try to execute a bubble chart. So this is how a standard bubble chart looks like. Now let's create a new sheet. Rename this as bubble. Now let's select genres from dimensions and number of seasons from measures. Now the genre will help us to know a particular value, and that particular value will be a circle in the bubble chart, and the number of seasons will provide the size of the bubble. That means the highest number of seasons for a particular genre will be having the biggest circle. Now let's select the show me, and inside that you can see the bubble chart. Let's just select that, and you can see we have different circles and different sizes of different circles. Now we have the same color for all the circles. To change that, let's drag genre into color, and now we have different color for different genre. Now the next type of chart that we will be dealing is the histogram. Histogram is one of the simplest charts available and also easiest to create. So histogram is a chart that displays the shape of a distribution. Histogram looks like a bar chart but groups values for a continuous measure into ranges or bins. Now to understand this better, let's get back to Tableau and try to create a new chart. So we are back on Tableau. Let's rename this as histogram. Let's just select enter. Now let's select the IMDb ratings. Now we'll be using the IMDb ratings measure to create a histogram, and we'll be having the biggest bar for the highest rating of IMDb. Now we have selected IMDb rating. Just hover over to show me tab, and in that you can see the histogram tab over here. Let's just select that, and we have the histogram chart on our window. So there are many shows, and each and every show has specific number of IMDb ratings. So a maximum number of shows are having 7.2 as the IMDb rating. Now followed by histogram, we have the next type of chart, that is the highlight table. So highlight table is completely similar to the text table that we have already dealt with. The only difference is we have various colors for various data cells inside that particular table. Now in Tableau, highlight tables are used to compare categorical data using color and represented in the form of tables. That's what we discussed. Now let's get back to Tableau and try to create a highlight table. Let's create a new sheet and rename it as HD. So to continue with the highlight table, let's select genre from dimensions and hold Control button and select the number of seasons available. And when you hover over to show me, you can see a table called highlight tables. Let's select that option and you can see we have the highlight option over here. Now you can see that we have different colors for different number of seasons available in that particular genre. Now you can see that they are not ordered, so let's just select the sort option and sort from descending order. So there you go, we have the highest number of seasons available for drama, that is 339. Now the next type of chart that we will be dealing is the line chart. So a typical line chart looks something like this. So the line charts connect individual data points in a view. They provide a simple way to visualize a sequence of values and are really useful when you want to see trends. Now let's get back to the Tableau, and here we are going to use the Superstore dataset so that we can have a look on the trends. Now let's create a new sheet and rename it as line 2. Now let's drag the profit into rows and see if the profit is increasing day by day or not. As you can see, the Tableau has automatically selected the line chart for us, and there you go, we can see that the profit is increasing day by day or year by year. We can just kind of select the plus icon over here and see we can have a quarterly update over here. So Q1, Q2, Q4 of the year 2014 and 2015, 2016 and 2017, the Q1, Q2, Q3, Q4. So that's how we use the line graph. Now the next type of graph that we will be dealing is the bullet chart. So a normal bullet chart looks something like this. So a bullet graph is a bar graph that replaces dashboard gauges and meters. It is used to compare performance of a primary measure to one or more measures. Now let's get back to Tableau and see how a bullet chart is made. Now let's create a new sheet. Let's rename it as bullet 2. Enter. Now for a bullet chart, we'll start with the analysis button on the toolbar or the menu bar. Click analysis and now select create calculated field option. Now inside that, let's try to set an average for profit. So we can kind of estimate a profit over here. So let's rename it profit estimated. So basically we are going to use the bullet chart to estimate the profit in future. Now inside that, let's have an average value. So average value of profit must be something nearly 250 to 300. So just write in 275,000. Just select OK. So this is the average what we're expecting. This must be the average amount of profit that we should be facing in the near future. Now we have a new measure in the measures section, that is the profit estimated. Now just select that and hold Control, and now we're going to select profit. Now we are going to hover over the show me option, and there you go, we have the bullet graph option over here. We're going to select that, so we have the bullet chart over here. So there you go, we have the bullet chart over here. We can kind of increase the size of that as well. So there you go, that's how we use the bullet chart in real time. Now the next type of chart that we will be discussing today is the scatter plot. So scatter plot shows how points are scattered in Cartesian plane. It is created by plotting values of numerical variables as x and y coordinates in the Cartesian plane. Now let's get back to Tableau and see how scatter plot is used in real time. So we are back on Tableau. So a scatter plot should be looking something like this. Now let's try to recreate a new scatter plot sheet. Let's rename it as scatter plot 2. Now to create a scatter plot, let's try to drag the genre from dimensions into columns and the sum of seasons from measures. Now we have the bar chart by default. Now let's just select the marks card, and inside that let's select the shape option. Now we have the data scattered across the different points in the Cartesian plane. Now just select the genre and drag it into color. So we have different colors for different genres. So this is how the scatter plot looks like. Now let's continue with the next type of chart. That is the area chart. So an area chart is a line chart where the area between the line and the axis is shaded with a color. Now let's get back to Tableau and see how exactly an area chart looks like. So an area chart looks something like this. So let's try to recreate area chart once again. New sheet, A2. Now we're going to see how the sales are happening according to a particular area. For that, let's select order date and hold control and select quantity so that we can have a sheet which shows us the sales happening in quantity on particular dates. Now we have the show me tab and we have the area chart option over here. Let's just select that and we have the area chart over here. Now you can see that we have one single color for all the sales and quantity. Now to have the details of the regions, like in what region what kind of sales are happening in what quantity, we want to select the region and drag that over color. So we have 4 different colors for 4 different regions: the central, east, south and west. So this is how we use the area chart. Now followed by area chart. Now the next type of chart that we will be dealing is the dual axis chart. So what exactly is a dual axis chart? So a typical dual axis chart looks something like this. So dual axes are 2 independent axes that are layered on top of each other. According to Tableau, dual axes allow you to compare multiple measures. Now let's get back to Tableau and try to create a typical dual axis chart. So a typical dual axis chart looks something like this. Now let's try to recreate this one. Create a new sheet, D2. Now the dual axis chart is really simple to create. Let's select order date from dimensions, hold the control key. Now you want to select the quantity from measures. Now again hold the control key. Now you also have to select the sales options. So we have selected the order date, quantity and sales. Now we are going to select the dual axis chart from show me. So we have the dual axis chart on my screen right now. So what we are going to learn from this is we are going to learn the quantity of sales happening according to the years. So in the year 2014 we have the quantity of sales which is something around 7.5k, and it has grown gradually from 2015, 16 and 17 and reached above 12k. So this is what we get to know from dual axis chart. So the number of sales happening and the quantity of sales happening. So the line shows us the number of sales and the bar shows us the quantity of sales. Now with this, let's continue with the next type of chart in our list. So the next type of chart that we will be dealing is the symbol map. So the symbol maps are simply maps that have a mark displayed over a given longitude and a latitude. So now we are back on Tableau. Now let's try to execute the symbol map. So symbol map looks something like this. So we have the number of sales happening in a particular country and a particular city. Now to create a symbol map, let's select city, hold control, country, and again hold control and select sales. Now you can see that we have 2 different maps over here. The first one is symbol map and the second one is maps. Now let's select the symbol map and there you go. We have the symbol map over here. Now we have the same color for all these sales. Now let's kind of select sales and drag it to color. So we have different colors for different amount of sales happening. So the darkest one shows the highest number of sales and a lighter one shows the least number of sales. So that's how we use symbol maps in real time. Let's get back to the presentation again. Now the next type of chart that we will be dealing with today is the map chart. So a map view is one data point created since geographic role is assigned to a country. Tableau creates the map view as shown in the image here. So similar to the symbol maps, we can use the maps which shows the amount of sales or profits or anything happening in that particular country or city. Now let's get back to Tableau and try to create a map. Now a sample map looks something like this. Now let's try to create a new map. M2. Now to create a map, let's select country and hold control, and now let's select kind of profit. So let's select the map icon here, and so now we have different colors for different profits. So this particular state or country says that we have a profit of 286,397 numbers, or it might be even dollars or something. We can also select the country and hold control and select sales, and now we can also select maps again. So this is how the map chart looks like. Now let's get back to the presentation, and the next type of chart that we will be dealing with today is the tree map chart. So what exactly is a tree map chart? So the tree maps are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measures to define the size or color of the rectangles. Now let's get back to Tableau and try to create a tree map. So you can see that we already have a tree map. Now we are back onto the Prime TV dataset. So we have used the genre and we have used the sum of IMDb ratings to create the tree map over here. Now let's create a new sheet and try to recreate the tree map so that we can understand how to create a tree map in real time. Let's rename it tree map. So the tree map is being recreated. Now just select the genre, and from that hold the control key and select the IMDb ratings, and now hold the control key again and select the number of seasons available. And now when you hover over to the show me tab, you can see the tree maps icon over here. Let's just select that. So there you go, you can see the tree map on the screen right now, and we have different colors for different genres. So the darkest color for the drama has the number of, or the highest number of IMDb ratings and the highest number of seasons available, and similarly so on. Now the least one is the comedy, arts, entertainment, culture, with the least IMDb rating of 6.2 and only the number of seasons available are 1. So this was the last type of chart that we had to deal with today in this particular Tableau charts tutorial.
Today we will be building dashboards from start to finish. First about world population, then health. Next we'll build a dashboard about economy, and finally we'll build a dashboard about business ease. I would recommend getting access to the dataset before you start this tutorial so you can build along with me. If you would like access to this dataset, please comment below and we'll get you access. So first we're going to build a dashboard that revolves around population. So we're going to build a map based on country. So I'm going to double click on country, and it's going to map out all of the countries. And then on our marks, I'm going to change it to map. So it's a filled in map. And we want this to be colored by population total. And we can see who contributes the most to population. We're going to label it with population as well. But you can see that it's labeling it the total population, and what we want to label it is how much it contributes to population by percentage. So let's add a table calculation, and we're going to have it do percent of total based on country. Okay, so now we can see which countries contribute what percent. Let's also bring the country name onto the label, and let's put it on top. So country name's on top. Now it's getting a little bit crowded in here, so we're going to unclick Show Marks Label, and we're just going to show the ones that we want to see specifically. So we can right click on China here, hover on Mark Label, and click Always Show. And on India, since these are our two biggest contributors, we can see that this one's a little bit darker than the others in that area. And here. And that's just a manual way to choose which ones have indicators and labels and which ones do not. And we're going to put a note here. So we're going to annotate an area that explains that China and India contribute the most to world population. just calling out this section of the visualization. And let's name this sheet. So here we have our visualization, and when you hover you can see both the total population and its percent contribution and the country name. Our next visualization for this dashboard is going to be population over time. So let's bring on our time element. But one trick for bringing on a time element, if we just drag it on, so year with the calendar mark here, if we just drag it on, it'll default to a discrete version. So let's take it back off. And then we could edit it there. But one thing you could do is if you, on a Windows machine, you right click on it and drag it on, then it will pop up with a dialog box that allows you to select what kind of date value you want to use in the first place. So we're going to use year here. And now we have, instead of discrete, we have a continuous axis. And we're going to bring on population total. And we can see that over time. One thing you can do when the value is up so high in your axis is you can uncheck this box that says include 0, and it will not always include 0 in your axis, but this can be misleading. So you can see that it looks like population growth is something really dramatic by increasing that slope of the line, whereas it really wasn't quite as dramatic as it seems. So as long as it's communicated well and you're not doing it to mislead your users, you just need to keep in mind that this include 0 can change what your graph is saying. So we're going to not include the 0 at this time, just so that we can focus in on our data a little bit. Now we're going to add our forecast. So we're going to click on forecast and drag it on, and it adds the forecast to our visualization right there. And now we can right click here and see forecast result is actual and forecast. So you can see that the forecast picks up here in 2012 and pushes out what it thinks it'll be in 2013 as well. You can change how far out that forecast goes by right-clicking on the line and clicking forecast option. And we can change, it says automatically the next 2 years, but we could change it so that it's the next 10 years. And it will go out into the future, out to 2022. You can change prediction intervals, or if you don't want to show them, you don't have to show them. And this is just kind of a visual guide for those prediction intervals. Okay, and then you can also have your trend line show, where it shows your trend line following out from where your population growth is, and also the trend line for your forecast right there. And we'll call this world population trend. Excellent. And we're going to make one more visualization for this, and it's going to be a pie chart. So the pie chart is also going to be based off of population. So we're going to click on population, and we're going to control click on country and come over to show me and click your pie chart. Great. So I'm going to make this the entire view so we can see the pie chart better. And this is getting really crazy in here. And so I have changed my mind, and instead of country, I'm going to drag region over top of country. And now we see something a little bit more manageable. So we can see that here's Asia, and it makes up the biggest piece of the pie, and then here is everybody else. So right now, each of these is population total, and we could keep it that way, or we could do what we did last time and change it to percent of total, so that on hover we can see the population and the percentage of population that it contributes. So for this pie chart, we're just going to show Asia versus everybody else. So we need to make a group. And what we'll do is select all of these, and we're going to right click and click group. So now we have all of those things we selected, and we have other. Let's edit our group. Right click, edit group. We're going to rename this group Asia because that's all that's in there. And we're going to rename this group Rest of the World. Okay, so now we have our group. We can drag it onto label, and we can see Asia and Rest of the World. And now see how it's breaking it up into those different sections? That's because we still have region on our detail right here. So we pull region off. Now it's just split Asia, Rest of the World. We can change our colors. Make it a little bit more visually interesting. Now we can still see our percentages. And now let's rename it, and then we'll put it all together on a dashboard. Great. So let's make our dashboard. We have this new dashboard button down here, and you can choose what sizes you want. So we have a fixed size where you just select the width and height. We have automatic, which will just fill your screen, and we have a range, which has a minimum size and a maximum size. Some of the good things about fixed is that once you have it, you can have it always look that way, so no matter where they're looking at it, you know that it's going to be laid out the way that you expected. However, if somebody's looking at on a screen that is bigger or smaller than yours, then it doesn't fill up the screen, or it will fill up the screen too much and they'll have to scroll up and down and left and right. If you have automatic, then it will fit the screen that it's displayed on. However, the things that you've placed might get squished too close together. And then the range gives you a minimum size and a maximum size, meaning if the screen is too big, it still won't fill up the screen, but it can get closer, and then as they get smaller and smaller screens, you at least know that it will never make it get smaller than this particular size. So there's some benefits to that as well, where you still have a little bit of control of what it will look like in the end. Great, let's bring on our worksheets. And you can see that where you hover, it fills up that space, and that's where it's going to show up. You can also adjust the lines in between different visualizations for things that need more space or less space. Another important thing to recognize is that when you click on a visualization, like this one, up here it will tell you how it's viewing that visualization within that space. So if you click standard, then it will do a standard fit, versus if you have entire view, where it will make it fit inside the box. Over here we could have fit width or fit height. On some of the visualizations it doesn't make as much of a difference. However, when you have a visualization that maybe has a lot of text in it and they need to be able to scroll, you'll want to have it fit width, but you don't want it to fit height, because then it will shove all of that information into the box and not allow you to scroll up and down. So if you saw, as we dragged these on, it took these legends and added it to the left here. We can modify that and make them floating and drag them next to the visualizations that they are relevant to. And this particular one has a couple of things wrong with it. We might not want the title of this to be region group, so we could come in and we could edit the title and then maybe just call it region. However, I don't think we need this legend at all because it's very clearly marked on the visualization there. So you could also just remove it from the dashboard. And this one is telling you how big of a circle it would need to be before it gets to that population number. So it belongs to this circle as well, but again is unnecessary potentially because we have our two population numbers showing up right as we hover. So we'll remove that as well. So at this point, we have a visualization, or 3 visualizations all on the same page, which is the basics of a dashboard. However, we might want to be able to interact with them a little bit more than just hovering. And so this is where we should look into adding filters. So we have information over time, we have information by country, and we have some information by region here. One of the quickest things you can do to add functionality to the dashboard is by clicking this Use as Filter button. So if we click this, that means whatever country we click on here will filter the other visualization. And then you can unselect it to go back. Now, that Use as Filter button actually creates an action here, filter 1 generated, that it's made on its own. Now you can see that when we click on China, it doesn't make a lot of sense to have this pie chart update based on that China click, because it's just going to show duplicated information. So it shows the 20% or the 20% here and the 17 billion. And then here it does the same thing, except for it shows 100% because it's filtered everything else out of the chart, so it now makes up 100% of the circle. So that doesn't make a lot of sense. So there are ways to format your visualization or your actions, modify your actions so that they only affect the things that make sense. So we can come here and click Edit. We're going to call this country action, and we want it to use the population by country sheet and then modify only the trend. So now when we click on China, we see China's trend over time. And it doesn't affect our pie because that doesn't make sense for it to affect our pie. We might want to select on our pie Asia or rest of the world and have that affect the other visualization. So we can click Use as Filter here and click Asia. And now it zooms into Asia on our map and shows us just the Asia world population trend. And here's rest of the world, and we can see that Asia is grayed out. And there's the rest of the world, and here's the rest of the world population trend. We might also want to be able to use this to filter to a certain year. So if we click Use as Filter, then we click on 2011, you can see these numbers are slightly updating. So this is 19%, and we come here, 19.5%, come down here, and we can see that the pie updates a little bit, although it hasn't been anything dramatic, but you can kind of see it over time. So that's one way to add filters to your visualization. Another way is to use actual filtering instead of just actions. So if we come back here to our trend, we could take the year, we're going to control click and drag it onto filters. And now we have a year filter, so we could have it the actual year number, so just look at 1 year at a time, or a range of dates. So if we click range of dates, that makes this slider from 2000 to 2012. So if we hit OK, we'll right click and we'll click Show Filter. We can see it here, and as we drag this, it updates, but kind of messes with our forecast. So let's not do a year filter in this case. So we click Remove Filter there. But maybe we want a filter just on this for the different years. So let's drag year onto the filters. We're just going to do the year number next. And here's all the years. We're going to let all of them be selected for now. And then we're going to show the filter. And here's all of our years. And we can change the way that our quick filter shows up, and we can make it like a drop down, so they can still select multiples, but it's a drop down. Or maybe we want this visualization to be just 1 year at a time. So we could choose single value in a list, and it lists out all the years, or in a drop down, and we want it to be 2012. And then we want this to show up on our dashboard. So we come to the dashboard and we click more options here, hover over filters, and we can see the filters available, and we can click year of year, And now our formatting hasn't passed on. So that's one thing to remember, that formatting it just on the workbook doesn't necessarily mean that the formatting will pass over to the dashboard. So I tend to not do any formatting on the workbooks and just format it on the dashboards, because the dashboards are what I publish. So we're going to single value drop down. We're going to add it, we're going to move it to the top. So now how we do that, let's talk a little bit about what each of these sections are. Come here to layout, and you can see we have this layout here, item hierarchy. So tiled is the whole screen, and inside of that we have a horizontal container. And inside this horizontal container we have another horizontal container, and when you click on something in this view, it shows you where it exists. So we can see this horizontal container is outlined now, and then we change it to vertical and it outlines this. Now a horizontal container allows things to be side by side, and a vertical container allows things to be one on top of the other. And so in our vertical container we see all this extra space for extra things to be on top of each other. But if we wanted to have it at the top, we would maybe want things to be able to be side by side. So if we go back to the dashboard and we grab horizontal and drag it to the top, it adds a horizontal container up here, and now you can see everything that's floating kind of stays in the place that it was, even though all the other things shifted. So that's one of the disadvantages of floating, is that you're kind of just manually choosing where it will stand using your X and Y position, and it's not dynamic. So let's give us a little bit less space up here. We can add a text box into our horizontal container, or we'll say population dashboard. We can format it. Now we have our title up here, and then we can add our filter. We're going to drag it to be on inside of our horizontal container, but on the side here. We can give it more or less space. Let's bring our legends down to places where they make sense again. Perfect. And so now we have this that will affect this only and show you just 2012, 2011, 2010. So we don't want it to affect the trend, because we want the trend to show all of time. And just looking at 1 year for this trend that is only at a yearly part and forecasts into the future doesn't make any sense. But we maybe want it to also affect this worksheet so that these two are in sync. And so that the dashboard is basically for 2012, except for the trend, which shows you the past and the future. So one way that you can do that is clicking Apply to Worksheets here, and you can choose Selected Worksheets, and it will show you all the worksheets in this visualization, or in this dashboard. And you can click Show All Worksheets in Workbook, and then if there were other worksheets, it would show them. So we wanted to do Asia versus rest of the world and population contribution by country. Okay? And that's another way we can change what year they show. So it's only going to show 1 year at a time, unless we select all. And then this visualization isn't affected by it. If we don't want to click on a country and have it make the change, if we instead want to have a filter for country, we can do that by taking country and dragging it onto filters. We'll have it show all for now. And then when we go back to our dashboard and we come to this visualization, we can go filters and add country. And it's just added it side by side where we had our other filters, so that's a nice feature of Tableau where it can kind of guess where you might want things. We're going to do multiple value drop down, and right now it only affects that visualization, and we can just look at one country at a time. And we might not want it to affect this visualization because it doesn't do us any good to just look at one region in a pie chart. But maybe we want it to affect the world population trend, so we can do the same thing we did before. And we want it to affect these two. We'll click OK. And so now we could look at all of these countries, and that would update both these visualizations. Another thing I like to do on a filter is customize and click Show Apply button. And this means we can make all these changes in here. See, I've selected none, however, these visualizations aren't updating. And then I wanted to look at Turkey, so I found Turkey, and then I hit Apply, and that's when they update. Perfect. So now we have a dashboard complete with filters and actions. We also have a title on our dashboard. We can give it a little bit less space, and some legends. We have titles on each of these pieces. However, if we didn't want a title here, we can click Hide Title, and it will just show our visualization there. And this is dashboard number 1. Here's what it looks like in full screen mode. Full screen mode is a good opportunity for you to test it to see what it will look like to the end user. I press escape and get back out, and it doesn't give you these highlights when you hover over things that are dashboard formatting related. You can see that all those extra lines went away, and it just gives you the opportunity to test out your dashboard in a more real way and see how they will use it instead of giving you the dashboard editing options.
Next, we're going to make a dashboard revolving around health information. So first we're going to make a map about birth rates. So we're going to call it birth rate rank map. And to make a map, we're going to double click on country, and we're going to change it to a map type, so we have a filled map here. And then we're going to bring birth rate onto color. So let's define our colors a little bit by clicking on this color part of the marks card. We'll click Edit Colors, and we're going to change it to red and gold. And the idea here is that the red is for a higher birth rate, which is more associated with countries that have poor health. So we'll hit Apply, and now we have our higher birth rate countries highlighted in red. Next, we're going to create a class. So we're going to duplicate birth rate, and let's edit that field. We're going to call it birth rate class. And so we're going to say that anything that is in the top 50 countries with the highest birth rate is categorized as having an alarming birth rate. So we will first do the average birth rate, and then we're going to do a rank on that. Did you see sometimes when you're auto-completing your statements, it will replace one of these functions that you have with the one that you pressed tab for? So if I type if, or I start to type if, and then I come here and click on if, it replaced my rank with if. So keep an eye out for that if you're like, where did my thing go? It's because I was typing it right next to it. So if I put a space and then I start to type if and I click if, it will not delete rank. So we're going to say if the rank of average is less than or equal to 50. So if it's in the top 50, then alarming birth rate. Else if, and we can take this again, is greater than 50, then normal birth rate. And always make sure you put on the end. Also, we didn't necessarily have to have this else if statement. So if we had just done else normal birth rate, that would have covered all of our bases. So with these if statements, just make sure that you're always getting all of the different options that you want. But in this case, we defined both. However, we didn't have to define the second calculation, because if it is not in the top 50, then it's obviously in the bottom, the rest. So we're going to hit OK. And then we're going to put birth rate class onto label. And it's gone around and labeled everything. And I am seeing alarming birth rate on everything. So let's see what the problem is. So if we open this back up by right-clicking and clicking Edit, you can see it says results are computed along table across. So we're going to click Default Table Calculation here, and instead of compute using automatic, we're going to change it to compute using country. We'll hit OK and hit Apply. And that didn't seem to fix it. So this is the first place I would look if it's not doing what you would expect. So we'll put it back to automatic. Okay. The second place I would look is inside of the table calculation that is created. So when we defined rank here, we put a table calculation on it. So when we right click here, we get edit table calculation. And we're going to choose that we want to do the rate based on the specific dimension of country. So now we can see, using the logic, the calculation assistance, that we no longer have just alarming birth rate. We have normal birth rate and alarming birth rate on our screen. So we can close this. And we are done here. But one thing you can do is, when we have allow labels to overlap other marks selected, then it will make sure that every label shows up, but it gets super crazy in there. So there are some times where the labels may overlap a little bit, and so you'll want to select this option. In our case, we don't want that. And now we have a visualization showing birth rate map based on rank. Our next visualization is going to be about average life expectancy, male versus female. So we're going to do a chart across time. So we're going to click year and bring it onto columns, and we're going to change it to this year in the continuous section. So now we have an axis, and we're going to double click on female life expectancy. Oh, there we go. Double click on female life expectancy and then double click on male life expectancy. So what that did was made us two charts, one on top of the other, but we don't want that. So we'll take this off, and we're going to drag male life expectancy right onto this axis for the female life expectancy. And what this has done is made what's called a blended axis chart. So it's not a dual axis chart where we have another axis over here for the second visualization. This one is a blended axis chart. So they necessarily use the same axis, and they necessarily have the same kinds of marks. So we'll take a look and see what the difference is there. So if I were to change this to a bar chart, we would have bar chart for both of them, and I can't define one separately from the other. Change it back to a line chart, and they're both a line chart. Now if we go back to when we just had female life expectancy and we drag male on next to it and we have two charts, now we can change it to a dual axis and we have one on top of the other. However, our axes don't line up. We can see at the top here is 15K and over here it's 14K. So we're going to synchronize the axis, and you can see one on top of the other. And we have two marks cards. So we could have this one be a bar chart and that one be a line chart. So that's some of the differences of those two. We're going to do a blended axis chart. So I'm going to take male and drag it here. And we have our blended axis chart. And now you can see that our scale here is really strange. So what it's doing is it's adding up all of the life expectancies for all the different countries instead of averaging it. So we're going to change that by right-clicking on the measure down in this measure values card, hovering over measure sum, and we're going to change it to average. Since I only changed one of them and they share the same axes, it's really spread out now and it almost looks like a straight line down there. And then let's change the other, and it should get everything a little bit more in sync. There we go. So now we can see the average life expectancy over time, which for both of them seems to be going up. However, it seems to be higher for females. Now let's take a look at our analytics, and let's drag on forecast. So it's forecasted out the next 2 years for both lines. And we'll bring on trend onto linear, and let's change it to a square. So now we see each individual point for the life expectancy for females and males, and we can see what they're expected to be in the future and our trends. And our next visualization is going to be a heat map about multiple different measures, so we'll just call it a heat map for now. And for our heat map, we're going to look at the different countries. So we'll bring country onto rows, and we're going to look at their birth rate. So I just double clicked on birth rate and brought it on. We're going to look at their health expenditure percentage on GDP, so how much they spend on GDP. So when I double clicked on it, it did what we did before, where we have a measures value card, and so now whenever we put measures on here, that determines what goes here, because we have our measure names on columns. So every measure in here, their name is going to define the name of the column, and the values define what's in the text right here. Great. We're also going to bring on infant mortality rate and the life expectancy for females. Okay. So now it has changed these to not have decimal points after them, which is not as helpful. So we're going to format those, and you can format it field by field. So for birth rate, we definitely want to have decimals afterwards. As a matter of fact, the birth rate is a percentage. So instead of doing a number standard, we'll just go to percentage. And now we don't need to have those decimals afterwards. We can just look at the birth rate as a rate. And for percent of GDP for health expenditures, we can come click there and do the same thing. And for infant mortality rate, okay. And to make this make a little bit more sense, we again need to change it from a sum to an average. And for some of these, we could change it from a sum to an average right inside of the, well, for all of these, we could change it from a sum to an average in the default properties under aggregation, so that it will automatically average it whenever we bring it out. Default is sum, but if we make it automatically average, then we won't have to do that again for any other visualizations. I won't do that at this time because I get a little bit confused sometimes when I don't have my sum on there by default, because that's what I'm so used to seeing by default. Great, so we now have a matrix by country and by our different metrics here, and so we can take our measure values and drag it onto color, and we'll make our marks from automatic to square, and it will make our heat map. Now, what happens with a heat map is it colors darkly the higher the number it is in this case, and right now it's doing it for the whole area. So 1% is obviously much, much smaller than 82. But if we wanted to be able to look at birth rate independently from life expectancy, we can right-click on the measure values on the color and click Use Separate Legends. And so now we have a legend for each one of these. Let's change the colors on those legends so that we can see them separately a little bit more clearly. So we'll change the colors by coming over here to each of the legends, and we'll leave one the same, but we'll change this one. If we click Edit Colors, you can see our different palettes. You can see some of them just have one color, others have one color to another color. We used the red gold before. So now you can see that one is changed. We could use another one that goes from green to blue. Great. You can also define your own. So you can make a custom one that could go from light to dark, and then you can choose what color you want as your dark color. So we could pick a lighter blue, and then we see that last one. And now with these separate color palettes, you can quickly see the difference with birth rate and spending on health. And that is our heat map with separate legends. So let's build this all into a dashboard now. We're going to call it our health dashboard. And for simplicity, we're going to make it automatic so it fills our screen. And then we're going to first bring on our map. We're going to bring on our health related map with birth rates. Then we're going to bring on our heat map. And we'll bring on our life expectancy lines. Now, as we brought on all of our charts, it brought in our legends here. And we're going to move our legends up to the top. So let's add a horizontal container. And then let's put our legends into the horizontal container. And let's put these ones in order. So life expectancy. Oh, so birth rate is going to be over here. Great. Now, one thing we can do is make these smaller. Well, that's actually just making that one bigger, huh? Okay, so you would make them smaller by making something else bigger or by adding in a blank space, which would then help you adjust the size by taking up the space that you're not using. Another thing to pay attention to is this fixed width. So once you start to drag the size on something, it no longer is dynamic. So if we unfix that width so that it's only taking up whatever space is left. Oh, and that one is not fixed width. And then we can edit the width on this to be even bigger. Then it will squish things over to where we would like them to be. So that's one of the ways you can add space or make things the size you would like them to be. Now let's take a look at filters. Oh, before we take a look at filters, I want to look at this map one more time because I think that it would be useful for our colors to be a little bit more distinct. So one quick way to navigate to your worksheet from your dashboard is to click this Go to Sheet button. And while we're here, I'm going to click on Color, Edit Colors, and we did red and gold, and we're going to change it from this sequence to a stepped color, and we're going to change it to 3 colors. So it's going to either be this color, this color, this color, and when I hit OK, you can kind of see it's a little bit more dramatic in our differences, and it's put everything into the 3 categories we defined. So let's go back to our dashboard, and we can see the difference there. And now we're going to take a look at our filters. So we want to be able to filter by country. So let's bring country onto filters, and we're going to allow it to use all. And we're going to, here you can click Apply to Worksheets. And you can click Selected Worksheets, and it's going to pop up with all the worksheets in the whole workbook. And so one disadvantage of doing it on the worksheet is that you can see all of the worksheets in the workbook, and you have to differentiate between which ones are on the dashboard and which ones aren't. And these are the 3 on this dashboard, so we're going to hit OK. And we're also going to do it by year. So when we drag the year onto filters, we're going to allow them to choose years. So we're going to do the distinct number of years. We'll click Use All. Okay. And we're going to apply to the worksheets this one with the birth rate and the average life expectancy male versus female. We're not going to filter down our line chart by year because we want to be able to see it over time, and if we filter down the time, then we don't get as much context. So we'll hit OK. Let's go back to our dashboard. If I click on more options here and hover over filters, you can see that year filter and that country filter. You should also be able to see both of those filters on the heat map because I told it to apply to that one as well. So here's the country. Oh, I made a mistake. Let's go back to this visualization and apply to worksheets. Selected worksheets. See, I wanted it to be on the birth rate and the heat map, not the line chart, and I clicked the wrong one. So that was a good test. So when we go here to the heat map and click down, you can see now we get the year of year as well. So we'll click year of year, and let's put it over here, and we're going to make it a multiple values drop down, and we'll bring it over to the middle. And let's also get the countries filter. Great, so now that we have these in here, we don't need this to be so big, so let's edit the width and make it 300, even smaller, 200. Great, and let's change our country to be a single value drop down, so you can pick one at a time. And let's also change it, or this year of year, since we can select multiples, let's change it so that on customize that you show the apply button. So here, since they can only select one, we don't have the apply button because it will just automatically apply. And here, since they can select multiples, we'll let them unselect all and pick their years and then hit apply, and then you'll see the changes. And you can see that even though I've selected only 2011 and 2012, you still see all of the years on this line chart as expected. And there is our health dashboard. Our next dashboard is going to have to do with economy. Our first sheet is going to be another map that is going to have to do with overall GDP. And as we usually begin with maps by double-clicking on country and changing it to a map mark type. And this time we're going to bring on GDP onto color and change it to average. And we can edit the colors. Let's this time do a custom diverging, so you get to pick both colors. And let's pick a little bit lighter. Okay, red for there, and then we want to do maybe like a deeper green. And that way, you can see who has the highest GDP, which is green. We hit apply. Okay. And then it will eventually get lighter and lighter until it goes to gray, which then it will lead to green. Okay. And next we're going to make scatter plot, which we will call GDP versus GDP per capita. So GDP, or gross domestic product, versus gross domestic product per capita or per person. And to make a scatter plot, you have one measure on one axis
and then another measure, which is going to be GDP per capita, which we will now create on the other axis. So let's start with GDP, and we'll hit duplicate, and let's edit that, and we're going to call it GDP per capita, and we're going to take sum of GDP and divide it by the sum of the total population. So population total. What is my error? Opening parenthesis. There we go. And then we have GDP per capita. So what this will do is sum up the GDP across whatever measures we have in place, across whatever dimensions we have in place, and then sum up the population for those same dimensions, and then divide it, instead of dividing it per row and then doing an aggregation on it. Okay? So now we're going to bring on GDP per capita on the rows. And we have the sum of GDP and the GDP per capita. And to make it more than just one little mark on our scatter plot, we will drag on country to detail. And now we have one mark per country. And you can see some countries have a high GDP per capita, and some countries have a high GDP overall, but not as high of a GDP per capita. And so on. We have some middle of the road people here. So we can change this from automatic to circles, and now they're dots like you might see on a scatter plot. And you can drag region onto color, and now we can see our different regions. And we see a lot of reds here, and it's quick to see what region things belong in. Also, you can click to highlight, and you can see all of the Americas highlighted in context. The next visualization we're going to make is going to be showing how much countries spend on healthcare as a part of their GDP. So we're going to rename it to be GDP on healthcare. And we're going to look at each of our countries. And we're going to make a bar chart that shows the health expense GDP. And we're going to change this to average. And we're also going to show the health expense per capita. Over here it shows how much is spent per person on health. And this is showing how much is spent on health based on GDP. Click at the top and click sort, and it's sorting by this first one. And you can see which countries spend the most of their GDP on health. We can again bring region onto color, so we can see the different regions highlighted. And let's bring on labels. So for our different marks cards, we're going to want to control click this and drag it onto the labels. And we can see that it's a percentage, but it's coming up as a number, so we can right click and click format right there. And we're going to change the number to percentage. Maybe just do 1 decimal place. And then for this one, we're going to control and drag that onto labels. And maybe we'll change this one to currency. However, if you don't want to change it to currency, since we aren't sure necessarily what currency this data set is in, it's worth checking out what currency it is in. So for now, we'll just have it as a number. And now we're going to customize our tooltip. So we're going to go to the overall marks card, and we'll click on tooltip, and we want it to tell us the country in the top. So we'll erase region, and we're going to erase country label and center country. And then we're going to put this country spends this percentage on healthcare. And if you want to preview it, you can hover or click here on preview, and it will show you an example. Marshall Islands spends 2.1% on healthcare. We'll hit enter, and then when we hover, it tells you the country, and it has our custom tooltip on both visualizations, or on both of the different axes. So let's build our dashboard. We'll bring on our map. We'll bring on our healthcare visualization and our GDP versus GDP per capita. And we'll move our legends to the top again by adding a horizontal container to the top and bringing them up here. One thing we can do also is to give this more space. We can have it go all the way to the top, and these legends are just side by side, just above the map and the GDP per capita scatter type plot. An interesting thing you can do in Tableau is you can see this outlier of the United States is making it difficult to see the rest of the information or to visualize if there's any trend there. So you could right click on it and click exclude, and then it will exclude it from your data set very quickly. And then you'll just click this back button to get it back. Great, now let's take a look at filters. We are going to do a single filter. So let's go to this visualization, and we'll bring on country. We'll click use all, okay. And we're going to apply it to worksheets. So I showed you how we can apply it to worksheets here. You can also apply it to worksheets once it's on the dashboard. So if we come here and look at filters, we can see that country is on the filters for this visualization. But if we come down here and look at filters, we still see country because it's in the details of the information. So either way, when we add country, since I added it from this visualization, it only affects this visualization. Okay, but we want it to affect all on the worksheet. So we're going to apply to worksheets, and we can click selected worksheets, and we can click all on dashboard. Okay, let's bring this over here. We're going to allow them to see all at once and be able to scroll and select the ones they want. And now, when we select different ones, it affects all three worksheets. We're also going to add an action for a URL action. Add action, go to URL, and when we click on a country on the overall GDP map, we want it to take us to the Wikipedia page that talks about the economy for that country. So that is this URL, and it's going to say Wikipedia for economy of, and we're going to add our country to the end. So we hit OK. We have it running on menu, so let's change it to run on select. And as soon as you click it, it will take you there. Okay, so now let's try it. And we can click on Canada, and it will take us to the Wikipedia page for the economy of Canada. Great. We click on Brazil, same thing. So if we unselect on Brazil, then it will make our map highlighted normally again. We can also use this one to filter the other visualizations. And so we could click use this filter here, and then when we click on France, it will filter these two other visualizations to France. You can see that when we filter this visualization to a particular country, so if we look at Germany, Germany wasn't green before on our map, but now it is. That happens because our scale has changed just for the ones selected. So if we control click France and Germany and Switzerland and Austria, we now have a scale that reflects only these countries, and the biggest is going to be the darkest green, or the highest GDP is the darkest green, and the lowest is the lightest pink. And there is our economy dashboard. You can see that we have some nulls on these visualizations. That occurs when we don't have all of the data for every point. You can ignore those and they won't show up on the final visualization when you publish it to server, or you can deal with those by clicking on them and filtering that data out, or showing that data at the default position, which is showing the null values at 0. Our final dashboard is going to be about the ease of doing business in a country. So our first visualization is going to be a bar chart, which we will call days to start business. So how many days it takes to start a business is important to know when you're trying to start a business in a country, and also can be an indicator of how easy it will be to do business in that country. So let's make a bar chart that includes every country, and then we're going to bring on days to start a business, and we will sort it smallest to biggest. And we have some days or some countries that don't have any days, so let's filter out those countries. And we're going to filter it to only those that have a good market. We're going to make a calculated field. We're going to define business-friendly market. We're going to define our market based on how easy it is to start a business and how many days it takes. So if it takes less than 25 days to start a business, we'll consider that a good market. And so we're going to do if the days to start a business is less than or equal to 25, then else if days to start a business is greater than 25, then business might or might not work. Doing less than or equal to 25 or greater than 25 allows us to be able to define these two different markets. So we'll hit apply there. And we're going to filter it just to a good market. And we're going to look at just 1 year. We'll look at 2012, our most recent year. And we're going to color it based on region. And we can see which regions tend to have the shorter days to start a business. And we're going to move on and build our next visualization, which is also a bar chart, which we will call ease of business. So we have this ease of business field, and we can bring on the country and we can bring on ease of business. And we want to make it a measure. So ease of business is at this point looking at it like it's a string, and we can change that in our default properties and convert it to a measure, or use it up here and change it to a measure. When we try to change it to a measure here, it wants to treat it like a string, so it wants to take the minimum or the maximum. But if we here convert it to a measure, then it also automatically made it a count. So the first thing to do would be to change the data type to a number. And now we can change it to a measure and aggregate it. So we could do like the sum of ease of business. In our use case, we're actually going to do the average of ease of business, and then we want to have the smallest on the top. We do have some that don't have ease of business ratings, so we're going to filter that data out. And again, we want the year to be 2012, but how we're going to do that is by coming to this visualization and by applying this particular year of 2012. So we'll do it on select workbooks and select ease of business. Okay. And now this one also has the year of 2012 there. And we're going to segment this by creating another header. We're going to call that business friendly. And we're going to say that if the ease of business is, so I guess this is a nice thing to know. So if we start typing in what we want to see, then we can select it from a list here. But you can also interact outside of this box, so you could just grab ease of business and drag it into the dialog box here, and that's really nice. So we're going to say if it is greater than or equal to 1 and less than or equal to 3, then we're going to say it has the most business friendly regulations. Give us a little more room to look at. Okay, and this statement won't work because it's saying and what is less than or equal to 3. So you have to have ease of business in both places. And then this should say then and not the. Great. So now we're just getting an error because we don't have an end. So if that's all we wanted to do, then that's what we would do, but then we'll just do another else if. And it's already taken, this if statement goes through one condition at a time. So it's already classified everything that's between these two numbers. And so now we can just say if ease of business is less than or equal to 10, then we'll call it very, very business friendly regulations. And we'll keep going. Else if ease of business is less than or equal to 50, then we're going to call it moderate. And we're just going to say moderate business regulations. Copy that for later use. Less than or equal to 150, then strict. So the reason that this doesn't grab everything that is less than or equal to 150 is because these sections 1 to 3 and then 4 to 10 and then 11 to 50 have all been classified up to this point. So it's just getting everything else. And we're going to finally say else everything else is going to be called not preferred for business. And see if we get any errors. Calculation is valid. Let's see if this works as we expect. So we'll hit apply and we'll bring business friendly onto our rows. And now it categorizes everything based on what we said. So We want to define what order these go in, so we're going to click sort, and we want the most business friendly at the top, then we want moderate, then strict, then not preferred. Okay, so we have our top 3 that are the most business friendly, and then we've got 4 through 10, which are very, then we've got our moderate, our strict, and our not preferred. So let's bring region again onto color, and we can see which regions are the most business friendly. And we have our year of 2012 there. And now we're going to make this even more useful by adding the business tax rate onto the label, so that you can see that business friendly is like Singapore, but they have a pretty high tax rate of 27. Whereas if you get down to some of these that are not preferred, some of them have really low tax rates. So let's make sure that we're getting, okay, the right tax rate. So you can see that 27 is definitely not the highest tax rate that we have for business. But you can also see that there are places that have even lower tax rates, like Saudi Arabia, and we have 8% here. It looks like we don't ever go to that second decimal place. So let's quickly format this. Oh. Business tax rate is also text. So if we could convert our data type to decimal, and then we will format it to be a percentage, and we just need the 1 decimal place. Okay, now let's make some annotations. So we could come and click here on this mark, and then we can annotate that mark, which will make this dialog box, and it's already filled in here. And so we could use some of this information. So I'm going to copy that, and I'll put some hard returns there. So we're going to say that this country is the most business friendly, but has a business tax rate of, and let's grab the tax rate. And then we'll erase this. And we'll hit OK. And I made a typo. So Singapore is the most business friend is not what I meant to say. So I can click edit, business friendly, but has a tax rate of, and you can move this around. Draws the line to Singapore, which is the mark that we wanted to annotate. So that is an annotation on a mark. If we wanted to just make an annotation for the area, then we could point out that more business-friendly countries often have high business taxes. We could change that size, make everything fit. Now we have this second note where our user can come in and see some more information about what's being presented here. Great. And now we're going to make one more visualization, and it's going to be about phone and internet usage, because you may want to know about the phone and internet trends when you're looking to start a business. So we're going to do this one over time, so it does not need to have that year filter on it. And we're doing our continuous, our axis, and we're going to look at mobile phone usage. So I double clicked it, it shows mobile phone usage over time. And we're going to change it to average so that it's averaging it across the countries. And then we're going to bring on internet usage. So we'll bring it on side by side, so we have two visualizations. And we're going to also make that average. Now, we might not want these to share an axis because they are measured a little bit differently. And so we can make it a dual axis, but allow them to keep their independent axes. Or you can synchronize the axes and see them at their rates. However, the usage is just a little bit of a different measurement. We can have one of them be a bar chart and the other one be a line. Let's have this one be the bar chart. Okay, and then the line is in the front. You can also change which one's in the front by coming and clicking on the axis itself. And you can click Move Marks to Front, and that moves that one to the front. Okay, and now it's made each of these wide, and there's like a start point and an end point on the axis for the bar, and that comes here under Size, where they're all fixed. Or you could have it be manual, where we can define the size of the bars. So we're going to make those bars like this. And we can see them going up over time. We can also change the width of the line itself. Make it thicker or thinner. And we can change the colors here. So let's change it to orange, since red might imply that it's bad in some cultures. And now we can see our internet usage and our phone usage over time and how it's trending. And so this will all come together on our new dashboard, which is about ease of business. You can see that I have a sheet called Ease of Business and a dashboard that I've called Ease of Business, but it won't let you create a dashboard with the same name as your worksheet. So, Ease of Business dashboard. Let's have it fit the screen. And we're going to bring on our Days to Start Business visual, our Ease of Business visual, and our phone and internet visual. Let's put our legends at the top again. So we'll make our horizontal container. And we'll bring our region legend into there, and then our measure names for internet versus mobile phone. And we have a filter that already is pre-applied to two of the visualizations called Year of Year. And it's selected 2012, and if we select 2011, it's only changing this one, it's filtering out all the information for this visualization and changing this one to 2011. So let's see why that's happening. If we go to this visualization and click the Go to Sheet, we can see year of 2012 is here. Let's click Show Filter. And if we change the filter to 2011, okay, it's not showing up here, and the only filter I can see that could be removing it is this average ease of business that is removing anything that is null. So if I pull that off, you can see that we don't seem to have any information for 2011 for ease of business. And the more years I select, I'm not seeing any ease of business information. So we're going to want to set this to 2012 only, because that seems to be the only information that is useful for this visualization. So let's go back until we're back to the state we were in when we started. Okay, so here we are. Now we're going to want to remove this filter, and we're going to give it its own filter that only selects 2012. That is not connected to the other filter. So now, when we change year of year, it only changes this visualization. Sometimes that's useful to note, sometimes it's useful to put, let's do a single value drop down. Sometimes it's useful to put this right next to the visualization it affects. So if we could change it to floating and just put it like here, that makes it clear that it's just changing this chart so that people don't get confused. Another thing that we can do, that we should do on all of our visualizations, is change the titles so that they're more business or user friendly. Great. And so we have our filter, and let's use this as a filter, and that way we can click on New Zealand and we can see its most business friendly regulations, and we can see its internet and phone usage over time. We can click on a lot of different countries to see those changes. We can see that some countries have a steeper change, so some of them have adopted phone and internet usage and have stayed pretty similar, whereas other ones have only really adopted it in the last couple of years. Also, if we wanted to filter to just one country, we could do what we did before and create a country filter. Here's another way to go to the sheet. You can click this down arrow and click Go to Sheet, or you can come over here. You can see that it's highlighting a visualization over here, or a sheet, and whatever sheet I click on is highlighted over here. And there's this little pop-out arrow here that also takes you to the sheet. And we can bring country on, use them all, go back to our dashboard. We'll go to filters and select country. We'll make it a multiple value drop-down. We're going to add the apply button, and now we're going to make it apply to all the visualizations by clicking apply to workbooks, selected worksheets, all on dashboard, okay. Now we can see that if we just want to look at Afghanistan, okay, we can see how many days it takes to start a business there. It's not preferred for business, and it's internet and phone usage over time. And those are our 4 dashboards. So as a review, we have made a dashboard on population, we made one about health, we made one that had to do with our economy, and one that had to do with our ease of doing business.
So today we'll be dealing with the Tableau project. So the first dataset that we will be using for the Tableau project is based on COVID-19 data. Followed by that, we'll have another project based on the airline data. And finally, the third project will be based on space missions data. Now let's begin with our first project. So in this first project, we'll be dealing with the COVID-19 dataset, and using that dataset, we'll be getting some insights. So what are those insights? Those are, what are the total number of confirmed cases in different nations? What are the total number of recovered cases in different nations? So we'll be using the map chart for these, and we'll be finding out the insights about how are the cases going on in the current situation or in the current date or year. Followed by that, we'll also look into the insights of the confirmed and recovered cases in India as well. Followed by that, we'll enter into the next query where we'll find out the trend line of COVID-19 in the international level, like how it started, how is it going on. And moving forward, we'll create a group of Indian states and we'll find out the COVID hits there, and then we will discuss about the death rates. So highest death rates at international level and the least death rates in the international level. Then we'll enter into the next segment where we'll find out the variation in COVID-19 cases around the world. And then finally, we'll discuss the future of COVID-19 in the international level. Basically, we'll create a trend line which will give us the forecast levels of the COVID-19, like is it going to increase or is it going to decrease, or what's going to happen in the near future. So I hope I made myself clear with the queries or the insights that we're going to take from the COVID-19 dataset using Tableau. So without further ado, let's get started with the Tableau. So we are on Tableau right now, so we'll be using an Excel data file. So we'll be using the COVID-19 data file. So this particular data set is available on Kaggle, and if you don't find it there, don't worry, we'll be attaching that particular data set in the description box below. You can use that as well. Now let's just select open to get connected with that particular data. So you can see that we just got connected with that data, and there will be some minute errors in the data, or there will be some problem with the data which the Tableau might identify. And when it identifies something messy with the data, it will show you an option. Maybe you might want to use the data interpreter, so I prefer using that. So whenever I see that particular option on the left hand side, I better use it for the safer side, for being on safer side with the data. And let's also select these, not a problem. Yeah, so the data got clean now. You can see that over here. So to do that, you can also check the review results. So when you click that review results option, then you'll get into this particular Excel document, which will help you with the changes made to that data set. So you can see that the orange color one says the data is interpreted as column headers or field name, and the green box suggests you that data is interpreted as values in your data source. And now you can see that. There you go. So now we'll get back to Tableau. Now you can see that the data has been interpreted successfully by the Tableau, and everything is as expected by the Tableau. Every data element in the dataset is as expected by the Tableau, and it's really fine now. Now we'll check the columns what we have in our dataset right over here. So we have the serial numbers, observation dates, province, state, and country or region, last update, and confirmed deaths recovered. So basically these three columns will be telling us the confirmed cases in that particular region, country or state, and the deaths happened in that region, country or state, and recovered rate, and the last update, when was the last tested done, the latest tested done, and in which region, and what's the observation date, what's the observation results on that particular date, and the serial numbers, etc., etc. So we have the clear understanding of a data set now. Let's get started with the first sheet what we have over here. So according to our first query, we had to find out the total number of confirmed cases in different nations. So for that, we might want to select the country or region, and then the confirmed from measures. So for that, we'll be selecting the map chart for this, so that we have the data shown in a more appealing format. So now we have the bluer color of map on our screen right now, where the darkest color shows the maximum number of cases confirmed, and the lighter ones represent the lower number of cases confirmed. Now let's make this look a little more interesting. So for that, we can select the edit color options, and inside that, let's select the red to green diverging. Yeah, this is it. Red to green, white diverging. And as you can see, the colors are a little opposite right now. So we want the greener one in the lower side, and the red colored one on the higher side. This should be good. So let's select OK and apply and OK. So you can see that the red color now represents the highest number of cases, and a lighter red one here, you can see a little touch of red, which shows that the India's got some good amount of cases as well, and in the Brazil, and etc., etc. So even Russia has a little light green. So this shows it also has some good amount of cases, not completely green though. Yeah, so this is how it looks. Now let's rename the sheet as confirmed cases. At the international level. Now, according to our second query, we are supposed to find the total number of recovered cases in different nations. So now let's create a new sheet for that. Now for that, we'll be selecting the country or region, and then we'll be selecting the recovered, and hover over to the show me icon, and let's select the map for that. Now you can see that we have a lot of recovery happening in India. So according to the stats, we get to hear that the virus which we have in India is a little, kind of harmful than comparatively what we had in China and other states of the world, or the other nations of the world. So yeah, we have a good recovery rate in India. Now let's rename the sheet as recovered cases. International level. Yeah. So I'm naming these sheets separately because we'll be using these sheets to create a dashboard at the end. Now let's get into the third query. What we have right now is find the total number of confirmed cases in India and what are the total number of recovered cases in India. So for that, let's create a new sheet and let's select country or region and confirmed. Now we'll be selecting the text table and we have the complete data set right now. We have all the nations over here. So what we are looking for is just India. So for that, now we'll drag the country or region into filters, and inside this you can see we have an option of selecting India. Now let's search for India. GHI. So we have India over here. Let's select apply and OK. So we have the total number of cases in India. Now we can drag the state or province into rows, add all members. So in India we have all the states, and so all the states have their own confirmed cases. So this is the total confirmed state or confirmed count in India. Let's rename the sheet confirmed cases in India. Similarly, let's find the recovery cases in India. Let's create a new sheet for that. Rename it as recovery cases in India. So now let's select the country or region, recovery, and then let's close the show me icon, and now let's drag the country or region to filters, then none, select India, apply, OK, and let's drag the state or province here, add all members. Yeah, so you have the text chart here which represents the total number of recovered cases in India according to the state wise. Now yeah, this looks okay, but we can make it look a little more appealing so that it's more visible and understandable, readable. So we can make that happen. So let's make a duplicate of this and recovery cases as well. Now I would like to change the confirmed cases in India into a pie chart which looks a little bit more readable and understandable. Let's select the entire view so that we have a bigger pie chart and a little bit understandable or readable. Let's increase the size a little bit and let's select the label and select the show mark label so that we have all the numbers over here. We can even select the province or state and drag it into detail, so we have the state's name as well, or should we tag it into label? Yeah, now the recovered into label again. Yeah, there you go. We have the state and we have the confirmed number over here. So this is how we can make the data look a bit more appealing and understandable. So we can see that Maharashtra has a larger number of confirmed cases. It's the biggest state of India. So maybe, yeah, That's true. And now we'll get back to the duplicate sheet of recovery cases in India. And now let's make it look a bit more appealing by changing the way the data looks. So for this, we can select the packed bubble option. Now we can see the packed bubbles which show the recovery states happening in the Indian states or the recovery cases. So you can see that everything is looking in blue color, a bit difficult to understand. So for that, let's drag the province or state into color so that we can have different colors for different states. Yeah, now this is good. We have the country name and state name. This is fine. Now we can make it a bit more readable by dragging the recovered icon into, or the recovered pill into the label. So we have the count of recoveries happening in that particular state and that particular country. Now it's a bit more readable. Now we have Maharashtra at the leading place. We have a good recovery in Maharashtra. Yeah, that's fine. Now let's get back to the presentation mode and see our next query. So can we forecast a trend line of COVID-19? Yeah. So how it started, how is it going on? So we can do that. Let's get back to Tableau again. So let's create a new sheet. We have the new sheet over here. Let's rename that as trend line. Yeah, the sheet got renamed. Now let's select the observation date from the dimensions since we're making a trend line. So let's keep it observation date, or you can even select the last update. Let's go with the last update. Now let's select the confirmed pill from measures. So let's select a line chart, or we can do that from here as well. Okay, so we're not getting the line chart, so there might be some problem with the date format over here. So we have to change the data type of, so I think this might be something with the date. Yeah, let's select the date pill and change data type to date or date and time from string. So you can see we had string first, so now it's changed to date and time. Now we'll be getting a proper trend line. So now we have it according to the year, so we can make it according to quarter, and even in the form of months. And so if you see this a little bit readable, you can keep it that way, or you can even change to days. So yeah, I think there is some problem with date and time value. So let's keep it in the form of months. It's more readable in one screen. So yeah, it's good. Let's remove this. So we have the month update. Now let's go to analytics to create a trend line, and you can select the trend line and drag it over here and select the linear option. So you can see here we have the trend line over here which reads the R squared and P values and confirmed, and we have a formula for that. So basically Tableau creates a formula to create a trend line, so which is 5.280 exponent to the power of 8 into month of last update. So pretty complex formula, yet understandable. So this is how you create a trend line. So according to the trends, we have January, February, the quarters, Q1, Q2, Q3, Q4, and this is the first month of January. So here it is. So in January we find one. Okay, this is in billions, maybe, yeah, maybe even trillions, who knows. But based on the data we have in the last year, we have a decrement of the confirmed cases in January. So it's basically indicating that corona is basically or slowly decreasing. That's a good sign. Now let's try to find out the trend line for India. Let's duplicate this. So for that, let's drag the country into filters. We have the filter option, and let's select all. No, not all. We might want to select the Indian icon. Yeah, let's select apply. Okay. So now we have the trend line for India. Let's kind of rename it. Yeah. Even you can see a gradual drop of corona in India as well. So the number has decreased in India as well. In the earlier year, we had a lot of cases above 30 crores. Now we have nearly 20 crores. That's a good sign in India as well. Now let's get back to the presentation mode and try to select the next query. So according to the next query, can we group Indian states and find COVID-19 hits? Yeah, we can do that. Now let's get back to Tableau for that. Let's create a new sheet and let's rename it as grouped. So the sheet got renamed. Now we're going to select the country or region or province. Now for that, you can see the create option over here. Now inside that, let's select the group. Now we have to create a group of Indian nations. So select Andaman and Nicobar, hold control, select Andhra Pradesh. Now let's select a couple of states we know which are in India. Arunachal Pradesh, Assam. Don't forget to hold the control key for this, or else the options might vanish. We have Bihar, we have Chandigarh, we have Chhattisgarh, we have Dadar and Nagar Haveli, Dayu Daman, we have Delhi. Yeah, we are going to just select a couple of states just to show how group can be done. So fetching all the states in this particular column would be a little difficult, or we might even miss a few. We have Gujarat, we have Haryana, we have Islamabad, Jammu and Kashmir, Jharkhand, we have Karnataka, we have Kerala, Ladakh, Lakshadweep, we have Madhya Pradesh, Maharashtra, Nagaland, we have Punjab, we have Rajasthan, we have Tamil Nadu, we have Telangana, we have Uttar Pradesh, we have West Bengal, and let's rename the group as Indian States Group. Let's select apply and OK. So after selecting the apply option and clicking OK, so we can have a new pill in the dimensions section that happens to be Indian States Group. So what we're gonna do is drag that pill into detail option so that we can have the results on our screen. So there you go, the states what we selected are right over here, all the Jammu Kashmir, Ladakh, and Punjab, Maharashtra, Gujarat, etc., and our Lakshadweep and the Andaman and Nicobar Islands. Right, so we have all the states of India right on our screen. Okay, let's expand it a little bit. Scrolling on Tableau is a little bit difficult. I don't know how to select the default option for the screen. Yes, we can see these states. I don't know where the scroller is at. Yeah, we can always undo what we did in Tableau, so that's the best part. Now let's drag the states pill again so that we can have a perfect map in the screen right now. Yeah, I would like to not to mess with it again. It's pretty good right now. Let's keep it as it is. Now let's quickly get back to our presentation and check out our next query. So find the highest death rates at international level. So we are basically going to find which nation or the country has the highest death rates, and which is the country with the least amount of death rates, so which is the safest country. Now let's get back to Tableau. Now we're not going to mess with this particular sheet. Let's create a new sheet. Let's rename the sheet as highest death rates. International, INTL. Let's enter. So the sheet got renamed successfully. Let's drag in country. And let's drag in confirmed cases. So we have a map over here. So Tableau basically kind of selected the map as default. We can drag the deaths, and now we can actually change this to a text chart. Now let's drag the measure names into rows, so we have a little bit more, sorted kind of data. So you can see we have the confirmed cases over here and death rates here. Now if we kind of sort it in the descending order, yeah, so the order is being changed now. So we have our charts processed by Tableau for a better visual. So our chart got rearranged or ordered in the descending order. So with that we have the highest deaths and confirmed cases in US. So we can even do that using a parameter where you can create the top 10 or top 5 nations with highest confirmed and death values. So for that you can drag both, or no, you need to create a parameter. I think it's not required over here. Let's continue with the next sheet, or you can just simply duplicate this. Since the dataset is a little huge, it takes a little bit of time. Now let's rename this. Yeah. Now let's rename this sheet. It's still taking a little bit of time. Yeah, now I think we can rename it least death rates. So now for that, we're gonna rearrange it in the descending order. Ascending order. So yeah, after sorting and changing some layouts, we have the least number of cases or death rates in the country called Makkah, where we have least number of deaths and least number of confirmed cases. So with that, let's move into the presentation mode again. And in the presentation mode, we have our next query that says, can we find the variation in COVID-19 cases around the world? So for that, let's create a new sheet again.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So after changing some arrangements, or by making an ascending order arrangement and changing the layout or the orientation and everything, we have our final result, which states that we have the least number of deaths and confirmations of COVID-19 in the country of Afghanistan. So yeah, so we have the pretty well sorted, arranged data over here on the screen. Now let's get back to the presentation mode, and in the presentation mode, the next query that we have to deal with is, can we find the variation in COVID-19 cases around the world? Yeah, we can do that. So let's get back to Tableau and create a new sheet. Let's rename the sheet as variation of C19. Yeah, it's done. So to find out the variation of COVID-19, we might want to use the boxes and whiskers chart. Let's select the country or region pill from dimensions and confirm from measures. Let's hover over to the show me tab and select the box and whisker plot. Yeah, so you can see that we just have one box or whisker over here. When you see something like this happening on your sheet, then directly head over to analytics and uncheck the aggregate measures. So we have this kind of visualization. Maybe we forgot something, so we forgot the country or region to be placed in columns. So when you place it in the columns section, then you find out all the countries and the variation of COVID-19 in their region. Now let's sort it in the descending order so that we can find out the maximum variation which is happening in France. So of course there are less number of confirmed cases, but there is a lot of variation which states that they have something wrong with the climatic conditions or the weather conditions there. Yeah, we have a larger confirmations in or larger cases in US, but there is some data which shows that France is leading in some variation. Yeah, so since we are calculating the variation of the confirmation of COVID-19 presence, we have France in the first place, where it shows that there is a lot of variation in the confirmed cases in France rather than US. Yeah, that's how we can find the variation of presence of COVID-19 in a particular country. So with that, let's move into the next query. So the next query is, can we forecast the sheet of future and reference of COVID-19 presence? Yes, we can do that. Let's get back to Tableau. For that, let's create a new sheet and rename it as forecast of COVID-19 presence. So the sheet got renamed successfully. Now we'll select the observation date from the dimensions and confirmed fill from measures. So we'll use them, drag it to columns, and the confirmed from, yeah. Now we're going to change this. Okay, there is something wrong with the observation date, so for that let's select the observation fill and change the data type to date. Yeah, so far so good. Now let's select this to day. We can change that to year. Now let's select forcat option. Yeah, so this is how it's gonna be. So in the year of 2020 we had the confirmed cases around this number, which is 760,7053464, so which is nearly 76,370 lakh. And in the 2021 the number got a little decreased, which is 17,130 lakh cases, and in the end of 2022, which is the forecast, we can see there is a little more drop. So it's a good sign that the COVID-19 is getting decreased. So this is the forecast of the COVID-19 presence in India. So we can change the path to step 1. The line is okay, the line is pretty good, no worries on that. So basically we've finished the queries on our presentation mode. So yeah, if we get back to the presentation mode, so all the queries on the COVID-19 data are finished. Now let's create a dashboard. Yeah, we have the dashboard right now, so we can change the layout of dashboard. Let me increase the width to 1320 and decrease the height to 70 or 760. So we have the entire screen right now. Now let's drag in the confirmed cases of international level and the recovery cases of the international level. Yeah, now we have it. Okay, or let's keep it in the top and that in the bottom. The trend line of COVID in the international level and the highest death rates in the international level. It takes a little time. It's still taking a little bit more time. I don't know what's wrong. Okay, it should be done in some time. Let's wait. It's basically taking a lot of time because we have a lot of data in that particular sheet. Let's kind of change that a little. Now let's change the sheet to yeah. Or we can just remove this from the dashboard and select the least death rate or the top 10 least death rates. So we have the sheet right over here. We have the top 10 ones only here. Yeah, this is good. So this is how we can have the dashboard. And now let's create another dashboard for Indian results. So again, let's change the dimensions of the screen. Yeah, it's pretty good. Now let's take the confirmed cases in India and drop it over here, and recovery cases in India and drop it over there, and trend lines in India over here, and Indian states, and the forecast somewhere over here. And if we get back to the dashboard 1, we can even add the forecast data or the variation data somewhere over here. And we can always change the height so that it's a bit more visible. So we can rename the dashboard C19 International Dashboard, and this one as C19 Indian Dashboard. Yeah, so with that we have finished the first project based on the COVID-19 dataset. Now we'll continue with the next dataset, that is the airline dataset. So now we are in the second project, and the second project is about the airline dataset. And in this particular dataset, we're going to take the insights, which are as follows. What are the total number of flights which are taking off in a day from the San Francisco airport? And followed by that, we have the next query, which reads out, find the busiest day of San Francisco airport. We'll be finding out the top 5 busiest days in the San Francisco airport, and followed by that, we'll also find what are the total number of flights per day in a month. Then we'll find out what are the top 10 busiest flight routes. Then we'll find out what are the top 10 longest flight routes from San Francisco airport. Then we have to represent the flights flying outside the San Francisco towards different parts of the world using a map chart. So these are the queries that we'll be executing in our second project. Without further ado, let's get back to the Tableau. So now we are back on the Tableau dashboard. So let's select our dataset for today. So our dataset is somewhere here. Yeah, this is the air travel dataset we were looking for. Now we got our air travel dataset loaded onto Tableau. So remember I said about the interpreter. I'll select that and show all the. Okay, let the query execute. Yeah, so the interpreter query got executed. Now the data has been cleaned. We can review the results by clicking on review results option over here. We have another query executing now. So basically this query will take us to the Microsoft Excel sheet where our cleaned data is readily available for us. There you go. You can see that the red colored data is the data that is interpreted as column headers or field names. The green color one is the data interpreted as values in your data source. So it looks something like this. So we have our data fine over here, just looking fine. Now when you come into the route column, you have San Francisco to the other parts of the world. For example, we have Los Angeles here, etc., etc. But we don't have a separate field for origin and destination. So what we'll be doing is we'll be splitting this particular column right away here. So let's navigate to the last column, which will show us the route. So you can right click this and select the option of split, which will basically split it into 2 halves, which will give us the from destination or the origin of the airplane, and to or the destination of the plane. So from, to, or the origin, destination fields we have right now over here. You can see that. So far so good. So let's quickly begin with our worksheet. Now we are on the worksheet right now. So what was our first query? So our first query was to find the total number of flights in a day. So for that, we have a simple step. So basically we'll have a particular number of rows, right? For the dataset what we've selected, we will have some thousands of datasets. So each and every row is actually a flight. So what we will do is just create a calculated field and just name it as number of rows. Okay, since we are trying to calculate the total number of flights, let's kind of not name it as rows. Instead we'll name it as flights, and inside the calculated field just write 1 and it should be done. So you can see the number of flights just over here. Just hover down the text and we'll have the number over here. So this is the total number of flights per day which takes off from the San Francisco airport. Let's kind of increase the text size so that it's a bit more visible. Yeah, that should be it. Let's rename the sheet. From here I would do the renaming from here because it's a little simple. Total number of flights. Yeah, that should be it. Now let's get on to the presentation mode again. Now let's execute the second query. Find the busiest day at San Francisco airport. So to execute the second query, let's just simply duplicate the sheet and rename the sheet as busiest. Okay, we can actually schedules of flights, or no, not schedules of flights, number of flights, or we can rename this as flights taking off. So when we get the count of flights taking off, then we can actually find the date which was really busy, like the date with the maximum amount of flights taking off. That would be the busiest day. So the data type is date by default. That's great. Now let's drag it to columns. Now the sum of numbers at this place. Analysis, let's uncheck this to get a map. Let's make it by month or day. Okay, we don't need this. We don't need this. We don't need this as well. Now we have a chart over here. Let's change it to scatterplot maybe. Yeah, so we have the chart. No worries on the scatterplot thing. It's really a scatterplot. No worries on that. So right now we need to find out the busiest days. So for that we might want to drag the date into filter and let's select the individual dates. Select next, and inside the top we have the we need to select by field, and now we have the top 10 number of flights. We need the top 10 flights. So let's select apply. We needed top 1, but why not top 10? You will select top 10 for that. Now we have the scatterplot on my sheet right now. So let's kind of arrange it in the descending order. This shows the highest number of flights, or okay, we need to change this value to sum. Yeah, it is sum. So yeah, I got to know where we made a mistake. So inside analysis, we were supposed to aggregate the measures so that we can get the sum of number of flights. Now we have the total number of flights. Now let's quickly arrange this. Now we have the 3,166, 3,200, 3,295. Yeah, so 3,295 happens to be our busiest day in the year 2020, that is the 6th March, which had the maximum number of flights taking off. So we can actually make a set of these. The set of these, which happens to be in the March. So March happens to be the busiest month for San Francisco Airport. So with that, we have finished the second query. Now let's create a new sheet for our third query. Let's get back to the presentation. And the third query reads that, what are the total number of flights per day in a month? So for that, let's get back to Tableau. Let's try to rename it total flights in a month. Done. So for that, let's select date and drag it to columns, and let's make it to month. Let's remove this. Let's remove this. Let's remove this as well. Now let's check it to day, and now number of flights. So automatically we have a line chart, and we have the flights taking off from March 1st to March 31st, which happens to be the busiest month for San Francisco Airport. Now let's just tick the show mark label so that we have the number of flights taking off every day. So as we got the result in the previous sheet, 3,295 flights on the date of 6th March, or is it 3rd March maybe? Yeah, that happened 6th March. That happened to be the busiest day of San Francisco Airport. Now let's get back to the presentation and check the fourth query. So the fourth query reads, what are the top 10 busiest flight routes? For that, let's get back to Tableau again. Let's rename the newly created sheet busiest routes. Now the sheet is being replaced or renamed. Now to find out the top busiest routes, we need a calculated field to remove the effects of San Francisco Airport first. So create a calculated field, and we can name it as busiest route, busy. And now inside the calculated field, we need an if condition. Then if route 1 split 1 is equals to SFO, then route 2 split 2 else route 1. And yeah, the calculation is valid. Let's apply and OK. Now we have the newly created calculated field somewhere here. I will drag that into rows, and now we'll drag the number of flights to columns. So there we go. We have the bar chart over here. Let's rearrange it in descending order so that we get the descending order. Now we needed the top 10 or top busiest routes. For that, let's drag busy into filters, select top, and by field we have top 10. Let's just select apply and OK, and we have the top busiest routes from San Francisco Airport, or SFO. Now let's get back to the presentation mode, and in the presentation mode the next query is which are the top longest flight routes from SFO. So to find out the longest routes, we'll create a new sheet and rename it as longest routes. Yeah, the sheet is renamed, and you can see that we have geometric coordinates 0, 0, 0, 1, 1, 0 and 1, 1. So these 1, 1 and 1, 0 coordinates basically provide the origin information, and 0, 0 and 0, 1 provide the destination information. So we'll be creating a calculated field for that. Now let's create a calculated field. So let's rename the calculated field as origin, and inside the origin we'll make use of make point, and inside make point we'll write geometry coordinates 1, 1 and geometry coordinates we'll need the geometry coordinates 1, 1 and geometry coordinates 1, 0 separated by comma, and done. So we have the origin. Now let's create another for destination. We are creating a calculated field destination, and inside destination we are going to use the same make point and geometric coordinates 0, 0 comma geometric coordinates 0, 1, and select apply. OK. Now the origin and destination are created. Now we need to create another calculated field for distance. So we'll write it as distance, and inside that we'll use the distance function, and we'll write origin comma destination, and we'll represent the distance using kilometers. And select apply. OK. Now we have the newly created distance measure in the measure section. Now we'll drag the busy into columns and distance into rows. Okay, we made something. Oh, there's no problem. We can actually change the orientation. And now let's rearrange it in the form of descending order. Now we have the distance sorted in the descending order, but there is a small change. We have to change the sum to average. So once you change that, you want to arrange it again. Now we have the BLR, Bangalore, as the farthest airport from SFO. Yeah. Now we might want to drag the busy into filters again. Now we have the top 10, apply. Okay, so we have the top 10 longest routes from SFO. So with that we have finished our 5th query. Let's get back to presentation mode, and the 6th query. Represent the flights flying outside SFO towards different parts of the world. Yeah, that can be done. Let's get back to Tableau again. Now for the 6th query, let's create a new sheet. Let's name it as map flights from SFO. Okay, so for that let's select the latitude and longitude and select a map. So we have the map right here. Now let's change that to map. Yeah, it's in the map section by default. Let's create a calculated field called lines. So we are basically using lines to represent the flights taking off from SFO. So I'll name it as line, or we can name it as flights line. Okay, and inside the calculated field, let's type in make line, and so inside the field, let's make use of make line function, and inside that let's write an origin and separated by comma destination, and the calculation is valid. Apply OK. Now we have the newly created flight line over here. Now we'll drag that flight line to detail. Now once we drag that flight line to the detail, we have the lines or flights taking off from SFO to different parts of the world. Now we can make it look a bit more appealing or more informative by dragging the routes, or into detail. So we have the details of routes, and we can even drag the distance into detail. So when we hover over to the line, we'll have the route and the distance as well. Yeah, so that's how it is done. Now we're basically done with all the queries. Now let's create a dashboard. So now let's kind of arrange the dashboard size convenient to our monitor. So I'll increase it to 1320 width and decrease the height to 760. So that's the proper size what I was looking for. Now we'll drag the details into the sheet. Longest routes. We have the flights taking off, busiest routes, longest routes, and total flights into here. Now it looks more readable. Fine, so we have the busiest routes, we have the longest routes, we have the flights taking off in the month of March. The busiest month was the March, and the busiest day was 6th of March. I don't know what was so special on that day. If you know it, please let me know in the comment section below. And yeah, so totally we created a dashboard. Now let's rename the dashboard as SFO flight data dashboard, and we are done. So we're done with the second project. Now let's get back to our presentation and let's check the last project, that happens to be the space missions dataset. So now we are in the third project, which is based on space missions dataset. So using this particular dataset, we're going to get some insights which are based on the queries on my screen right now. So we're going to find out what are the average temperature details of the launch sites, what are the average wind speed details of the launch sites, what are the average humidity details of the launch sites. So we need all these to before launching a satellite or a rocket into space. Everything needs to be in ideal condition. So followed by that, we have what are the different varieties of launch vehicles used by different companies. So there are a lot many companies. Few are from government sector, few are from private sector. For example, USA military satellites belong to government, and private satellites like SpaceX, and few others. Next we have what is the mission status of the company. So we have a list of satellites launched already, right? So we need the mission status of that particular satellite. Is it a successful launch, or was there some failure record or something like that? Next, at the last query, we have the track records of launch sites. So what are the track records? So what are the successful launches? What are the failure launches? What are the satellites launched by different companies, etc., etc. We'll have a complete track record of that, of all the launch sites which are available in our data set. Now without further ado, let's get back to Tableau and start the project. So we are on Tableau. Now we're going to extract the data set. So the data set we need is the space missions data set. You can get this in the Kaggle, or you can even have the access to this data set from the description box below. Select open to open the data. So yeah, the data got successfully loaded. Again, use the interpreter, and it's a good habit of using the interpreter to clean your data and make everything understandable or look understandable. Show all the answers, everything is fine. So we're good to go with the dataset what we have in our Tableau right now. Now with that, let's get back to the first sheet. Now let's check the first query that we have in our presentation. What are the average temperature details of launch sites? So for that, let's create a new sheet. Yeah, it's created. Rename it as AVG temperatures. Or launch site temperatures. So now we need the launch site and select the temperature and hover over to the show me tab, and let's select the bubbles chart. So now you can see the temperature is in the sum, but we don't need the sum here. We need to change that to average. Now we have the average temperatures of the launch sites. Now let's kind of select the label show marks here. So we can do one more thing. We can drag the temperature onto the label. Now we have the temperature here. Now let's again change the measure to average. Now we have the average temperatures of the launch sites in Fahrenheit. Yeah, that's pretty well. Now let's get back to the presentation, and the next query is what are the average wind speed details of the launch sites. Let's get back to Tableau again. Let's create a new sheet, launch site wind speeds. Now let's drag the launch site into columns and wind speed from measures into rows, and you can see automatically we have a bar chart, but to make it a little bit more readable, let's select the boxes and whiskers chart. Yeah, you know what to do now. Go to analysis, uncheck the aggregate measures options, and let's drag the launch site again onto columns. Now we have the different box and whiskers for different sites. So let's kind of arrange it. Yeah, so the wind speeds at Kennedy Space Center are here, 20 miles, and 23 at Vandenberg, and Marshall at 9. Yeah, so this is the wind speeds at different launch sites. Now let's get back to the presentation mode, and now we have to find the humidity details of launch sites. So let's get back to Tableau. Now we are back on Tableau. Let's rename it humidity launch site. Now let's select the launch site and humidity, then a pie chart. The pie chart is really small, so we can select the entire view. Now we have the sum of humidity, but we need the average humidity. And now let's drag humidity onto label and launch site to label. Now we have the detailed humidity. No, we need to select the measure to average again, and here to average again. Yeah, so we have the humidity percentage of launch sites on the pie chart over here. So with that we are done. Now let's get back to presentation again. Now our fourth query, which states that what are the different varieties of launch vehicles used by different companies. For that, let's get back to Tableau. Now let's create a new sheet. Launch vehicle details. Yeah. Now this query is pretty straightforward. Select company and vehicle type, and we should be done. So there we go, we have the company name and vehicles used for the launching of satellites process. Now let's get back to the presentation mode. Let's select the next query. What is the mission status of companies? Now let's get back to Tableau. Let's create a new sheet and rename it as mission status. Now we are back on Tableau. Now let's select the company, drag that to columns, and mission status to columns, and we'll select one parameter from measures so that we can get a good bar chart, side-by-side bar chart. And now we can drag the company to color so that we can have different colors for different companies. So we have the mission details. So SpaceX found a maximum success in the recent days and little failures, and yeah, Boeing found good success as well and some failures. So these are the mission status of different companies and different satellites as well. So we have even US Air Force here faced some satellites here, some failures in some satellites. It's okay. So now let's get back to presentation mode. Now the sixth query is track records of launch sites. Okay, we had the payload as sum, so we change it to count, distinct count. So now we have a better observation of failures and successes over here. So as we discussed in the sixth query, now we need to find the track records of launch sites. Now let's create a new sheet, rename it as track records. And now let's drag the company to columns and mission status to columns again. And now let's drag the launch site. Yeah, I think we might want to drag the mission status to rows. Yeah. Let's click on text. Now let's drag the space missions count to color and space mission count to labels. Now let's use this one. Yeah. Now we have the stats or the track records of different space centers or launch sites, and we have the failures and success rates over here. Yeah, so basically we have done the last sheet or last query executed. Now let's create a new dashboard. As we always do, change the resolution according to the monitor we have. So I'm going to use 1030p. And height as 760. Now let's drag the sheets. So we have the launch temperatures, launch wind speeds, and launch site humidity at one place. Now the launch vehicles used, mission status, and the track records. So we'll kind of drag it here, and this one over here, this little bit over here, and this one over here. So now we can actually, select the track records of Cape Carnival. We have the site temperature, we have the site humidity, we have the site wind speed, and the track records of that particular site, and launch vehicles launched, mission status, everything on one single dashboard. So that's how you make use of dashboards in real time.
Today we'll be going over answers to common interview questions for Tableau positions. First question is, what are the data types supported in Tableau? We have string, date, date and time, numerical, Boolean, so true or false, and geographical. In Tableau, you can tell what kind of data type you have. So when you're on the data source tab, you can see that this is numerical and this is string. Here we have a date. We don't have any date times here. That would have the little clock icon. And we also have geographical. These are set by default, and you can change them by clicking on the icon. And say we wanted row ID to allow text, so we'll change it to string. And you can see the icon changes there. The next question has to do with how well you understand dimensions and measures. So a key thing to remember is that dimensions are qualitative and measures are quantitative. And if you can remember those particular words, it helps convey what the interviewer is looking for. So dimensions are qualitative, and you can use them to categorize your data. So for example, you can categorize your data by what country it comes from. And measures are quantitative and can be aggregated. So you can do a sum of sales, or you can do the average profit. Did you know that Tableau automatically assigns each field a data type and a role, and that it automatically aggregates your measures using sum? But you can change what the default aggregation is. Question 3. What do you understand by discrete and continuous in Tableau? So we have discrete values and continuous values. Discrete is represented as blue and continuous is represented as green. So let's look in Tableau. When we go to our worksheet, you can see that all of the dimensions are automatically blue and all of the measures are green. However, you can have a continuous dimension and you can have a discrete measure. So we have discrete dimensions, which is a blue dimension, but also continuous dimensions, and date is a good example of that. Let's take a look. So we pull on order date. We right now have year, and it's making categories instead of a continuous axis, so it's making a finite list there. But we can change it to be, you can see now it's marked as continuous here, and it's green, and we can change it to be an axis. Instead of different categories, it would be a continuous axis. So you can also have discrete measures, which are blue measures, and continuous measures in the green. So for example, let's say we had a visualization that had the region and sales and profit. But instead of having an axis for profit, maybe we just wanted to have a number for the profit listed right next to the region, and then we could have the sales visualization. So what we could do is change it to a discrete value and put it next to region, and now it's part of the labels. And that's an example of having a discrete measure. Did you know that continuous is infinite and discrete is finite? Those are some key words that you could use also to describe the difference between continuous and discrete. And also just remember that discrete is blue and continuous is green. The next question, number 4, is what are filters? And name the different filters in Tableau. So filters are a way to restrict the data that allows you to only see the data that you want to see in your workbook or dashboard. And there are these different types of filters, and they also have a specific order. So if you can remember the different filters, that's helpful. But also if you can remember what order they apply in, that'll get you some definite bonus points in your interview. We have extract filters that filter the data as it extracts, and it will affect how big your extract is. We also have data source filters here, which will filter the data out of the data source. However, the extract will still be the same size. So let's take a look at this handy visualization that Tableau has on their website. We have the order of operations, and in blue we have our filters. So extracts is first, and it filters down your extract to just what you've selected. Then we have data source filters that will apply to the entire data source. So any visualization that uses that data source will have these filters. We also have context filters, which are next, which come before some of these level of details. That's the major difference, is that it applies before some of these sets and conditional values. And then you will do dimensions and then measures. So any filters that happen on dimensions happen before any measure filters. The last type of filter we have is a table calculation filter, which happens after all of the rest of them, and basically just applies to your visualization, just the one visualization. Question number 5. There are 3 customer segments in the Superstore dataset. What % of the total profits is associated with the corporate segment? Perfect. So, in some Tableau interviews, you may be asked to build a visualization. For our examples here, we'll be using the Superstore dataset, and if you don't have access to the Superstore dataset, just comment below and somebody on the Simplilearn team will help you get access to that. Also, this is a fun opportunity to pause the video and then you can work on this on your own and then come back and see if what you did was the right thing or how we did it differently. Also, you can comment below on what your answer is and we'll see if we can all get the right thing. So let's build this. 3 customer segments in the Superstore dataset. What % of the total profits is associated with corporate segment? Great. So we're going to bring on our segments, and we have consumer, corporate, and home office. And let's bring on our total profit. So I just did that by double clicking. And now it's just bringing on the sum for each of those by default. But we want to figure out what % of the total each of these are. So we can change this to be a table calculation. We can click add table calculation, or we can do a quick table calculation and find % of total. So let's go back to our question. We wanted to know the % of total profits associated with the corporate segment. And the corporate segment has 32.12% of the total profits. And here's our solution with 32.12%. So did you get it right? Comment below if you got that. What are the different joins in Tableau? Give an example. So in Tableau, you can join your data. So if we wanted to look at orders and tie it to people, we can pull on people and it will give you this visualization and you can see all the different joins here and we'll discuss those in just a second. You also have the opportunity to union information, which would be if we had maybe 2 Excel sheets that had orders information. Perhaps one of them had 2012 and one of them had 2013. Then you could take your orders and pull it, so you see that pop up, drag table to union, and that's another way to add more data, and so those are all worth mentioning. Let's take a look at the different kinds of joins. We have our inner join, which will only give you the values that have matches in both tables. Our left join, that will give you all the values in the left table and its matches in the right table. And then the right join, which will give you all the values in the right table and its matches in the left table. The outer join, also known as a full outer join, will give you all the values in the left and the right table. And then as we discussed the union, you can see it's represented by a more vertical join, and what it does is it adds more rows. All the rest of these are about adding more columns, but this will add more rows in the same columns that you had before. If you have the opportunity to draw out the answer to this question and make these Venn diagrams, it's a really helpful way for you to explain your point, and it really portrays that you know what you're talking about. What is the difference between a join and blending in Tableau? So I just showed you how to make a join here, and we are joining an Excel sheet to another Excel sheet, all within the same connection to that Excel file. So when you're joining data, we'll look over here at the joining side, that's when you're bringing 2 or more tables within the same data source, and that's how you join it. And so we're all inside of a data source here, which, when I go to sheet 1, just has one data source here called orders, whatever we wanted to call it, and that is all within one data source. However, let's say we already had 2 different data sources in Tableau, and we wanted to bring together 2 of them. So in this case, it's an Oracle table, and we brought in an Oracle table and we made a data source, and then also an Excel table that had a second data source, and you can blend it together to get your combined data set. So the major difference, what you're going to really want to take away from this, is that blending is from 2 separate Tableau data sources, and that joining is all within one data source, and it ends up just being one data source in the end. In blending, each data source contains its own set of dimensions and measures, and when you join, it will combine it into one set of dimensions and measures. So let's go back to our example here. Let's bring on people. It is automatically said we're going to join it on region, and we're going to do an inner join. That's fine by me. And so we come here, and now we have just one set of dimension and measures under orders. However, if we were to add a second data source, which we will, it'll be an Excel file and it will be based off of this rank example. We'll open that up, and now when we go to sheet 1, we have 2 data sources. And if we were to blend this data together, we would still see 2 separate sets of data, only we would be able to pull in from this set some information, and we'd pull in from this set some other information. So that's a visual difference between blending and joining. Question number 8 is, what is the difference between a live and an extract? So first we'll talk about live, and we'll say that your dashboard is connected live to a database. And so a live connection will query that database every time you open up the dashboard or visualization, so that you're getting the most recent information each time. And it's useful for if you need information that's a little bit more real-time. However, it can be slower, especially if your queries are complicated. With an extract, it will run the query beforehand and store the information on Tableau server or on your local machine, and so that it's faster to get to. However, it is not real-time information. So if you had a refresh of your extract that runs every day in the morning, and then during the day somebody has made a change to your database, they won't see that change on your dashboard until the next time the refresh runs for your extract. In Tableau, you can set if you want the connection to be live or extract when you first are making your data source. And this is in Tableau Desktop. In Tableau Public, you don't have that option. Did you know that the reason that extracts are faster is because Tableau doesn't need to access the database each time it builds the visualization? And did you know that you can set up a refresh schedule on Tableau server in order to be able to see your extracted data update? Question 9. What is a calculated field and how will you create one? So if we look at our data set here, we have the opportunity to see the difference between order date and ship date. So to create a calculated field, you click Create Calculated Field with this drop-down arrow at the top, or you can right-click in white space, Create Calculated Field, then you give it a name, and we're going to call it Shipping Delay, and we are going to do a date diff. So if you don't see this dialog box here, you can click this arrow to see that. Our date part is day, the start date is order date, and the end date is ship date. So to remember how to create a calculated field, it's by clicking this down arrow and clicking Create Calculated Field, and then writing your query here. And a calculated field is an additional field made up using the data that you already have. So we've made a new field here, and it has the equal sign at the beginning. That might be worth mentioning, how to tell if it's a calculated field or if it was an original field. And then we can bring shipping delay here, and we can see the number of days that it took between the order date and the ship date. We could also duplicate a calculated field. So now we have shipping delay copy. And we're going to call this average shipping delay, and we're going to encapsulate it inside an average function. And now if we take off the order ID, the order date, and the ship date, it's automatically summing up those days, but we can bring on our average shipping delay. And you can see on average how many days it took. And let's change our number here to include decimal places. So a calculated field is a new field made from existing data. It can be used to create more robust visualizations, and it does not affect the original data set. For example, we made our average delay function here using data from our original data set. Question 10. How can you display top 5 and last 5 sales in the same view? You can show top 5 and last 5 sales for a same dimension by creating a set. So let's take a look at doing that here. We have our customers. So let's bring on customer name, and we're going to do it based on profit. So now that we've done it on profit, we can see these are our top 5 profit, and I've sorted it by profit. And here's our bottom 5. And we can create a set by coming and clicking on the dimension that we want the set to be based on. We'll right click there, and we will come to create and click set. And we're going to call this top customers. Top by field, top 5 by sum of profit. And now we have a set. It makes a set section here. Now we're going to make a second set off of customer name. Create set. Bottom customers. Bottom 5 by sum of profit. We'll hit OK. And now we're going to combine these two sets. So I'm going to control click, and then we have both of them selected. And we're going to click create combined set. Top and bottom customers. And we're going to have it include all members of both sets. And now we can pull top and bottom customers onto filters. And you can see our top 5 and our bottom 5. So if we control drag profit onto color, then it's colored by that as well. So key thing to remember is that you can use sets to create, to show both the top and the bottom in the same visualization, and that you can combine those sets. Is there a difference between sets and groups in Tableau? The answer to this is yes. You can describe a group as being simpler and using only one dimension to determine the group, whereas a set can be more complex. So you could say sets are more complex, and you can use conditions to create the sets, and you can also use multiple dimensions and measures to create the sets. For example, here we create a group of subcategory. So we grab all of these things together and can group it, and that will be, we'll have copiers and envelopes, and then we'll have one group of all of these together. Over here, you could create a set that looks at sales and profits to create a set. So the best way I can describe this is by looking at what we did here. And so we were able to use dynamic filtering here to create our sets, and where it will look at the top 5 or the bottom 5. And let's do the same thing we did there, but use a group. So for a group, we could see that these, we've sorted it, and we can say 1, 2, 3, 4, 5. This is the top 5. So we could create a group. That's this paperclip here. And now we have a group of the top 5. And it's added that group. It makes a new group, customer name group. And it put it on the color for us. Now let's go to the bottom. And we're going to go 1, 2, 3, 4, 5. And we'll create our group. So now we have a top 5 group, a bottom 5 group, so let's name them that. And we'll do that by clicking Edit Alias. Top customers. Okay, and we'll come here and we'll rename that. Bottom customers. Okay, and we'll put our top customers on top. And then let's hide all of the others. So we'll click Exclude there. And now we have a similar visualization as we had before for our sets. Top, bottom. However, a key difference here is that we had to go through and select the top 5 and the bottom 5. So let's say that maybe Cindy, or let's say Henry Goldwyn, has suddenly had much more positive profit associated with them. If that changes, he's going to still stay in our group. This group is just using these customer names to determine who's in the group. So the group is Henry, Sherelle, Luke, Grant, and Cindy, no matter if their data changes. So say tomorrow all of this data is different, it's still going to put these people into the group. However, the sets, as you saw before, is based off of the profit, the sum of profit, and who has the top 5 and who has the bottom 5. If Raymond suddenly has a lot less profit and falls out of the group, then the groups won't pick it up, but the sets will. So that's one thing to remember, is that it could be based on conditions. And then you saw how we took two sets and put them together into our combined group. You could also have a set that is based off of 2 different dimensions or 2 different measures, and that's how you could put those 2 sets together and get dynamic sets. So the major differences, as we saw, is that a group is just based off of 1 dimension, and a set can have conditions and be based off of other dimensions. Also, you need to know that groups cannot be used in calculated fields, but sets can. Question 12. What is a parameter in Tableau, and give an example? A parameter is a dynamic value that a customer could select, and you can use it to replace constant values in calculations, filters, and reference lines. So, for example, here we determined we wanted bottom 5 and top 5 customers, but let's give them some options. So we'll create a parameter, and we'll call it select number of top, bottom customers. And we're going to let it be a range with a minimum of 5 and a maximum of 20 and a step size of 5. So we'll let them go 5 at a time. Okay? Now if we click show parameter control, we can see our parameter control, and you can do 5, 10, 15, or 20. But since it's not in any of our calculated fields or sets or filters, then it's not making any difference. So let's put it inside of these. We'll edit our set, and instead of top or bottom 5, we'll click bottom, select number of top bottom customers. So now it's taking our parameter and inserting it in to our set there. We'll do the same thing with top customers. Okay, and now right now we see top 5, bottom 5. If we change it, now we see top 10, bottom 10, 15, and there's our 20. So it replaces a constant value and allows the end user to select the value. Question 13. What is the difference between tree maps and heat maps? So let's first talk about what each of these are. Heat maps compare categories using size and color. I think the biggest thing about heat maps is the color. Size is somewhat optional, so let's build this visualization quickly. So we have region, category, and subcategory. And we're making a heat map, so we want to bring profit onto color. And you can see we've got hotter and colder. In this case, for a heat map, we might want to change. So in this case, what it's doing is hotter is negative, but we could reverse that, and then hotter is positive. And so hotter maybe means this is where more activity is. We can also double click on profit. We can also bring profit onto label, and we'll change this to square, and now it's marked at what everything is. So a heat map will use color to draw your eye to the places where there's heat or maybe activity. We could also use size in this case. So it's not just defined by color necessarily. Maybe we want the size to be defined by sales. So we get things that are bigger but they're blue, which means that they are bigger in sales but their profit is negative. And it draws your eyes to technology. So machines in the South are doing a lot of sales, but they're not having positive profit necessarily. Also, you can see some things that have darker colors but are smaller. So high profit, but not a lot of sales. So that is a heat map. A tree map is used to represent hierarchical data. Now, hierarchy is the term you need to remember when you're talking about the difference between a tree map and a heat map. In the heat map, none of these boxes have to do with the hierarchy with each other. Whereas with a tree map, you can see that this box has a thick white line between it and the other ones. And that means that that section are all connected. So these are all technology. And the bigger this section is, that means the bigger the, size is based off of profit. So this bigger section means that technology has more profit than furniture. So let's build this one. When I build tree maps, I like to use our Show Me tool. So here's a tree map, and it says 1 or more dimensions or 1 to 2 measures. So we're going to grab category, and we're going to control-click subcategory, and we're going to control-click profit and sales. And we'll click on our tree map. Perfect. And so the darker the color, that means the more sales there is. And that's pretty similar to our heat map over here. So the color indicated, in this case it was profit. So the color indicates the difference and the size indicates the difference. And that's true over here. The color indicates a difference and the size indicates a difference. However, there is a hierarchy to it. Over here you can see that there is hierarchies because we have furniture, and then that puts that all together under furniture. And then here's the subcategories. However, if you were trying to compare furniture to office supplies, it's really difficult to tell which one has more sales. But if we go over to sheet 7 that has our tree map on it, you can see really quickly that office supplies has much more sales than furniture. In this case, office supplies has much more profit than furniture. The biggest difference is that tree maps have the hierarchy. Question number 14. What is the difference between TWBX and TWB? So these are all Tableau file formats, and the TWBX contains all of the necessary information to build a visualization. So it's called a packaged workbook, and it compresses it all together. However, the TWB just contains instructions about how to interact with the data source. So when it's building a visualization, Tableau will look at the data source and then build the visualization. With an extract, it contains all of the information that you need, so all of the data is wrapped up inside of there, and there's no connection that has to be made between Tableau and the data source because it's all right inside. Whereas with the TWB, it has to connect to the data source or else it doesn't have the data to build the visualizations. It just knows, it has the instructions of what to do with that data. So the biggest difference is TWBX has the data inside of it, whereas a TWB only has the instructions. Question 15. Explain the difference between Tableau Worksheet, Dashboard, Story, and Workbook. Perfect. Here's a breakdown and explanation of each of those. And in Tableau, this entire thing that we've been looking at, all of these sheets, is a workbook. However, this sheet 7 is just one worksheet. All of them together is a workbook, and sheet 7 is a worksheet. The big difference between worksheet and a dashboard is that the worksheet is just one visualization, and so it is only one set of columns and rows here. And a dashboard could contain multiple visualizations. So if we wanted to see our heat map and our tree map on the same page, that would be a dashboard. And then a story is somewhat similar to a presentation mode. And so you can have different pages. And so we could say here is our heat map. And then we could make another page and look at our tree map. And then look at our heat map. And then we could duplicate that page. And we could say, let's focus on furniture. So we're going to highlight furniture. And then, so if we were to go through these one at a time, we would say, here's our tree map, and then we would look at information there, and we would say, here's our heat map, and then the next screen we'll say, let's focus on furniture. And you can see that it highlighted furniture for me when I went to the next seat. So a story can show you things one at a time. It's like a presentation mode. So the differences are the workbook contains the sheets and the dashboards are the stories. The worksheet is a single view, dashboard is multiple views, and a story is a sequence. A sequence is a good keyword to remember when you're describing a story. And did you know that the only place that you can access the dimensions and the measures and custom fields we've made is on a worksheet? So when you're looking at a dashboard, so on a worksheet we see dimensions and measures. When you're looking at a dashboard, you no longer see dimensions and measures. What you do see are all of the worksheets. Similarly, when you look at a story, you no longer see any dimensions and measures, but you do see all the worksheets and the dashboards. Question 16. What do you understand by blended axis? With a blended axis, you can use two measures that share an axis, and that means they necessarily have the same scale. So let's build something with a blended axis. So we can make a visualization that looks at sales over time. We'll bring on order date. And let's just do order date by month. There we go. So we can see sales over time. And say we wanted to also see profit. This is two visualizations that have two different axes. But if we wanted them to have the same axes and just the same marks card, you see how I made two different marks cards? We could bring on measure values and take off all the measures that we don't want. We just want. When we take them off here, it's creating this filter here for measure names. And let's take off these two extra visualizations. And now we have a visualization that has a blended axes for sales over time and profit over time. And you can see that they necessarily have the same axes. There is no second axis. What is the use of a dual axis? And how do you create one? Perfect. So a dual axis allows you to compare measures and you can have two different scales. So if we had this same visualization, that same information that we wanted to see with, again, profit and sales over time, we'll do, okay, great. And we wanted them to have the same axes. We could right click on the second pill of the measures and click dual axis. And now you can see that they do not share the same axis, and you can see profit is much higher here, right there. And so the use of this would be, sometimes you need things to have different axes. If you come here and you click synchronize axes, you end up getting a pretty similar visualization, but you do get two separate marks cards. So a key thing to bring up if you are asked the difference between a blended axis and a dual axis chart is, one, that the blended axis uses the same scale and a dual axis could have two different scales. And two, a dual axis has two marks cards. So let's say we wanted our profit to not be a line chart, but to be a bar chart. That gives you that option. When you go to the blended axis, we only have one marks card, so we change it to bar, everything is bar. But back over here, we change it to circles, and we see the circles. So if we wanted to show sales by year and profit ratio by year in the same view, that's where two different scales could be handy. Let's build that visualization. So we'll make a new chart, and we'll bring on sales and profit ratio over time. That is profit. I still did profit, so I'll drag profit ratio right over top of profit. There we go. And you can see that they can't use the same scale because this is a percentage, and so if we had them on a blended axis, 20% is really 0.2, and it would just be so tiny. But if we wanted them on the same area to apply to the same space here, we could dual axis it. That you can still see useful information there. But otherwise, this would just be in such a tiny, tiny space. So our profit ratio would just show up right here, almost like a straight line. Question 18. What will the following function return? Left 3, Tableau. Here's the question again, and here are the potential answers. Tab, or EAU, error, or none of the above. So just take a moment and see if you can answer this question correctly. Go ahead and pause the video, and if you get the answer, you can comment below, and then we will discuss. We've taken some time to answer this question, and let's go ahead and see what the answer is. The answer is it will return an error. That's because the syntax for left is that the string must go first. First you say left, then you put the string, and then you put the number. So let's talk about what left does. It returns a specific number of characters from the left, and if you had done it correctly, the left is this side. So if you had done the string first and you said you want 3, the result would be TAB. There's also one called right, and that would come from the other end and go EAU. So that's where these answers came from. Question 19. How do you handle null and other special values? Tableau is unable to plot null values or zeros or negative values on a logarithmic axis. And so it will display an indicator in the lower right corner, which looks like this, telling you that it is unable to draw those 2 points. So when you click on the indicator, you can choose from the following. First, you can choose to filter the data, which will exclude the null values from the visualization, or you can click Show Data at the Default Position. So we'll look at both of these. So you click on your indicator and it will say, what do you want to do with these 2 values? If we click Filter the Data, then you can see that it has filtered that blank space and drawn a line connecting those dates in between. Even though there is no point for the 29th or the 30th, it goes straight from the 28th to the 31st. So what's happening on our visualization is it's adding this filter. If we press the back button, we see that filter disappears. If we come down and select Filter the Data, it adds a filter here that then only includes non-null values. So those are all removed from our visualization. And up to this point, you can see that we have 1 point per day, the 21st, the 22nd, the 23rd, the 24th. But then when we get to the 28th, we don't have a 29th or 30th, and it just draws that line to the 31st. Assuming that during that time period, what we want is a straight line. Now the other option would be, we could also make the assumption that whenever there is a null value, that actually means 0 sales have happened during that time. So that's when you would click Show Data at Default Position. And now it draws those 2 points at the 0 line. And when you hover, it still shows sales null. So, and when you hover here, you can see the actual amount for sales during that time. So if a null in your data means 0, then Show at Default Position is good for you. And if it doesn't necessarily mean 0, then you can filter the data, or you can leave it disconnected like this. Question 20. Find the top product subcategories by sales within each delivery method. Which subcategory is ranked number 2 for first class ship mode? If you'd like to pause the video and work on this on your own and then see if what you did matches what we did, then you're welcome to now at this time, and comment below what your answer is. Okay. So we want to know by subcategory and by ship mode which subcategory ranks the highest for each ship mode. So in sales. So if we take sales onto the visualization, we can see that by the ship mode, it's already split up, and we could see that maybe this one for standard class, it would be chairs. You can kind of look through and kind of, oh, it's not chairs. Chairs isn't number 1 because we have this one, it's phones. So to make it easier, we're going to change sum of sales to a rank table calculation. So we're going to come here and click Add Table Calculation. And we're going to change the calculation type to rank. And it's going to rank them in order of sales. So, but right now, we can see that it's highlighting. That's called Calculation Assistance, helping us understand how it's ranking us. So if I unselect Calculation Assistance, then it gets rid of it. But you can see right now, it's ranking it across the table. So it says accessories has most sales in standard class, then second class, then first class, then same day. And that's not what we want to see. We want to see it up and down. We want to see for first class which subcategory has the highest sales and second highest sales. So let's turn back on our calculation assistance, and we're going to click table down. And you can see now it's going up and down. Within first class, what are all the subcategories ranked? So that's what we want. Now, as soon as you click things in the table calculation, it applies it over here, so you don't have an OK button. So you can just close that out. And you can see now we have a rank up and down for the subcategory. So back to the question, was which subcategory is ranked second for first class ship mode? Here's first class. Let's find number 2. It's chairs. Question number 21. Find the customer with the lowest overall profit. What is his/her profit ratio? Let's go ahead and build this visualization. Customer profit. And we're going to bring all of our customers on. And then we're going to bring on profit. Let's do it as a visualization, so I'll bring it on to columns. And then let's sort smallest to biggest. So Cindy Stewart is the one who has our lowest profit. And now to figure out her profit ratio, we need to make a calculated field, which I've already made here. So in this calculated field, we take the sum of profit and divide it by the sum of sales. We do this so that it will sum up all of the profit per row. So for Cindy, we want to take all of her profit over all of her transactions and divide it by all of her sales, instead of doing it row by row, profit divided by sales, and then summing that up at the end. So we'll take our profit ratio and put it on the label, and we can see what her profit ratio is. And since it's a ratio, here I have it in a percent. If you don't have your profit ratio set up as a percent, it will look like this, negative 1.65. Question number 22. What is the rank function in Tableau? We got a look at the rank function earlier when we figured out our top product subcategories by sales and what was rank number 2. So I'm sure you're familiar with what ranking is, which is assigning something a position like first place or second place, usually within a category and usually based on a measure. So Tableau is able to rank in several different ways, where you can do rank or rank dense, rank modified, or rank unique. And we'll take a look at these in a visualization here and talk about the difference. But if you are asked about the rank function in Tableau, it's worth bringing up that there are several different ways to rank, and going into a little bit of detail on those different ways will be helpful for you. So let's build off of this rank example instead. So we're going to bring on our store, and we've got store A, B, C, D, and E. And then we'll bring on our sales. And store A had $10 and E had $40. So now let's create a calculated field. We're going to call it rank. We're going to do a rank calculated field based on sales. We're going to do a rank calculated field based on sum of sales. Perfect. Okay. We'll double click on rank, and we can see first place is the one who had the most sales, and fifth place is the one with the least sales. Now, we had a tie here at 20, and it gave them both third place, and then it skipped fourth place and went to fifth place. And that's how the basic rank function works. So if we duplicate it, and we edit our copy, and we're going to make this one rank dense. You know what? Let's do rank modified second. Okay. And we bring on rank modified. Let's have this happen in order. So sum of sales, then rank modified. Now you can see it's similar to rank first, second, but then it skips third and goes to fourth, and then fifth. So over here it gave them a higher number when there was a tie, and over here it gave them the lower number when there was a tie. So if you could remember that rank gives them the higher number and rank modified gives them the lower number, that will be helpful for your interview. Now we're going to take a look at rank dense. Rank dense, apply. And rank dense doesn't skip a number. So it goes 1, 2, 3, 4, and it condenses the ranking without skipping any numbers. And now let's do our last one, which is going to be rank unique. Okay. And with rank unique, it refuses to give two the same rank. And how it determines when there is a tie is it will look at the dimension that's in the visualization and do whichever one comes first in ASCII. So it goes 1, 2, and these are a tie, and since capital B comes before lowercase c, then it's doing B first, then C, then A. So in your interview, it would be really impressive to talk about the different versions of ranks and how they all work. Question 23. How can you embed a web page in a dashboard? So we're just going to build this and then explain it. So I have here my map by sales, and we're going to build a dashboard. We'll bring on, first we'll change our layout so I can fill up the screen. Then let's bring on my map. And I've added the state name and the sales on the map here. For an embedded web page, you can grab it from the objects section, the web page, and then you could put a URL right inside of here, and then that will embed that page underneath. So if we wanted to do Wikipedia or something, we can hit OK, and it will take you to Wikipedia. But what we're going to do is make this page dynamic based on what state you select. It'll look up that Wikipedia page for that state, so you could maybe look at some population data. We'll close that, and we'll try again. We're going to bring on our web page. It's going to ask for a URL, but we're just going to hit OK and not provide it with a URL. And then we'll use this dashboard action and create a URL action that then contains our URL with our state appended at the end, which is how Wikipedia formats their URL. So we'll hit OK. Oh, I forgot one more thing. Let's do it on select instead of on menu, so whenever we select something, it will run this. OK, OK, and now when we select Texas, it brings up the Texas Wikipedia page. When we select Nebraska, it'll change. So the major points to know on how to embed a web page is you bring it in from the objects section, and then if they ask how to make it dynamic, you use dashboard actions and a URL action. Question 24. Design a view to show region-wide profit and sales. So one way you could do this is by bringing on region and then bringing on profit and sales. And that's a pretty simple view of profit and sales by region. However, one thing that interviewers may be looking for when asking a question about region is your mapping capabilities in Tableau. So what we could do is, region is not a geographic location, so it takes a little bit of creativity, but if you bring on state by double clicking it and it maps out the states, you can make it a map here and it fills it in, and then you can bring region onto color and that splits it up by region. And then if you bring on profit and sales on the labels, and let's also bring on the state onto labels. And then you can look at your profit and sales inside of their regions, inside of their states. And so that is another view where you could look at profit and sales by region. And it's a little bit more, takes advantage of some of the mapping capabilities in Tableau. It may be what your interviewer is looking for. So you could discuss multiple ways to look at it. But here is one way that we could recommend it. Question 25. How can you optimize the performance of a dashboard? There are multiple ways to optimize the performance of the dashboard. Some of the things that you might mention is that you could exclude any fields you're not using from your visualization, just keep them off, or you can use extract filters, and if you recall, extract filters will remove out rows of data from the extract, and so only focus on the data that you need. Another thing you can do is try and limit the amount of filters that you use. And when you do use filters, avoid using quick filters, and you can use action filters and parameter filters instead. Filters cause your queries in the database to be a little bit more complex and can keep them from running as efficiently as they could. Use min and max instead of average, because average functions require more processing time than min and max. Also, you can try to use Boolean and numerical calculations because computers do better with integers and Booleans than they do with strings. So quick things to remember is keep your data simple, use fewer filters, and when you do use filters, use parameters or actions. Avoid using average, use min and max. and avoid using strings by using booleans and numerical calculations. Question 26. Which visualization will be used in the given scenarios? Here we have 3 scenarios of opportunities that you might want to visualize, and there is no perfectly exact answer for these, but there are some visualizations that tend better for certain types of data. However, there sometimes could be different ways to visualize it, and it doesn't mean that these are the very best ways. However, if you want to take a moment, go ahead and pause the video and go through and figure out what your 3 answers are and comment below, and we can discuss what we think the best ways are. So first we want to show aggregated sales totals across a range of product categories and subcategories. We want to show the duration of events or activities, and we want to show quarter-wise profit growth. So to show aggregated sales totals across a range of products, subcategories, and categories, you could use a tree map. The reason we bring up a tree map here is that they are known for allowing you to show a visualization using hierarchies. So let's take a look at that. We're going to show aggregated sales totals across a range of product categories and subcategories. So if we come here and make a sheet, and we want to see sales across control click category and subcategory, and then we click a tree map, what happens, it's showing it based on size and color. And so it shows the size, the bigger the size, the more sales, and the darker the color, the more sales. And the reason we choose a tree map over just a normal heat map is that it makes a category here. So we can compare this box that has all the technology in it, see how all of these are technology, to this box that has all of the office supplies. And you can quickly see that technology has more than office supplies, but you can also see that phones has more than art. And it breaks it up as a hierarchy and breaks it up based on your sum of sales. And question 2 is show duration or events, a duration of events or activities. And you would use a Gantt chart. Gantt charts are used to show duration. And each of these lines is a duration. So it's like it's got a start date and an end date basically. And it shows you how long everything takes. And the last one is to show profit growth. And you can use a waterfall chart. And that looks like this, where you can see how the profit changes across every period and if it's going up or down, and each one of these show you how much up or how much down they go. But as we said, there are potentially other answers to this question, so if you have any questions about why we didn't say this chart or that chart, go ahead and comment below and we can start a discussion. Question 27. What would you do if some countries or provinces or any geographical entity is missing and displaying a null when you use map view? So when you start to map the geographical fields that you have, sometimes Tableau is unable to map them because their locations are unknown or ambiguous, meaning a lot of states have a city called Springfield, and it won't know where to draw that city. So for example, let's look at here. So we've taken city as our detail, and it's drawn a lot of cities. However, it's got a lot of unknown values here. So if this question comes up, you've got to remember these 3 things. You can edit locations, filter the data, or show data at default position. Edit locations allows you to correct the locations by putting in their unique names. We'll show you an example of this. Filter the data means just keep them off of the view, and show data at default position means show it at 0, 0 on the map. So edit locations. Here we can say, here's all of these cities that seem to exist in multiple locations, and we could say, well, we know what state they're in as well, and that should help you answer the question. So you could choose a field that will define the state. So here we're saying the state is from the state field, and we hit OK, and then it can draw the rest of those cities. Sometimes you want to keep them off. Perhaps maybe they spelled city names wrong, and you just want to exclude those. And the last one is show data at default position, which is 0, 0. 28. What is a level of detail expression? A level of detail expression, or an LOD expression, is maybe the way they will present it to you. And LOD stands for level of detail. So obviously it helps you get to the level of detail that you want in your visualization, but it also is used to run complex queries at the data source level instead of all in the Tableau interface. So we're going to take a look at an example here, which is adding a dimension to an already calculated aggregate field. In our case, we're going to exclude a dimension from a calculated field. So here we have a visualization that I built, and right now it's just looking at sales by category and subcategory, but say we wanted to look at the total sales for furniture and not break it up by the subcategory. So if we take off subcategory, then we get the total sales for furniture. But if we want a side by side, and so that you can see the total sales for furniture and you can see it broken up by subcategory, you can use a level of detail calculation. This, I already made the field for it. I've called it exclude subcategory, so that's right here. Right now it just contains sales, but we're going to use the level of detail calculation exclude, and we're going to tell it what to exclude, which is subcategory, and then we're going to do sum of sales so that it will sum it up for us. And once I apply these changes, it should change it here and our labels. Perfect. So now we can see that it's ignoring the fact that this is chairs and this is tables and this is bookcases. It's just doing the total for furniture and just ignoring these because we told it to exclude. So level of detail helps you to be able to define the level that you want to in your visualization, regardless of what else exists on your visualization. It also moves some of the logic from inside of Tableau to the actual database. And there are 3 level of detail calculations. This will be an important thing to bring up in interviews. They might give you brownie points when you can remember all 3 of the level of detail calculations, which are, we looked at exclude, but we have exclude, include, and fixed. So include, exclude are pretty easy to remember, and just always remember fixed as well. Question 29. How do you calculate daily profit measure using level of detail? Here's another opportunity for you to pause the video and take a look at calculating a daily profit measure using level of detail. We are going to get started. Profitable level of detail. So we want to have a daily profit measure, and I already made a place for it, profit per day. And we want to look at the profit for a day regardless of what else is on the visualization. So we're going to use a fixed instead of an include or an exclude, which will only take into account whatever you put in for include or exclude. Fixed will take into account everything. It will ignore everything else on the visualization and only look at what's in your list here. So we're going to fix it by day. And you have to put a colon. And we're going to do a sum of profit for each of those days. And close it off. So now we have our profit per day. And we'll hit OK. And now we're going to make a KPI, which for our purposes, if profit for a day is greater than 2,000, then that day is highly profitable. If it's less than 0, then it's unprofitable. Otherwise, it is profitable. So we're going to go if our profit per day is greater than 2,000, then we're going to call it highly profitable. Else if we're going to do less than or equal to 0, then profitable. Else, otherwise it is profitable. You always have to end with an end. Great. Okay. So now we're going to make some visualizations, and it's going to look at it by year. Now it all fits in one view. We can rotate these labels to make it easier to see. And we're going to bring on order ID. But now it's showing like a lot of orders. And so we actually want it to be used as a measure, and we're going to do a count distinct. Great. So now we can see how many orders were on each day. And so that's helpful for us to see how many orders are on this day each day, but we want to see the orders on each day that are highly profitable versus unprofitable versus just profitable. So we're going to use our level of detail and break it up into different sections. So we have highly profitable, profitable, and unprofitable. Let's also bring this onto our color. Highly profitable, profitable, unprofitable. And now we can see that the profitable ones are going up. Unprofitable ones seem to be going down in 2015, and that's nice, but they are going up. And highly profitable is not very many. Oh, in this case we did area charts instead of just line charts. To make that change, you change it from automatic to area, and that helps you see some of that spatially as well. Comment below if you were able to make this visualization on your own. Question 30. How can you schedule a workbook in Tableau after publishing it? So when you publish a workbook in Tableau, if you've used an extract, you're going to need to refresh that extract. So in Tableau, when you create a Tableau data source and it's an extract version of the data source, it will no longer update if the data from your database updates. So somebody's made some changes to your database or your Excel file, and you want to see that in your Tableau visualization. Well, you're not going to see it, but you can see it if you make a refresh. So you do that on Tableau server, and you can remember that you have to get all the way to your data source. So you can go to your data sources or to your workbooks, and then you look at the data source on your workbook, and you go Actions, Extract, Refresh. And then you select Schedule a Refresh, so that looks like this. You can press these three dots next to it and click Refresh Extracts, or you can go to Actions, and then here you click Schedule a Refresh instead of Refresh Now. And then oftentimes in Tableau you'll have several different options. You can choose daily at 7 a.m. or every 4 hours. If an interviewer is asking you about how to schedule a refresh, it might be worthwhile bringing up the fact that you only need to schedule a refresh if you are using an extract on your data source, and then that will help them know that you know the difference between live and extracts if they didn't ever ask that question.
With that, we have come to the end of this session on Tableau Full Course. If you have any queries related to the topics covered in this full course, then please feel free to let us know in the comment section below. Our team of experts will be happy to resolve your queries. Until next time, thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.